Data science and any data-inspired and data-driven science is so critical right now. More and more decisions are made based on data. The amount of data that we gather every day and the insights that the data can provide us is just growing exponentially, and that is no exaggeration.
The market for data science and related areas like AI is booming.
It is so important to have women in artificial intelligence in the area of data science and also in leadership roles. It's being able to use data to solve issues and understand bigger problems. It's critical. And we need women in these roles. Every individual brings their own perspective. And so we need to make sure the entire workforce is represented.
And the good news is there's so many jobs and many different ways to combine their passion area and their skills in data science and get involved.
I would like you to say, what are the problems in the world that absolutely have to be changed? And, can you individually, given all the amazing background that you've had so far and all the education that you've got so far, what are the unique things that you can do to change the world towards that mission? And then think of the technology.
If that is going to become completely data-driven over time, then you can't miss that opportunity. You've got to join in and have your say.
If you're not looking at the data from all sorts of different angles, then you could introduce a lot of bias. So it's really, really important that we have around the table all genders, all races, all backgrounds.
We can't ignore social and structural problems. We can't just go in a corner and write some code and read math and then that's the solution, right? Can't do that. So we have to think about who is being affected by these algorithms.
Welcome to WiDS!
When we first started this conference, we never would have imagined that we'd be sitting here today with over 200 regional events. We've got over 500 WiDS ambassadors worldwide. Many of them are women, but we've also got a lot of men. And these are people who are just passionate about inspiring others within their community. We're in over 60 countries, and year after year, we're blown away.
Let's make this next decade the Women in the Data Science decade.
What I love about it is that growth is viral. That people will attend one event in one city and then they'll want to bring it to their cohort or colleagues the next year.
This type of industry can be done everywhere, so it should be accessible to everybody. And this is one of the reasons why I love that we are global with WiDS.
So we wanted to create opportunities for women to inspire, educate, and support women at many different times throughout the year. And one way that we decided we could do that was through a datathon every year, which is a predictive analytics challenge using real-world data. We have over 900 teams from 85 countries, and that's in every continent except Antarctica.
When we started WiDS in 2015, we had no idea this was going to be a global movement with tons of international events and a datathon and a podcast show and now outreach to middle school and high school. It's just been such a ride.
Our latest endeavor is to work on some materials that we can hand off to teachers in schools around the world.
This has provided a platform for literally hundreds of women, if not thousands of women, to have an opportunity to be heard.
But the truth is, these are really simple experiments, but they had profound impact because they empowered someone else to be able to do their job better or to be able to take that message.
5 years ago, when we were sitting around a coffee table thinking about what WiDS could be, I never in my wildest dreams thought it would grow so far and so wide around the world in just 5 years. What I'm most excited about is the next 5 years, because I think this is really just the start.
A very good morning to everyone. I hope all of you are safe and healthy. This was the video of the Conference of WIDS in Stanford University, and here we are today organizing WIDS Mysuru, an independent event to coincide with annual Global Women in Data Science Conference held at Stanford University and an estimated 150 plus locations worldwide. All genders are invited to attend WIDS regional events, which celebrate, appreciate, and glorifies women doing extraordinary work across the globe. So this WIDS event is organized by Ms. Usha Rengaraju. She is India's first women Kaggle Grandmaster. She takes a strong initiative to organize and conduct talks and events that you come across on this channel. You can get in touch with her on Twitter at her handle, that is @urengaraju. She leads over 8 communities in Bangalore and Mysuru. To name a few, these are GDG Mysuru, WTM Mysuru, TFUG Mysuru, and the list goes on and on. She plays an essential role in making these events an absolute success. WIDS Mysuru is organized in collaboration with 4 major universities, namely NIE Mysuru, VVCE, JSS, and GSSS. Each university has its own organizing team. This is the organizing team for JSS Mysuru, NIE Mysuru, VVCE, and GSSS. The organizers of these teams have played a huge role and they have supported us. Here is the core team of WiDS Mysuru, a team which works with its utmost determination and dedication in making these events a huge success. This team has done it all, from designing, marketing to anchoring, under the guidance of Ms. Usha Rengaraju. We constantly organize such events every month, and you can keep yourself updated by connecting with us on our meetup pages. The links to the same are put up in the description below. So now let's start our event. Now I'm going to hand over the session to my co-anchor, Shashank. So Shashank, over to you.
Thank you, Nitya. A very good afternoon to one and all present here for this event. And let's start off with our first speaker, that is Ms. Kalika Bali. She is a principal researcher at Microsoft, and today she's going to be talking about the ethics of building language technology for a social impact.
Good afternoon, everyone. I am Kalika Bali from Microsoft Research India. I'm a researcher who works in the area of language and speech technology. And today I'm going to talk about the ethics of building language technology for social impact. Before we go any further, I think it is important for us to first understand what exactly we mean by ethics. This definition by the Ethics Centre Australia talks about how ethics is firmly rooted in 3 main concepts: values, the things we strive for and seek to protect; principles, how we achieve our values; and the purpose that gives life to the values and principles. To what end are we doing something? So, in short, it is about doing the good and the right things as a means of being. All that is still fine, but you may still ask, what does technology and data have to do with ethics? Well, technology, and especially the data we build it on, touches on some very crucial aspects of ethics. For example, privacy and security. Our lives are fairly exposed by the multitude of data generating activities that we engage in via technology, and inconsistent and weakly enforced data regulations and policies can have detrimental effects on our privacy, not only in terms of our reputations, but also in terms of our economic and emotional well-being. And as socio-technical systems are increasingly deployed in a number of public services scenarios like finance, e-governance, education, etc., we need to concern ourselves with biases that may be implicit or even explicit in such data set, resulting in sampling errors, falsehoods, and ultimately discriminatory practices. And this, of course, means that transparency, or the ability to see how such socio-technical systems work, and provide us some autonomy over decisions that affect our lives. For example, if a bank denies my loan application, then I should be able to have a transparent access to the information on why exactly was I denied the loan. And this then gives me some idea of what I can change to be successful. Now, this is very crucial as we deploy more and more complex machine learning based algorithms in such scenarios, because what happens is that certain algorithmic decisions are so complex and so work in a very black box manner that they cannot even be explained by the humans. For example, the bank officials or even the engineers who built the system cannot tell us why this happened or why this decision was taken. This is also tightly tied with the notion of inclusive AI or artificial intelligence, where we have to ensure that the systems that we build do not enhance the existing biases or social inequity through the use of artificial intelligence. And we can do this through ensuring non-biased data and algorithms. Everyone has equal access to AI technology, understanding what the impact is on vulnerable social groups, and also insisting on an inclusive governance of AI. Inclusive AI, therefore, exists at the intersection of algorithms, data, and the users of technology. And we have to worry about all of them if we are interested in inclusion and ethics of the systems that are built on top of data. Now, let me come to the language part of the talk. And I would just like to put out some facts for you there. And hopefully you'll be able to make the connection to this slide with the rest of the talk that I'm going to give. So 6 out of the 20 most spoken languages in the world are Indian. There are over 7,000 living languages in the world, and only 100 odd languages are supported by technology. And let me explain this better by taking two examples, one of a language like Dutch and one of another language like Somali. Now, if you look at the number of speakers that both Dutch and Somali have, you will see that, that's a pretty substantial population. But if you think of the kind of data resources that are available, language resources that are available, you will see that, Dutch has a far larger data resources associated with it than Somali. And then if you then start looking at the kind of language technology systems that are available, you will find that Dutch actually has state-of-the-art translation systems, whereas Somali has very inferior translation systems. And this will become clear by taking this example of the tiger moved across the grass from English. When it is translated to Dutch, we get this Dutch sentence, and then we translate it back to English using machine translation systems. We get the tiger moved across the grass. Now, the actual Somali system is so bad that when you translate the tiger moved across the grass using a Somali empty system, you get a sentence in Somali, and then when you translate it back into English, you actually get beans moved on grass, which is obviously not correct. So this shows the quality of systems that we have for Somali. If we look at these languages represented in the top tier conferences in the area, we also find that these disparities exist even at the conference levels. And as a community, we do know that these disparities exist, but nobody really knows, how much and what kind, etc. So the quantification of such disparity has not been done before. And we did some work around this and tried to break up this bigger problem into, these 5 specific questions to try to understand what is the fate of these different languages and how does it change with current language technologies. To get an idea of the status of the digital resources for these languages, we decided to construct a language taxonomy where on, the x-axis, we have all the label data that is available in places like Linguistic Data Consortia or the European Language Resources Association's map, etc. And on the y-axis, we put all the unlabeled data that may be available, like Wikipedia pages, which are the primary source of pre-training language models. Based on this analysis, we found that all these languages cluster themselves very neatly into 6 groups from 0 to 5. So as you can see here, the green group on the graph are the left behinds. These are the languages which has absolutely no resources associated with them. They have no digital data sets that we can use to build technologies. And on the other end of the spectrum, we have the winners, which is languages like English and French, which have not only got like the maximum number of resources, but also have state-of-the-art language technology available to the users of these languages, right? Essentially means is that there's a large chunk of population of this world, around 1/6 of the world's population, that has no access to technology in their own languages, right? And almost 88% of the languages in the world have no technology available to them. So that's like a huge population which is bereft of this advances in artificial intelligence, in data based systems, that a lot of us who belong to the upper edge of the spectrum, in languages like in groups like 3, 4, and 5, just almost take it for granted, right? So in Microsoft Research Labs India, we work on a project called Project Ellora, where we are very focused on enabling languages with low resources associated with them. So how can we enable people and communities who speak these languages, and what kind of methodologies and techniques are required to build systems where resources are constrained, but we want to enable the people through these technologies. And this is something that we can do through 3 ways. One is by concentrating on data, look at new approaches and community-based efforts. Data is what is lacking in these languages, so that, building of technology is hampered. And we can't really wait for the speakers of this language to kind of create enough Wikipedia pages so that then we go ahead and build technologies on top of it. So we have to kind of look at new ways and encourage the community to create its own data sets for the purpose of technology building. The second way is, of course, techniques. Can we bootstrap existing models? Are there new models and algorithms that allow us to build technologies in resource constraint settings? And the third is through application, trying to understand which are the verticals which have the most social impact, which are these underserved communities which can benefit the most from certain applications. So going from an application-driven approach rather than a technology-driven approach. So this is a good time for me to, say something that I'm very fond of saying in a lot of my talks, which is that sometimes as technologists, we forget that who are these people we are creating technologies for? The focus of any technology should be the users who are going to use that technology. And this is especially true for NLP-based systems. As Snowbillen said while summarizing this workshop on ethics in NLP, that the L in NLP is language, and language means people. So when we are building NLP systems, NLP-based applications, what we have to do is that look for NLP to assist people, right? We have to identify who the stakeholders are in this technology, and then design the technology in such a way that it supports the stakeholders' values. So now I will talk about a use case of a project that we did under Project Ellora that kind of shows a possible way of building local language technology in an ethical manner, right, for social impact. So we work with our collaborators CGNet Swara. Now, CGNet Swara is a not-for-profit organization, and what they do is they work in the tribal regions of Chhattisgarh mainly with people who speak Gondi. And this was founded by Bill Thies and Shubhranshu Chaudhary, and essentially what CGNet Swara does is that it makes local stories accessible through mobile phones, and there's also like a moderator interface that allows for annotation and editing to then post it on their um, web portal. But mostly local people access CGNet Swara through their mobile phones. So the population that CGNet Swara caters to speaks a language called Gondi. Now, Gondi is a very interesting language. It actually is a Dravidian language, which means it's related to the South Indian languages. But it exists in very close contact to many of the North Indian languages as well, especially Uriya, Marathi, and Hindi. So it is spoken by nearly 3 million people in this country, and in the states of Chhattisgarh, Andhra, Orissa, Maharashtra, and Karnataka. It has its own script, but nobody really uses it. What has happened historically is that because this was spoken by a tribal population, when the states were created, the population got, you know, subsumed by dominant populations of the state. And so Gondi in Chhattisgarh, for instance, is written in Devanagari. In Karnataka, it's written in Kannada script. And in Andhra, it's written in Telugu script. So it's heavily influenced by the dominant state language. The important thing here is that there's absolutely no technology support for Gondi. Gondi is one of the group 0 languages. But the community itself is amazingly motivated to do something about this. So when we started, collaborating with CGNet Swara to build language technology or think about building language technology for Gondi, the very first thing that we did was to call a workshop, organize a workshop to brainstorm on what possible technology applications will have the maximum social impact. And to do this, we involved all the stakeholders and experts. So we had people from CGNet Swara, we had technologists and researchers from Microsoft Research Labs, as well as Microsoft, other organizations in Microsoft. We had Gondi speakers and community leaders from the Gondi-speaking population. We had experts from various academic institutions, and we had one of our other collaborators, Pratham Books, which is a not-for-profit organization that works on creating children's books in as many languages as possible. So one of the first things that we heard from the community was that how they would like to have books, story books for the children of the community in their own language. Right now, there are schools in, say, the areas in the villages in Bastar, but most of them teach in Hindi. The teachers who are there are Hindi speakers. The entire school curriculum is in Hindi, and there's absolutely nothing available for the children in their own language. And this is where Pratham stepped in, and we had like a 4-way collaboration between Pratham Books, Microsoft Research, CGNet Swara, and IIIT Naya Raipur, where we got around 20 volunteers from the community, and then they stayed there for 10 days at IIIT Naya Raipur, and a facilitator from Pratham Books came and trained them on how to use their interface and how to do these translations from Hindi storybooks into Gondi. And for the first time ever, there were 206 storybooks that were printed and distributed to the children in Bastar village. And, that was just an amazing experience that happened, and it was all it all came from the stakeholders, from the people who would be affected by this, from them. Of course, one very positive side effect of this entire project was that we were finally able to create some resource for Gondi. We actually had a digital resource available for Gondi that could be used as a seed for building technology. As these books were translated digitally on the Storyweaver platform from Hindi to Gondi. For the first time ever, we had Hindi Gondi parallel data that could be used as a potential seed data to create a machine translation system maybe between Hindi and Gondi. So another very interesting thing that happened was that one of our young researchers got very inspired by his interaction with the community during the workshop, and he very quickly put together a prototype by creating a text-to-speech synthesis system for Gondi by bootstrapping a existing Hindi system and putting together a mobile app called Adivasi Radio, which became like a one-stop news app for Gondi. So any material that was available in Gondi through Wire or through CG Netswara or the Pratham books could be accessed through this app, and people could either read it or they could even listen to it via the TTS system. Now he created this prototype, and another student at IIIT Naya Raipur got inspired by this, and he took it up and built a full-fledged Android app that went out and was released to the community for the use of the community. Now, another very interesting thing happened then. So the community, they started looking at this and they started thinking about what to do, and they used this app to create translation data. So, a word would be displayed in Hindi or a sentence would be displayed in Hindi, and they would type it out in Gondi. And by doing this, we were able to collect nearly 30,000 sentence data for Hindi and Gondi. So in the end, I hope through this talk, I've been able to show you how a more ethical approach towards building technology, especially for the left behind populations, of speakers of low resource languages, can enable these communities to have a more equitable participation in the digital societies. And to do this, we have to take various approaches, some of them probably unconventional. It's not the conventional route of putting things together the way we do in typical database system building. But all of this involves those three things that we started with. What are the values that we are trying to preserve? What are the principles that allow us to achieve our values? And what is the purpose of doing this? So if we keep these in mind, we would be able to stay on the path of building systems in an ethical manner. And in the end, I would like to leave you with this thought from Lee Schlenker's article on the ethics of data science. If ethics is defined as shared values that help humanity differentiate right from wrong, the increasing digitalization of human activity shapes the very definitions of how we evaluate the world around us. Thank you.
Thank you so much, ma'am. That was a wonderful session. And moving on, we've got our next speaker lined up. That is Miss Vijay Mahadevan. She's a faculty scientist at Institute of Bioinformatics and Applied Biotechnology. And today she's going to be talking about data science methods on genomic data analysis. Over to you, ma'am.
Yes. Thank you very much, Shashank, for that kind introduction. I hope I'm audible to everybody.
Ma'am, can you be a little louder?
Can I?
Can you be a little louder?
Yeah. Am I audible now?
Yes, ma'am.
Okay. And I hope my screen is also shared. I have shared my screen, and is it on?
Yes, ma'am. It's visible.
Oh, okay. Okay. Thank you very much to the Women in Data Science Meet and the organizers for giving me this opportunity to interact. I've been watching this WIDS hosted by Usha and her team. It has been a fantastic organization with the volunteers doing a great service over the past few days and getting in touch with it. So, in short, I'm quite happy to be a part of this presentation. So, the topic that I chose to speak today is a topic that we are working on, particularly in terms of genomic medicine. That in the fact that we are involved in quite a bit of genomics, my lab at the Institute of Bioinformatics and Applied Biotechnology, IBAB, is working on epigenomics of diseases. We focus on colorectal cancer and breast cancer as a case, and also on neurodegenerative diseases with a particular focus on Parkinson's and a little in the neuropsychiatry in case of schizophrenia. So I thought it's quite interesting to talk about the use of genomics and how artificial intelligence and other data science methods are being applied for genomic medicine. If one goes back a decade earlier into the next slide, please. So if one goes back into, are you able to see my second slide now? Yes. So if one goes back into genomic sequencing costs, looking at from 2001, the genomic sequencing costs have reduced a lot compared to the several billions of dollars, the hundreds of billions of dollars we invested in 2001 to sequence a single human genome, to $300 million when we came out with the first draft. And when we finished it, we stopped at $115 million. But in an era like 2020, we are able to get a genome sequence even at a cost of less than $1,000. So why have the costs come down tremendously in this case is also because we have skipped many of the cloning steps in terms of inundated and improved technologies in genome sequencing. And these sequencing technologies have given us a very, very good, viable, accurate diagnosis of the genome as well as reduced cost. But when the cost reduces, what has happened is also the cost of the data analysis, which has improved. If you look at when I use the word genome, what do I refer to by a genome? I refer to the DNA sequence elements that constitute the genome, the information on the transcript, which is at the level of sequencing an RNA, the information called proteome, which is about the different proteins that build up the genome, the metabolome, the microbial composition, the microbiota inside our human body, the epigenome, which is influenced by external factors, the environmental factors, and the other exposures and the exposome. So there are multiple hidden layers. If I talk about genomic information, there are multiple layers I need to get. And today we have the capability to combine this with social graphs, the biosensors, the imaging through fMRI and other types of sensor-based imaging. And all these data have given us multiple opportunities to look at our genome. And personalized genome is actually evolving over the years as we started understanding the structure of the genomes, and then we began to understand the biology of the genomes. Then we used this genetic information to understand the biology of the disease as such. So once I understood the biology of the disease, can I go about understanding the science of the medicine? And can I tailor genomic-based medicine at a personalized level based on a mutation profile of a particular patient, based on the genomic buildup of a particular patient to predict whether this chemotherapeutic drug will be efficient or not, whether this particular drug can be delivered or not when it is not for generalized use. So genomics genomics has grown to an extent, and beyond 2020, we have quite a number of exciting opportunities to explore. But all this is on one side, the technology providing us all the capabilities to analyze and reach at the level of personalized medicine. But as one goes up, as the data, as the cost towards sequencing goes down, the cost towards interpreting the data from the human genome has increased over the years. It's a humongous task to apply genomic techniques, to apply bioinformatics methods to analyze the 3.3 billion bases of the genome that the human genome produces. So, if at all anybody wants to talk about big data, it is actually the genomics data which qualifies quite a bit. So if one looks into these, one sees that the statistics, quite a bit of statistics that goes into analysis of all these are very, very driven by several types of examples. There are complex decisions that go into these statistical methods. And remember, most of them are heuristic algorithms which define these things. Therefore, analysis using these statistical methods, sequencing is no longer the rate limiting step. But to understand the data and render the interpretation is a very big bioinformatics bottleneck because it goes on the limit of the human cognitive capacity, and one extends the decisions by integrating the genomic, transcriptomic, and other definition data. Therefore, it is a huge challenge given that the statistical methods applied to the genomic analysis through the bioinformatics tools are quite not sufficient to address this. So why should one go for AI? One of the main applications for AI, one of the main applications of genomics is to get a whole genomic application and look at the different variants that constitute a genome. If you start looking at the outer circle, the first analysis ends up with 3.5 million genomic variants, and I go down to analysis through different tools. I get into 11,000 coding variants and see a number of rare variants, and then I have only 10 to 20 that are segregated with respect to the disease. And finally, when I understand that there is one variant which is positive of that particular disease I am analyzing, I spend a lot of time and money in this effort. And particularly when we are going to do this type of modeling in tumor cells, particularly in tumor sequencing, when one does a tumor transcriptome sequencing, there is a limitation in terms of the generalizability and the complexity in tumor sequencing because of inherent biological factors like intratumoral heterogeneity between tumor and non-tumor cells present within the same tumor region. And when one has to detect the somatic mutations for all these, there are a variety of tools that bioinformatics has given us. Tools like Mutect, tools like Muse, Wear Detection, VARSCAN, Strelka, Somatic Sniper, and quite a handful of them. But are they able to detect these somatic mutations in this? Is not much with accuracy is the answer for this. So one relies on convolution neural networks to do this. So the Broad Institute in its corporate page has said this very beautifully, has summarized this, saying this generation has a historic opportunity and responsibility to transform medicine using systematic approaches and to accelerate in understanding the treatment of the disease. That is exactly why AI comes into the analysis of genomics. So I'm going to take you through one or two case studies in which the genomic AI follows exactly what the AIs do in other cases. The first example I'm giving is the traditional CNN approach, where one takes an input sample, divides it into several subsamples, and applies filter masks onto the subsamples. Build a feature map, apply the weights onto it, do the multiplication, and then sets up a classifier to classify as given in the example whether it's a car or not a car. One uses a similar approach to find out binding motifs on a genome, binding regions of certain binding regions on the genome, or certain regions which recur often and often on the genome called the recurrent motifs, for which what we see is the DNA sequence. We get several strips of like these subsamples. I take subdomains of this DNA regions. I apply filters onto these regions and then build up the feature maps to generate these motifs which are very recurrent across the genome. And then I would go into classifying whether it binds or not binds. And the CNNs in this case have shown very high accuracy. But between generating, between this, to distinguish between different regions of a genome, like an exon or a neutron, what would be more powerful is to use a recurrent neural networks. As one knows that what we show here is a bidirectional recurrent neural networks that reads an input and passes the hidden state in both the forward direction and the reverse direction in order to show this distinction that what I'm looking at is an intronic region or an exonic region which shows for coding regions of a DNA. So one clearly understands that these are very specific applications one looks at in the case of analyzing genomic data. But now AI is not just restricted to analyzing in different parts of the genome. As biomedical data is becoming more and more research intensive, and since medical diagnosis has always relied upon the doctor's specific judgment with limited amount of data, with a very personalized judgment, one doesn't see the effect of the information from molecular biology or biochemistry or genomics or other types of application applied mathematics or computer science to be applied for accurate diagnosis. Today's research has expanded into using AI and machine learning to detecting more of these variants in rare diseases, where the world is focusing more today, rare and orphan diseases, in neurodevelopmental disorders, in neurodegenerative diseases, in geriatric diseases. So these are areas which are quite the focus of the National Health Institutes of Health and the National Genome Health Research Institutes. And therefore, more of focus is being given on these areas. So if you look at this, the human genome was started at which time there was the functional MRI which was started to be used in humans. After we developed the first exome sequencing, where clinical sequencing and diagnosis was used in 2010, meanwhile, the neuroscience area grew up heavily to develop the human brain atlas. And after that, you saw a wealth of revolution coming up in terms of the invention of the CRISPR-Cas9 technology for genome editing and the release of the on-code data, which gave it was the encyclopedia of DNA elements, which was a huge data where deep learning showed enormous achievement in imaging. Then we had the evolution of the human proteome. Now the human cell atlas the work has begun and it's ongoing. There are several groups which are working across the world in order to decipher what components of the cell change with respect to different organs of the body, and they're mapping the entire cell atlas. With such huge challenge coming to us, the data cannot be analyzed by manual and bioinformatic tools. Therefore, it requires quite a lot of deep learning algorithms in order to also integrate them with the huge imaging data evolving out of these studies, particularly from the which are very intensively focused on energy these days. I would like to focus another case study on neurodevelopmental disorders, like the autistic spectral disorder or the epileptic disorder or the attention deficit hyperactivity, the obsessive compulsive disorder like abilities and intellectual abilities. In all these cases, what the traditional analysis does is to have a genome sequencing from families of these people. Our lab began to be involved in skeletal dysplasia of children, where we sequence the father, mother, the siblings, and the child because to see if there is a family trait involved, in which machine learning or a typical classification model will be very, very helpful. But let us always remember that in terms of incomplete penetrance, in terms of environmental factors which work on these, when the dosage is not balanced and when insignificant genes show up, normal analysis using bioinformatics do not help at all. This requires involvement using convolution neural networks. And also, what we identify through genomics are genotypic disorders. Can I correlate this with phenotypic correlation? Can I take imaging data from the children? Can I have their behavioral data and then correlate? Are there multiple genes involved in this? Can I generate a polygenic risk score, which are now also being generated, but the use of CNNs will be very, very useful in all these cases, which are being heavily used across the world also. And there was a very systematic study on schizophrenia between twins. These are monozygotic discordant twins, where one of them showed high schizophrenic properties, but the others did not show the variant towards schizophrenia. So, towards such cases, recurrent neural networks, primarily CNNs, are being used here. And later, if you look at what has been happening in the world in recent times, there are cell line based studies from human cells, from brain organoids, and from mouse in order to characterize these genetic mutations that have been shown in these genomic studies. And in order to get a biomarker, a risk based biomarker, or a drug target, or a drug based development, these are very, very considered, very, very important for diagnosis. Therefore, machine learning is considered quite an important, quite an important application towards these things. So, with the advent of these data, and what do people do towards using these machine learning? There are many cases, even in the diagnosis of Parkinson's disease, where people have used the retinal scans as a diagnosis to identify the neurodegenerative patterns, to predict early onset of Parkinson's or Alzheimer's, and to use also visual and use the slur in the speech, the audio processing and the video processing to predict the early onset of neurodegenerative diseases. But combining them with genomic data, particularly in case of Parkinson's, where the brain cannot be invasive, can one use the data generated from genomics? People draw blood and get peripheral blood mononuclear cells, convert them into induced pluripotent stem cells, and the stem cells are later differentiated into specific neurons, which are sequenced using genomics, and then the phenotype that one observes in the imaging data is combined with the genotypic data from genotypic data obtained by these experiments, because our lab is particularly interested in doing epigenetic biomarker studies in Parkinson's also. So, what one hopes for in terms of genomic data analysis is to use a lot of CNN-based deep learning approaches and also combine them with image approaches in order to get a genotype trials in humans. The other application where we use it heavily is to use it in drug discovery process also, where people have used quite a bit of artificial intelligence and machine learning. Therefore, tomorrow's medical world will be a hybrid of these technologies obtained from genomic data, from imaging data, from other electronic health record data, and to build a robust system for healthcare management in which the genomic data analysis using AI will be a great application to look for in healthcare. With this, I would like to complete my talk, and I would like to take questions if they are allowed. Thank you very much.
Thank you so much, ma'am. That was a wonderful session.
Thank you.
Thank you. So moving on, we've got the next speaker of today, that is Ms. Ujjwala Musku, and she's a data scientist at MIQ Digital, and today she's here with us and she's going to be talking about supply path optimization in video advertising.
Hi guys, I'm Ujjwala and I work as a data scientist in MIQ. So today the topic is supply path optimization in video advertising landscape. So before going ahead with the problem statement, I would like to give a quick overview of what MIQ does as a company. So we are programmatic media partners. We use marketing intelligence to connect data and discover insights, which in turn helps with the high performance campaigns. So in short, we basically run campaigns for advertisers so that they can gain high performance there. So programmatic industry is pretty huge. You can see that the digital marketing spend in 2019 is almost higher than 50% out of overall marketing spend in 2019. And the estimated growth of digital marketing is also pretty huge. It's almost 61% in the next 4 years. Now coming to the agenda of today's talk. So first is going to be programmatic advertising introduction. So I would like to give a quick overview of programmatic advertising as well as video advertising so that you can connect to the problem statement well. Then coming up with the approach and then how the results work. Now, coming to programmatic advertising. So let's first talk about what exactly is advertising. So it's basically making a product or a service known to audience, right? This can be done in multiple ways. One is print media, which is basically showing ad on newspapers, TV ads, radio, and out of home, which is basically the billboards. And then there is digital marketing. Let's talk a little bit more about digital marketing. So digital marketing is marketing done through digital channels. What exactly are digital channels here? First could be search and then followed by social media. Then there is email. Then there is something called as programmatic. So MIQ fits here in programmatic. Now, what exactly happens in programmatic media advertising? So I would like to explain the whole process here. So this process is called as real-time bidding. When a user visits any web page, there could be multiple ad slots available. So this information is being communicated to the ad marketplace by the website owners, saying that there is an ad which can be shown. Now, real-time auction occurs where multiple advertisers try to compete between each other and whoever bids highest wins. So this highest bidder gets to show his ad on the particular web page. So this whole process happens when the particular website is being loaded. You can clearly see that this happens in like few milliseconds, right? So we deal with pretty huge data, which is like 20 terabytes generated daily. Now coming to video advertising. So video advertising also follows the same part, which is real-time bidding. Here also when you're probably watching some video on YouTube, you might see video ads sometimes in the start, sometimes in the middle, sometimes in the end, right? So again, same real-time bidding occurs where multiple advertisers compete with each other and the person whoever bids highest wins. Now, within this process of whole real-time bidding, there are multiple players in the market. So there is a seller trying to sell, there is a buyer trying to buy. There are other third-party places which try to resell the whole ad slot. So there are multiple players in the picture. So this is why it is going to take. There are multiple paths to basically reach a particular ad slot. Now let's connect it to the challenges. So first of all, let's talk about one set of challenge, which is limited inventory. If you compare to the digital display advertising, which is the static ads you see on the websites, we in video compared to display, we have very small, very limited inventory. Now, since it is limited, the demand is pretty huge and hence it is costlier. Now, this is one set of challenge. There is another set of challenge because of multiple players in the market. So because of multiple players, the auction duplication happens and it is getting worse day by day. It is said that on an average, an impression, a particular ad is available through 19.8 distinct supply paths. So there is already this problem. And now the particular certain deals between demand side and supply side is making the already existing worsen problem even more worse. Now our goal is to basically, out of all those paths, we'll have to make sure that we are choosing the right path. So now when I say right path, it's basically the path which is cheap, and hence that means the low cost, which is low CPM, low cost per 1,000 impressions. And the second important thing is it needs to have higher quality, which is higher performance. So how is performance measured? Let's say when I'm probably, let's say I have shown some video ad. If I'm really interested in the product, I would probably watch the whole video. If I'm not, I'll probably pause it in first few seconds, right? So that is exactly how video performance is measured. The number of completions divided by the number of ads shown. So this is the performance part. So a good choice of a path is basically which is cheap as well as high performance. We are not compromising on the quality here. So since this whole process happens like in milliseconds, we would want some ML algorithm which can basically block few paths or maybe highlight few paths saying this you can basically bid through this path. So yeah, this is the whole problem definition. Our goal is to basically achieve or rank the paths. Now, if you take this particular example here, to get a particular ad slot, there are three ways this DSP can attain. One is through SSP3, which is the costliest. One is through SSP1, which is the least. So instead of going ahead with, if I have a chance to deliver $2, why would I go ahead with $5, right? So yeah, my ML algorithm should basically block this SSP3 path and maybe go ahead with SSP1 or SSP2. That is the whole problem definition. Now coming into the approach, I would like to give a detailed explanation of the whole approach here. So first is the data source, which is video feed. So out of all the video ads we show, which MIK shows, there is a data feed for each of those ads shown. There is an entry for each of the ads shown. So we have the raw form here, and data aggregation happens at this end, as in we pick up the features which are important and which is in a good format so that it can be accepted by the machine learning approach. So here we pick up the features, different features here are multiple players in the market, followed by the metrics, which is video completion rate, the cost spent, etc. Now the first step is obviously the outlier treatment. We need to filter out the entries which are not useful to us and which are not helping us give good accuracy. So outlier treatment changes according to problem statement to problem statement. So in our problem statement, we wanted to remove the entries which are delivering very low. as in the lower 5% of the quartile we are removing, because the trend observed in this to compare to other is pretty much different, and hence it is hindering with the whole process of accuracy. So that is the reason we went ahead with deleting the lower 5% quartile of impression delivery, as well as the lower quartile of the CPM, cost filtering. Now, the next step is data envelopment analysis. So what exactly is data envelopment analysis? So it's a non-parametric method that is used to rank unsupervised data. So when I say unsupervised data, the data which doesn't have any flag of saying good or bad. Yeah. So in our case, we just have the different key performance indicators, but we don't have any good or bad flag. So yeah, this method basically gives you the rank of the unsupervised data. How exactly does it do it? It calculates the efficiency values, which ranges between 0 to 1. Now, when we saw the results of this, we observed that there are two issues which are happening. So the data envelopment analysis was not enough. So what are the issues for this? The first is the significance of each player in the market is not being taken into account. So in the data envelopment analysis, we are only dealing with the metrics, which is video completion rate, the number of ads delivered, the cost spent. So all the numerical data stuff is being considered in data envelopment analysis, but nothing of a significance of a player in the market, which is really important to us. So that is not being done in data envelopment analysis. And the other thing is, usually most of the paths range, the delivery of the range is usually in similar, as in like probably there could be hundreds of paths which are probably delivering within the range of 1,000 to 1,000 to 1,100 impressions. So similarly, the video completion rate is also like a fraction, which is completes divided by the overall ad slots. The number there is also very, very constricted range. So that is the reason we were getting a lot of efficiencies in the same value. So that is why we did not want to go ahead with the data envelopment analysis, because the results were okay but not great. That is when scoring methodology using classification modeling came into the picture. So here, this particular process, this particular technique gives you the significance of each and every player, along with it also handles the second part, which data envelopment analysis was not able to handle. That is, it was giving distinct scores for the distinct paths. So yeah, so how exactly are we using scoring methodology here? We'll get into the depth of data envelopment analysis and scoring methodology in the next 2 slides. But yeah, I would just like to complete the whole flow chart first. So once we have this whole, once we get done with this technique, we'll have a score certain to each of these paths. So according to the score, we decide whether if the score is higher, it is basically good. If the score is lower, it is basically bad. So that's how we go ahead with the bidding process. Now comes the next. So yeah, I would like to explain a little more about data envelopment analysis, which is, so you can see the graph here, right? You basically plot all the supply paths using inputs and outputs as the axis. Now you can clearly see that there is an outer frontier, right? So this A, B, C, D are basically the supply paths, all these dots including R and S. So the outer frontier which is forming here has the higher efficiencies. So all these efficiencies will be 1, and all the other parts are encapsulated within this particular frontier. So you can see there is R and S. So how do we calculate the efficiencies of all the others? So you basically project from the origin to the outer frontier through that particular supply paths. Then you kind of take a ratio between the OR dash divided by OR to get the efficiency of this. So that is how the efficiency of all the other supply paths is being done. Now, once this is done, you basically get the efficiency values. You can clearly see that there is a range of efficiency values, and there are a lot of ones. So this output is being acted as an input for the scoring methodology. So from the behavior of the data and according to the domain knowledge, we have seen that anything above 0.5 is okay to very good path. Anything below 0.5 is very bad to these bad path. So that is the reason where like all the paths above zero point 0.5 efficiency are being flagged as 1, which is good. All the paths which are being flagged as below 0.5 are being 0. So that means which is bad. Now this acts as an input to the scoring classification modeling process. So there are multiple paths which this particular scoring methodology takes place. So first is binning. We use equal width binning here, which is followed by weight of evidence and information value calculation. Information value calculation basically tells us which particular predictor to choose within the modeling. And then we pick those particular features and then go ahead with logistic regression to come up with the coefficients. Once we have the coefficients, we go ahead and calculate the logit values, odds, the probability calculation, the factor, and the offset. Then we give a minimum and a maximum score, and then we the score calculation happens using all these particular values. By the end of this whole process, you can see that there is a, for each of the feature, you could see a particular score attained to it. And finally, you get the final output from each of these scores. For each of the player in each of the path has a score, and all of these are summed together to get this particular value. So obviously the path A is better here because it has a higher score. Path Q is bad here because it has a lower score. Now coming to the results part, we have tested this methodology in almost 10 live campaigns within MIQ, and we could see almost 6 to 12% reduction in the cost per 1,000 impressions in CTV and video campaigns, which is pretty huge because there are a lot of campaigns running and 12% on one campaign is huge. And we could also see the increase in the video completion rate, which from 1 to 4%. And the overall success rate is 8 out of those 10 advertisers, because we definitely could see the reduction in cost in all those 10. But there were 2 campaigns where there was a slight decrease in the video completion rate. So putting both the KPIs into the picture, that is the reason overall success rate is 8 out of those 10 advertisers. Since we are targeting only specific paths, we could see there is a drop in delivery of ads. So we are tackling that by adding the outside of campaign data, which is the network inventory supply paths to it. So yeah, overall this technique worked pretty well in video campaigns, and we are going to scale it for other kind of campaigns as well, because this auction duplication and supply path optimization happens in a lot of other places within digital advertising. So yeah, that's it, guys. Thanks a lot.
Thank you so much, ma'am. That was a wonderful session. And moving on, we've got our next speaker, that is Miss Abhinaya Mahendran. She's an assistant manager at Next Lab Emphasis, and today she's going to be talking about demystifying MLOps.
Hi everyone. In this session, I'll be talking about the basics of MLOps. Before I get into the topic, I would like to introduce myself. My name is Abhinaya Mahendran. I currently work as an assistant manager for the data science team at Emphasis Next Labs. I work for BFSI clients and I build AML solutions specifically focusing on NLP and NLU. Here is the agenda. We'll be looking at software development lifecycle, what is DevOps, and how ML projects are actually different from software projects, and how we can leverage DevOps in an ML project setting. What are all the basic principles that build the MLOps platform, and what kind of open source frameworks you have out there that you can leverage when you are planning to build your own MLOps platform. To start with, let's look at software projects. As you all know, it starts with the requirement analysis. Once we know the requirements, we design the system architecture and we start building the features. Once the development is done, the software goes through a lot of testing. Once everything is passed, the tested software is deployed, and the deployed software will be maintained through a maintenance cycle, wherein new feature requests might come, or requests for bug fixes might come. Then it goes through the same cycle of designing, development, testing, and deployment. The only thing that you have to remember here is that code is the only artifact that you have to maintain throughout all the phases. And data is used only during testing, and no other phases uses data as such. To make faster deployment and shorten the development life cycle, DevOps came into picture. DevOps is basically a software engineering paradigm which has continuous integration and continuous deployment pipelines. The main aim is to reduce the development cycle, increase the deployment velocity, and make the releases very dependable. So you will only get the stable version of your software deployed in production. So this is something that most of us might be using in our day-to-day work. When it comes to ML projects, it's quite unique because here we need to maintain 3 dimensions. One is code, one is data, the other one is model. You start with understanding the business objective. Once that is done, you start acquiring data, because data is not something that is readily available. Once you get the data, it has to be transformed to the required format, and the data scientist will perform analysis on the data and start building the model. Model building is also an iterative process, and the best model is the result of a lot of experimentation. You have your own metric that is very problem specific. Not just that, you also have other KPIs that has to be met by the model to make that the best model. The only catch here is the quality of the model in production might degrade over time, because there might be differences in the data that you have in production and the data that you have trained your model on. So that is something that specifically happens in an ML project. And another unique thing about ML project is that data is part of several phases. It is not just used in testing like we have seen in the software projects. So keeping this in mind, how do we actually incorporate the DevOps principles? It just like this. So you have several phases in a machine learning project, and you also have some phases that involve the operations work where you deploy the software and everything. So you combine both. So that is basically your ML ops platform. It should have several components in place. So these are all some of the phases that an ML ops pipeline should have. So you start with model building. You basically write your code, you train your model, and you come up with the candidate model. So here you have to maintain all 3 dimensions. So you will have the candidate models in place, and once that is done, you basically evaluate the model and you test it on the test data, and you get the metrics of the several models that you have built during the model building phase. The best model is chosen based on the metric. The metric can be very specific to your problem as well as the KPI. So based on that, you choose your best model. Once that is done, you productionize the model and you test it on like pre-production data. Like it's not exactly the live data, but it is also a subset of your test data. Once that testing is done, you deploy that final model in your application, and the application will be exposed to the end user. Once the end user starts using it, the model is actually working on the production data. So there might be some differences between the trained data and the production data. So if the changes so much, then you will have to have a pipeline to kind of retrain your model or update your model. So these are some of the business decisions that you have to make, and these are all the components that you have to take care of throughout the machine learning lifecycle. So here, if you see code, data, and model, it has to be maintained throughout the phases. So your MLOps platform should have such features in place. These are all the specific technical debts that you have to handle in ML projects. So you will have, like we have seen earlier, at different phases you will have several configurations that needs to be maintained with respect to your model parameters, maybe your infrastructure configurations, your data configurations, etc. has to be maintained. So that has to be handled in an ML project. Then the major thing that you will be doing is your data collection and data verification. So that forms the major part of any ML project. Once that is done, you have to handle all your feature extraction process as well as your resource management, because for training you might need a different environment, but for productionizing your model you might need a different environment, and the resource requirement might be different. You will have to choose what kind of tools you will use to analyze your data or your infrastructure. You should also have some workflow management or process management tools to automate several components that can be automated in this setting. You also have to take care of the serving infrastructure. You have to make sure that your application is scalable, your model can handle millions of requests, etc. So such kind of items should also be handled in an ML project. And on top of it, you should have a monitoring module in place which will kind of monitor the quality of the productionized model over time. If you see all of this, ML code is basically a small part of it. So building a model is not a big thing. You will have to actually take care of several things apart from building code. So these are some of the debts that you have to handle in an ML project. So any ML platform that you are going to use or going to build should address all of the technical debts that we have seen in the past, in the previous slide. So for example, ML ops platform should provide good auditability mechanism. So you should be able to version and track all of your data, your model, and the code artifacts using some metadata store or model registry, etc. It should also provide a way for easy collaboration among people. So if 10 people are working on an ML project, they should be able to easily collaborate and figure out what the other person has done, so that they don't repeat the same experiments again and again. So this feature is very important because it makes a data scientist's job easier. The platform should also provide a feature for testing. So the testing not just includes your traditional unit testing, integration testing, and functionality testing. You should also have other specific tests because ML projects have other requirements as well, right? So you need to have a mechanism to test your business metric. You can have a non-functional testing like explainability in place, which will tell you why your model made such a decision. You should also have A/B testing in place because only then you will get to know which of the candidate models are performing well in production. So these are some of the things that should be offered by the MLOps platform. The next thing is wherever automation is possible, the MLOps platform should automate that. So you should be able to automate your data engineering pipelines. You should be able to perform ETLs automatically. You should have a retraining and training pipeline in place. Maybe you can also have automatic model selection as part of your MLOps platform. Other than that, you should also have reproducibility of several experiments that are carried out by different people. Not just that, you should also be able to reproduce the data processing and the feature engineering pipeline. So these are some components that are very essential. The next step is to provide easy deployment options. So you don't have to spend too much time understanding how to containerize a model, how do you expose it as a REST API. So all these things should be readily available in that MLOps platform. The last thing that is maybe the most important one is governance or a monitoring module. So here, like I said earlier, the productionized model's quality might degrade over time. The degradation may happen in two ways. One is data drift, another is model drift. So if your target variable only changes, then you will have to actually retrain your model on the new production data. So that is called like model drift. If suppose the independent variable changes, so there is variation in the distribution of your production data and your train data, then maybe you will have to update the model. So these kind of decisions should be made, and the MLOps platform should have a module which will take care of all such decisions. Additionally, you can also have a monitoring module for your infrastructure or resource. I think this is kind of provided by a lot of the infrastructure service providers, like maybe the cloud service providers like AWS and GCP and Azure. So this is something readily available, but the model monitoring part is something very specific that you have to build or leverage from the open source frameworks. With the previous explanation on the basic principles of MLOps, it is very evident that you should have your MLOps flow should contain several pipelines. So one is for continuous integration, one is for continuous delivery, and another one is for continuous training. So like depicted in the picture, you have your development environment and your production environment. After you perform your DS experiments, you will have to kind of version your code and data as well in source repository and feature store respectively. Once that is done, you should have some build, test, deploy pipelines which are like automated, where you will perform your data engineering tasks, convert the data to the required format, and you perform your feature engineering tasks. Once that is done, whatever model you are building, that should also be stored or versioned. It can be done through a model registry. And from the model registry, you can start serving the best model after performing the relevant test. Once that is done, you actually expose it as a REST API, and your model will start predicting on the production data. You should also have a performance monitoring module where you check for the data drift and model drift, and based on that you actually trigger the retraining pipeline which connects you to the development environment. So this is also a cycle. This gives you a basic idea of the iterative incremental process that you have to follow in MLOps. For the MLOps pipelines, there are certain components that needs to be in place. These are some of the basic building blocks that you should have in the MLOps platform. So to start with, first let's look at source control. So you have to maintain and version your code. Many of us might be using GitHub or GitLab or SVN, some kind of version control system. So you can leverage such kind of a tool for doing your source control. For test and build services, again, GitHub provides something called GitHub Actions, where you can actually build your code, test your code, and also deploy. So it provides everything. So this is something that you can look at. Also, for specifically for deployment services like containerization and exposing it as REST API, which is compatible across different platforms. So you can leverage TensorFlow serving or CML. CML is continuous machine learning, which is also provided by DVC. So DVC and CML are from the same set of, same people. So DVC is for versioning the data itself. So you store the metadata about your train data, test data, everything using DVC. So DVC is called data version control. So DVC and CML are like offered together by the same people. And weights and biases and ML flow will provide you with a place to collaborate. Store your artifacts, your models, your even the data, metadata, all those things can be displayed, stored and displayed through weights and biases or ML flow. So these can be leveraged when you are doing your development work. So this helps in collaboration and easy maintenance of code and artifacts. So these are all the basic building blocks. And the last one is ML pipeline orchestrator. So this is you can leverage Airflow for tracking your pre-processing pipelines and workflows. So these are all the building blocks that are very essential in building an MLOps platform. So here are the links to the sources that I have shown in the previous slide. This is not an exhaustive list. These are some of the options that you can look at if you want to build your own MLOps platform. So I think that brings me to the end of the discussion. So I hope this discussion is useful for people who really wanted to understand the basics of MLOps. If you have any queries or questions, please feel free to connect with me on LinkedIn or Twitter. I have provided it in the beginning of the slide. I think that's all I have for this presentation. Thank you so much. Thank you, Usha, for giving me this opportunity. I'm glad I could be a part of WiDS Mysuru's event today. Thanks, everyone. Thank you so much.
Thank you so much, ma'am. That was a wonderful session. And moving on, we've got a next speaker, that is Miss Manjula Shivanna. She's an artificial intelligence and machine learning technical leader at Cisco USA. And today she's going to be talking about augment knowledge with conversation AI.
Hello, everyone. Good afternoon. How are you all doing today? I hope you are having a wonderful session so far and enjoying all the presentations. I'm happy to be part of this, and thanks to Usha and the team for reaching out and connecting on this Women in Data Science Mysore forum. Today, I'll be talking about augmenting knowledge in conversational AI. And before that, I would like to share that I'm basically from Mysore. So, Mysore National Institute of Engineering Computer Science. I'm currently working at Cisco USA as a data science engineering lead, executing AI ML innovation projects, basically under customer experience and product innovation lab. I hold masters from San Jose State University and executive innovation program from Stanford. I'm fortunate to work and explore multidisciplinary projects in domains like health, finance, computer, and networking, retail spaces. I hold 8 patents in software engineering, machine learning, and artificial intelligence field, and few are in process of getting approved and filed. I enjoy collaborating, connecting exchange of informations and mutual learning from peers like you and others who are in this forum and other forums. As part of it, I have come to connect with Stanford, Berkeley, and other universities as ambassador in this program and other programs. And she can mentor and co-lead on the SheCan and First Lego and some other non-profit organizations. So I'll be happy to connect and share the same information if any of you are interested to learn more about it. So now for today, the agenda will be, I'll be going over on our fundamental knowledge, representation and reasoning. As part of it, like we'll be covering what is a taxonomy, ontology, knowledge graph, and what's the embedding behind it, and the general use case which can be tailored to any business, and then vertically fine-tuned for specific use cases, and the common solutional framework canvas. Additionally, we'll be going over the Conversational AI platform given by, the current proprietary enterprise systems and open sources, and the frameworks which will help us to build very quickly and go to market in a short span of time. So I try to put a common problem statement, which is actually triggering the need for a conversational AI in today's world. So as part of that, you can see that I have put together two statements, but overall they boil down to one, but because they actually intervene with one another. So asking a question and getting an answer with common sense, natural sounding language, and another one is the virtual assistance with human like conversation. So where the mundane and repetitive work of a person in a given organization or a business can be passed on to getting passed on to virtual or augmented twin, so that it can be executed in a much faster and automated fashion. So the in order to put this solution in place, we need a conversational AI system and a platform, which was not there in like a decade back. Then we might hear that, okay, we have already the chatbot and message apps and others being running for almost nearly 5 years to a decade. Then what are those, right? Why are we talking about a conversational AI today? Wasn't it there? Yeah, it was there. It has been there since a decade, but it has been evolving and there have been different versions to it. So let's take a look at it. What are those and how we have evolved, and what is that as the current state of art we have to use, given that we want to have a human like natural sounding conversation in our apps, virtual assistant apps. Okay. So to start with, the foundational approach is we need to have a business specific data and content in a accessible and usable format. Okay, so the foundation is always going to be on the taxonomy and the ontology. Maybe in whatever form the evolving platform call it, maybe they call it as a knowledge base, knowledge connector, foundational units, or the skills in Alexa, whatever the different naming that gets formed based on the the platforms. The underneath term is always a taxonomy and the ontology, and the unifying between these two is the unification schema definitions. So these has to be carved out clear and as much as possible in a clear fashion, but it is time consuming and it demands SME or a subject matter experts involvement. As we know that it's not always easy to get that combination in a given bigger, larger organization where the business has been there for over decades, right? So in that scenarios, we do have like models, which will do a automated taxonomy and ontology extraction and labeling and tagging. And one of that component is been the Stanford Ignite, and they do have tool that tags and enables the relationship generation between the ontology, and we can have a custom model built into it so that it will help us to learn the taxonomy and the jargons specific to our like corporates or companies. For example, we do have jargons like, for example, television can be referred as a TV, which is a common I'm taking, but maybe in certain Samsung others, they might have like TVX and TV series with, because, and TV Roku X and so forth, right? Like Xbox has Xbox X series and X1 and so forth. So these are the jargon specific to the enterprise, which needs to be learned and tailored together in order to build a specific relationship. So when we have a specific hierarchy data, it's easier to build. Who is the manager of X employees? We can find it. Who is the manager of X employees working in a project? We can find it from the unification scheme. Who is the manager working on X projects, having coordinated with so and so employees without such skills, right? Without a direct related skills. So when this comes into picture, you still use the taxonomy and unification schemas and so forth, but the relationship becomes much more than a direct relationship, right? It becomes, you have to have vocabulary learning and certain enrichment within the entities and link data binding and so forth. So these are the foundational blocks that will help us to move the groundwork ahead, work on it, so that we'll be able to embed and integrate with the generalized conversation systems that we are going to take a look at it. So in this slide, I would like to share the knowledge representation reasoning layer by layer foundational architecture, where you can see there's a data layer where you have the taxonomy learning from different sources, because it's a multivariant, multimodal data source in today's world. So you get it from basic file to RDBMS to Elasticsearch to real-time streaming and other connected data sources. Once we have that, the taxonomy and the metadata learning has to happen, and the generation, whether it's automated fashions or a one-time extraction, but it's both the combination that has to happen. That's where a lot of text mining, auto generation, encoding, decoding, all this can be applied to have an effective model generation. Once we have this, the connected linked repository has to be fine-tuned, which is again tailored to a particular organization or corporate world. After that, we'll be looking into ontology-based knowledge, that is a co-occurrence of the concept similarity extraction. So for similarity extraction, one can play with TensorFlow, BERT, and other attention workflow models. And vocabulary enrichment and NLP engines can be built or integrated with the other proprietary or third-party providers. And system tagging, annotation, hand labeling, and so forth, or using the existing corpuses and like a WordWag or other we will be receiving open dialog corpuses and other forth. So these, all those can be leveraged in order to evaluate whether it's a right fit or not business case. But we need to have an ontology driven knowledge base, because unless it is completely unstructured data, then maybe we'll be having a very less dependency on the ontology. But if any organization is going to have a foundational structure to it, right? From which product is producing what data set, which service is consuming the what data set, maybe given a product, how many applications are associated to a product. So these are the kind of ontology relationship I'm talking. Maybe like for Netflix, it do have channels, the number of channels in which a user can view the same streaming program, right? And those channel, how many customers are having, what is their basic like demographic or their classifications model, whatever, right? So these are the like semi-structured ontology information, but the underneath connected pumping data might be still very unstructured and multivariant. Once we have this, we'll be weeding out the noise enrichment, and we can also depend on the crowd annotations and having traversal feedback loops in order to enrich the data from time to time. And once we have that, have the enterprise domain ontology and graphlets. So these are the connected components that has to be put together in order to enable Q&A model knowledge graph. So these are the layers which you can take into consideration, play with it. Not all of the components are core when a business has been analyzed, a business use case is analyzed, but most of it are needed in order to have all into a knowledge representation and reasoning forum. Now we know the flow of what it takes in order to put the content together. Let's see what is the conversational AI part overlaid on this. So in the conversational AI, there are three sections we can split in: general knowledge and industry specific knowledge, company knowledge. So in the general knowledge, it's a chit chat conversation, having initial greeting, hi, how are you, thank you, can I help you with more information, right? These are the general information, general knowledge chat. And followed by, we do have a industry specific knowledge. So if they are talking about a banking, telco, insurance, or a public sector, so forth, right? The terms and the conversation that is needed in that industry is very specific. For example, how many accounts are like uh, are there with you, like you're trying to open with us, right? If they are talking about the banking domain, it's been like few years back, so I'm not getting the word, but basically in order to say, okay, are you here to open checking account or saving account with us, what is that you want to do, right? And otherwise, if it is a computer network, which is my current domain, we would be asking, are you looking to buy our WebEx presence, right, teleconference product, or which is a product you're willing to renew, or so forth. So this is a very industry specific conversation that will happen. And then comes the branding aspect of it, like Amazon, IBM stores, or other will have their own specific jargons and the terminologies that they'll play with when it is company specific, right? So like AWS says whether they want to buy a ECS server, or IBM will say they want to provide a Watson service, or like Cisco will say UCS servers, and so forth. So these are the company specific knowledge. So there is a three layers at the most, like that will drive the conversation. So uh, in most of the cases, the general knowledge and the industry specific knowledge are part of all the conversational AI platforms out there. So they all have covered at least these two for sure, but they'll be having they are providing the way to create the company specific details, company specific knowledge nuggets that will enable the conversation very streamlined to the business. So as you can see here, this is a general conversational workflow. That is, you will have a knowledge base creation. So as I said, the knowledge base creation is curated from taxonomy, unification schema, and ontology, and the natural language processing and question answering and the dialogue management. So yeah, these are the components. But while we are building together the under artificial intelligence, there are several sections of areas like machine learning, natural language processing, and computer vision, and so forth, right? In that category, the main contributing category for conversational AI is natural language processing. And while we learn around the natural language processing, you might be coming across natural language understanding, dialogue management, or language generation, transformers. These are the terms you will be like hearing and learning around, but most of them actually roll up under the NLP as an umbrella. But when we go in a much deeper specific conversation, intent and context building conversation, at that point NLU plays a huge role, and definitely the language generations, which is based on all these BERT and transformers based generator models, will be playing a, like you know bigger role on identifying what is specific model we have to make a choice, and rebuild the content on this. So here is one of connected like uh, the overall visual diagram I could identify, which speaks fantastically about bringing in all these connections and building the different perspective of conversations. So for learning, you need to have reinforcement and reasoning, natural language processing, and dialogue management, and interaction is Q&A pair based, and perceive is entity recognition. But as I mentioned, right, entity recognition and having a Q&A pair and dialogue management are kind of an integral part of the overall natural language processing, like a conversational system. So though we say mainly we play with the natural language processing, we need to have the building blocks of entity identification, Q&A, intent and context settings, and so forth. So now let's take a look at who are the conversational AI platform players, and here are few: Dialogflow from Google, and Alexa from AWS, Salesforce Einstein, it is tailored to customer success platform, and IBM Watson is more like starts with a rule based and then expands, but it is completely data scaling, so it depends on the kind of the data that is provided. Each of these provides two layers, that is the general and the industry specific. Industry specific is also limited because they provide knowledge connectors through which we can upload and generalize the industrial knowledges, but the company specific still be built from ground up. And here, a couple of AI open source from Cisco. We have MindMeld, which is being made as an open source conversational AI platform, and Raza is another open source which is growing, and have been very active forum as of now as an open source for conversational systems, and it has added voice based assistance as well, and they're working on motion and uh, touch based is what I learned. Also, I noticed that later today there is a person talking on Rasa as well. So that will be a fantastic session, I believe. Here are few use cases I have put together which showcases how the dialogue builds up. As the dialogue builds up, what I wanted to highlight mainly is you can see the augmented knowledge here, right? There is a restaurant from which you want to order the food, and there is attraction places you want to take a look at it, and the taxi. But these three are not and need not be connected all the time, but they can correlate to each other based on the scenario, right? They are bound to occur together. So here is where the augmenting the knowledge in order to generate the best conversation comes into picture. And here is another example where how the reasoning and why the context and intents are critical while having a human like common sense based conversation. So the papers are provided and you can take a look at it, and it will be interesting for sure. And if you have any questions, feel free to reach out to me, because I have models on this, and I'll be more than happy to go in detail. Now, as a takeaway, here are a few observations. This is, as I said, just to give an overall view. So the observations has been taxonomy specific to corporate jargons has to be done, has to be built, and ontology and enhancement with specific KG embeddings has to be done. And from overall learning and the state of art claiming is neural generative models are insensitive for the utterance level. Like, if the utterance is not having more than 2 seconds, 3 seconds, and the utterance is like a word specific or a 2 words, or is it over a 3 word pair, right? So all this comes into picture, and also word level specific informations are needed. So on this, the generative models may be having certain drawbacks and biases, how accurately it will identify the next best responses. And the state of art in the area one, there's the general and industry specific is already there. So one need not actually reinvent it, they can use it. And a company or a brand specific embedding has to be built ground up in most of the cases using NLP attention mechanisms like TensorFlow, BERT, or GPT based OpenAI is trending now. And one can take a look at it and work on building the company specific models. So here are a few references, and that's it. This is the end, and I'll be more than happy to take any questions via email or through the forums, and I'm here to share more as and when the questions come on my way. Okay, and please keep in touch. And here is my LinkedIn and Twitter handler. So let me know in future how I can help you and learn each other. Okay, bye. Thank you.
Thank you so much, ma'am. That was a wonderful session. And moving forward, we've got our next speaker. That is Miss Lakshmi Gayatri, and she is a software quality architect at VMware. And today she is going to be talking about advanced Kubernetes.
Hi everyone, I'm Lakshmi Gayatri. Welcome to the Advanced Kubernetes talk hosted by WiDS Mysuru, Women in Data Science Group. So let's get started. So even though this is an Advanced Kubernetes session, you will be able to easily construct because the examples and the demos what we are going to see are going to be very simple and easy to understand. So here it is about me. I work for VMware Software India Private Limited. I had been with VMware for 14 years. I'm currently a software quality architect. And apart from my day job, I'm also passionate about Kubernetes, Docker, cloud native applications, and also I have built expertise on certain VMware products, and hence I'm awarded vExpert. And most importantly, I'm a Women Who Code leader from Bangalore chapter and a Grace Hopper conference tracker. And this is my third year in both the things, like Women Who Code and GHCI. And then I like to contribute to the community a lot. Coming to the topic, so we are going to have 5 different topics for coverage today, and this is the sequence in which we are going to go through them. We will be having demos in between, so it will be very easy to understand and connect what we are learning with what we are going to see. The first one we are going to do is the lifecycle management of Kubernetes applications. So we'll start with the demo. Usually I like to start with the demo first because it helps to understand and reinforce, get the attention of the audience. So let's get started with the demo. In this demo, we are going to see how the lifecycle management of an application is possible with Kubernetes and how simplified it is about. So in Kubernetes, we write YAML files in order to define the declarative state of the system. And here we have a YAML file which has a deployment, the kind of deployment, and the name as NGINX deployment. With the image as NGINX with 1.8 version. So in order to create applications in Kubernetes, we use kubectl create-f and followed by the YAML file. In case the application is already created and then subtle changes needs to be done, then in that case, instead of create, we should be using apply. Currently, we are not specified any namespaces, but if the application has to go into a specific namespace, usually we pass like -n and the name of the namespace so that the application gets created within the namespace. So here from this output, what we see is the deployment called nginx-deployment has got created. And then let us get the deployments and then see how the creation had happened. So in the get here, we can see that there is a deployment which has taken the ngInx deployment, which has taken 6 seconds. So that is what we have created now. And then kubectl describe command is what we are going to see. So this command, what it does, it will help us to give a more detailed description about what was created by us. So we are going to see that. Yeah, kubectl describe deploy and the name of the deployment. And then here we see that the image name is ngInx with version 1.8, the name. And currently this is using one replica set. Yeah, so the age of the system is 17 seconds, so which means it's been up and running since 17 seconds. Yeah, so for the deployment, we have pods. So the pod here, the second pod which we have here is ngInx deployment. And this is the age of, like the age of the pod is 43 seconds, which we have just deployed. And then this is the pod which is currently running with the ngInx version of 1.8. Sorry. Get pods. Yeah, so this is the pod what we have seen, and then we are going to make describe pod and then the name of the pod. So usually describe we used to get more details than what we get from get. And then if you see the events here, the event shows that we have a container image of ngInx created with the 1.8 version. Now, instead of this 1.8, what we are going to do is we are going to modify the image version to 1.7.9 and then see how Kubernetes is able to handle this change. So let us change the YAML file and then apply it again. We are applying it now, not creating, because it was already created. And then, yeah, so this is an interesting part. So when we had applied the YAML file, so we are seeing a newer pod, which is ngInx-deployment, which started running since 4 seconds. And the previous pod, what we had, which was with 1.8 version, so that we see it in terminating state. So at any given point of time, so what is happening is when we modify the version, the older pod, before it gets into the termination state, we are also seeing a newer pod has started and it's in running state. Only when the newer pod is in running state, the older one gets into the terminating phase. So it's trying to terminate the pod. Yeah, it's 1 or 2 seconds. The pod is in terminating state. Yes. At this stage, we don't see the deployment pod, which is ngInx-deployment 6F655, because it's been completely terminated. And it took about 1 or 2 seconds for the pod to completely get terminated. And then the newer pod, what we have created, so that is up and running since 14 seconds. And this is not what we have modified. And then, so all we did was the YAML file modification is what we did. And then once the YAML file is modified, we did kubectl apply-f in order to tell the system that this is a new declarative state of it. So let's describe the pod to get additional details. Describe pod and then name of the pod. Okay. So here we see the container image. If you see carefully, it is 1.7.9. So that is a modification what we have done in the YAML file earlier. Yeah. So at this stage, we will pause this demo and then come back to it when we have services. So then let's move on with the presentation and then see the service. When we come to the services part is when we will see the services one here. now coming to the networking part. So usually in Kubernetes, networking is underestimated. It's very important to have a resilient network. For example, we are playing some online games, right? Maybe like Fortnite or something where a lot of people are interested to play. And these are games which are like real time. So when the player is put on a battlefield with like more than 100 players, everything has to be real time. It cannot have some delays. Latency is not accepted. It cannot be like somebody shot at the zombie, but then the zombie is still alive. That is, it will make the players lose interest in the game and also leave the game and never come back to it. So networking aspect is there at every layer, not just at the application. When we build, we need to have a clear-cut idea about what is the networking we are going to use for the Kubernetes application. So this is where we are going to talk about CNI and touch upon Calico, which is one of the mostly used CNI for Kubernetes, along with Flannel, NSXT. We have other variants also. So this is a picture what you see, wherein the pod itself, it is a set of containers. So if you see the P pod here, right, there are a lot of P's which are seeded in. So when we say that this is a pod, you just think it could be one container or it can be a bunch of containers. And these pods, each pod will be assigned an IP address. So in Kubernetes, the container never gets its own IP. But then the IP address, what we assign is to the pod. So in this picture, as you see, right, this is a pod and then you have like IP1 and IP2. The IP address maps to a pod, not to the container. So the pods on the node, they can communicate with all the pods without any NAT rules. And also the agents on the node could be like system daemons or kubelet. They can communicate with all the pods on that node. And then the pods in the host system, they can communicate with all the pods on the nodes without any NAT. So that is what it signifies, like pod to pod, node to pod, and pod to node. Here in these three aspects, we don't have to have any NAT, no network address translation required. The communication just happens. And that is very important aspect to look at, because when we are designing systems or going for a choice of CNI, it is very important to know what it helps without setting up any additional requirements or without rewriting some resource definitions or something. And these are the examples of container network interface we have. This is not in any priority order. So we have Andrea, NSXT, Calico, Flannel, Weave, and Canal. So all these are examples of CNI. If we want to apply such networking, see the beauty of Kubernetes is everything is, it's like a software file. If we want to have Calico installed on this application, all we need to do is just get the Calico YAML file. It's called Project Calico. It is available. I mean, it's open source. So you can get the YAML file using curl and then run kubectl apply-net calico.yaml. So when this calico.yaml is done, so what basically it does is it brings in the CNI, the container network interface onto the cluster. The cluster here is a combination of the master nodes and the nodes, the worker nodes of the Kubernetes cluster. And then these are the aspects what it brings in. So when we bring in CNI, there is policy, IPAM, CNI, overlay, routing, and data store. So as you understand, right, like policy means like Kubernetes network policies are implemented by these network plugins rather than Kubernetes itself. So simply creating a network policy resource without a network plugin to implement it, it will have no effect on the traffic. So you need to have strong policies defined, so keeping in mind the pod security policies and then who is allowed to access applications. And this Calico plugin is it's a full set of Kubernetes network policies. In addition, it also supports Calico's network policies and providing additional features and capabilities beyond the Kubernetes network policies. And next we have IPAM. I think, IPAM is IP address management. And how Kubernetes assigns address to pods is determined by IPAM. So usually in IPAM, we give a range or a subnet. like say /24 or /23. So the pods, when they're coming up, nobody is sitting and then deciding that, oh, this pod has come, I need to provide this IP. So that cannot be done. It has to be orchestrated, right? So from this IPAM range is what each pod, when the pods are coming up, they just go grab the IP address from IPAM, the range, and then they get the IP. So in the previous picture we have seen, right, each pod has its own IP address. So that is what IPAM does. And Calico IPAM supports advanced features like multiple IP pools and the ability to specify this IP address range that a namespace or a pod could use, or even a specific IP address a pod could use. So you can also have it assigned, or you can give it a range, or you can also say like what are the namespaces which can use this particular IPAM set and what cannot. Next we have is the Calico CNI, which is nothing but container network interface. It's a plugin used by Kubernetes to get the details of how pods are connected to the underlying network. This is mostly using L3 networking without the need of any L2 bridge. Next we have is overlay. As the name says, right, it is like an overlay network. So which means you have another layer on top of it. You don't have to really have all the systems connected, but then you build another layer on top of it to which the systems are interconnected. So this overlay networking allows pods to communicate between nodes without underlying network being aware of the pods or IP addresses. So it just lets the traffic happen. And then next we have routing. So Calico routing distributes and it also programs the routes for pod traffic between nodes using its data store without need of BGP. And Calico routing supports unencapsulated traffic without single subnet, as well as the selective encapsulation for clusters that spawn multiple subnets. So this is VXLAN packaging, what I meant to us, because the packet actually gets encapsulated into the VXLAN package, and then it gets transported. The encapsulation happens there. And the last point here, what you see is data store here. So Calico stores this operational and configuration data of the cluster in a central data store, because it's very important for any network interface to know what is the state of the system, what is the desired state of the system, and how the current health is being updated. So there are certain advantages of using the CNIs which are already built in, because there is active development happening, and even if we hit any bugs, they will be addressed very soon. There is a large community support. NSXT is one enterprise product, and it has a lot of advantages. It also supports micro-segmentation, which is very much needed when we are building Kubernetes applications. Let's move ahead. So in the previous slide, we have seen, right, if at all we are talking about Calico as the CNI, and then we want to bring in that Calico to our Kubernetes cluster, so we can use curl and then get the YAML file. Once the YAML file is obtained, we need to use kubectl, either create -f or apply -f. So here, when we apply the Calico YAML, if you can correlate the output of this with the previous slide. So we are having some BGP configurations, and then we have some network policies which are getting created. There are IPAM blocks which are here. There are some IP pools. So all the in the example, what we have seen the layout, right? All these custom resource definitions are being applied onto the cluster. So typically, this is the output what you see when you apply Calico. So this is very important when we want to bring in some additional networks. And the best thing about these applications is, even though we have Calico, right, it's not like we cannot have another CNI. You can have multiple CNIs working in the same cluster. We can use Calico for a purpose A, and then we can have NSXT for purpose B. We can have Antria also. So different CNIs can be used to do the respective jobs, and then still have everything work without any collision effects. So, and if you watch this very carefully, so there are some features which are there, which we are going to talk in the next slides, and also in the coming up talks, wherein we have this config maps. So the concept, you see the first line says there's a config map which got created, right? And then apart from, and every line here, what we see is the custom resource definition. These are nothing but CRDs, which is going to be the last topic for this talk today. We'll see about a CRD. And then just see how to create a CRD when we have it in the YAML file, how to write a YAML file for CRD. So that is the demo what we are going to see. So moving forward, next we have is services. Services are very, very important because all the Kubernetes application, whatever we have, if we need to access it from outside world. When I say outside world, say I have created a Kubernetes application on my laptop. And then I want my friend to be able to access it over internet. In that case, I need to expose these services so that the services will be reachable over the particular domain name service, or usually we prefer domain name service, or a particular IP address. So the way we design the services also depends upon what is the accessibility criteria for the services we want. So we'll quickly see what are the types of services are there, and then it will be easy to understand when to use what. So these are the services which we have broadly. So we have headless also, which I'll talk about in the next slide. So this is, so first we have is the cluster IP service. So wherein the scope is within the cluster itself for the service. So whatever the service is doing, within the cluster, only the accessibility is there. Accessibility is not outside the cluster. So this is the default type which exposes cluster internal IP. And the next one is node port. So node port service, we will see the demo. So this is, node port service is very interesting and it's the quickest form. This service, what it does is on each of the nodes IP, node is like worker node, so there will be a port. The service gets mapped with the port on the node. So a cluster IP, what it gets created. So internally, what happens will be a cluster IP that gets created, and then the node port service is like a route to it. So that's why in this picture you see cluster IP within the node port circle. So, and the representation, what we do is the worker node IP colon the node port, whatever you want to expose it. That is how it talks to the outside world through the port on the node. The most popular one service type is load balancer. That is the bigger circle what you see. So this load balancer service, what happens is it exposes service externally using the load balancer of your. It could be cloud. Or you need, if you are running it on-prem, then you need some on-prem. It will say, for example, you have NSXT. So NSXT, if you have it on-prem, then it uses NSXT's one of the ports in order to send the traffic out, like egress it out. And this cluster, the external load balancer routes to node port, and then again it is to the cluster IP service. So it is just built. So when we create a load balancer service, internally what happens is, it has something like cluster IP and then the node port, and then the service gets exposed out using the load balancer. And the last one we have here is the external name service. So this one maps to the service which is like external name field. Usually it is like could be like a DNS name, like google.com or something, right? That is the name. When we look for something in the browser for Google, even though we know when we ping Google, maybe we get some IP like 16 dot something. It's not that you type the IP to get to the Google. All we remember is google.com. So that is the domain name service. So here for the external name, it is, we always use this external name field, that is like google.com or something. So the service maps to the external name, and it does this by just returning the CNAME record. Let's go forward. Let's get more details in the cluster IP service. So as you have seen, right, the cluster IP, this is the default one. It will open access to a cluster within the cluster itself, and there's no access to the external world. The traffic is coming through the proxy, and then the scope is all within the cluster itself. You see the box like Kubernetes cluster, so everything runs there. Then we have node port. So what is happening is in the node port service, if we are watching it carefully, so for the VM here represented is the worker VM of Kubernetes. So for each of the worker VM, there is a port. Here the example is 30,000. So this is the port which it is using to communicate. So what will happen is Kubernetes will open a TCP port on every worker node, and then it uses something called proxy. I mean, if we look at the architecture diagram and then understand what are the components of Kubernetes that are running in master, what are the components which are running in the worker, then we can map like how proxy is playing the role. So it is, and then if these worker nodes these are anyway placed on the private network, they don't have any access to the outside world, and this service can be used to give access to an application from outside the world. So, like I have something built on my computer, I can give access to my friend in order to access it by creating a port and mapping the worker with the port number. And the next one we have is the load balancer service. As I said earlier, this is the most commonly used load balancer. Load balancer type service is the most commonly used service. So here the traffic comes and then we have a load balancer. Having load balancer is very important because we should understand that the pods, they are ephemeral. Ephemeral as in they don't live for long. They may keep crashing for some time. They may get restarted. And this load balancer service, once we have it, so it takes care of all these things which are happening in the background. So the target, what we point to, is just a load balancer IP. Back and what happened, that we don't care, because when we open, say, Microsoft Excel, right? Just a simple example. Earlier, we used to have Excel installed on the laptop as part of Office package, but now we are not installing Excel or Word or PPT. Everything is coming from the cloud instance. Like we will have the Microsoft account, and then we are able to access. So when I launch when I want to deploy an Excel sheet on my laptop, right? So what happens is in the background there could be a container that is getting spun from my account with the application as Excel, and then I am able to access it because I don't have any installation on my laptop. So this load balancer service, what it happens is, so it will be as you see in the picture, right? You have a service and then it is communicating to all the pods. The traffic from the external load balancer is directed to the backend pods. If you are using cloud provider, then the cloud provider decides like how it has to be balanced. Different types of load balancers are there. There is so the protocol also, it can be like TCP protocol or UDP or HTTP. And some cloud providers will let us provide a load balancer IP by ourselves where we can choose. But otherwise, it will be created on some load balancer IP, which is by default, or the system picks it for us. And next, we will see a headless service. Usually, headless service we use when we are talking about databases. When we have databases is when we use headless service. I mean, a cluster or deployment of data centers of databases, like example like Cassandra or something. And the only difference what we see in headless service is the kind is still service there, but there's one key parameter which becomes none, that is the cluster IP. So in the YAML file of a headless service, the cluster IP is defined as none. So the moment this field is there, so that is when it becomes a headless service. So if we look at the NS lookup, right, of a headless service, we can see that the addresses, whatever you see here, when we do the NS lookup of the service, are actually the IP address of the pods. Now, say for example, in this example, we have like say five pods are there. So the IP address of each pod is being written. So when you need or you don't want a load balancer, right, and or a single service IP, then you can create a headless service. And there is two different types, like having headless service with selectors and without selectors, as you can see in the YAML file here. So the headless service with selectors, what will happen is it defines selectors, and the endpoints controllers, it creates the records in the API. and it modifies some DNS entries to return the records. And if it is headless service without selectors, then they don't define any, wherein you don't define any selectors, the endpoint does not create any endpoint records. So it is like, no records get into your details. So let's go forward. And the first demo what we have seen is the lifecycle management of a Kubernetes application, right? So there we have created a deployment called nginx-deployment, which is running with the image as nginx. So that service, so that deployment, let us try to expose it like a service and then see if we can access it from our laptop or not. And for this, the type of service what we are going to use is node port service. So let us start this. Yeah, so we have seen the modifications, we have seen how to apply. We'll just go to the place where the deployment is ready and we'll have to expose it as a service. Yeah. So we have a deployment which is running nginx with 1.7.9. And then we will use this expose command to create a service out of it. So what we are doing is we are using expose deployment, name of the deployment, and type is set as node port. So here, this is what happens. So in the node port, as we have seen, right, it is the worker, it is a worker IP address colon the port which is on the worker. Let's see the path. Usually -o wide option we use to get additional details like IP address and other things. The second one here is our deployment, which is exposed as a service. We have an IP address there. So how we are going to access, we need the node. It's like node colon port. So let's get to the IP address. The node IP address, we'll note it down. And try to open it in the browser. So the IP what we are using is the node IP, and the port number is the node on the port on the node. That is 30680. We can also make modifications to this file. So what we are going to do is usually when you open nginx server, it says like welcome to nginx, right? The main page. So that let us just modify that to welcome to demo or something like that. Yeah, we'll say welcome to Kubernetes demo and then make changes in the HTML. So when we open the browser, what we should see, we shouldn't say welcome to nginx, we should say welcome to Kubernetes demo. I took the demo a little back because it seemed to be hung. So that's where we are saying welcome to NGINX. So now we'll get into the container, make modifications from welcome to NGINX to welcome to Kubernetes demo. So if you just realize, I went back in the demo because the system seems to have been hung. Yeah, we are modifying welcome to NGINX to welcome to Kubernetes demo. And then we'll save and then get out of the container. And in this case, what happens is immediately the change is reflected. So in the browser, when we just made a modification, that we have not redeployed the code or anything, and then you can see that the change is immediately taken, and then you see welcome to Kubernetes demo. By default, it is like NGINX, right? So this is what we can do very quickly with Kubernetes. We have not redeployed. And then what we have done is we just entered into it and then made some changes. And then once it is, once we are out of it, because the service is already running, it immediately took the change. So let's go forward with operators. So what comes to anybody's mind when we talk about operators? So this is a picture of people who are literally working on the telephone systems. So operators, what it means is, so the people if you see here, right, these are domain experts. They exactly know how to run the entire TRI system, and they are able to manage it in a continuous fashion. So even with Kubernetes applications, like what happens is it's not just about we deploy and then we configure and then we push it to production. There are a lot of day-to operations also which we need to take care with respect to maintenance and management. So it's all this application, they're very complex applications. And then they need a lot of human intelligence, right? So that the knowledge of the humans, we'll have to put it in a code. That is exactly what the operator does. So that is where Kubernetes has this concept of operators. It is represented by this symbol. So we use Helm charts for deploying operators, and then this is the life cycle of an operator. If you watch carefully, right, it observes the cluster state, identifies if there is any difference. So I'll give you an example here. So usually when we have Kubernetes, you would have heard me now say twice that I have used the word declarative. So declarative, what it means is like in Kubernetes, we say this is a state I want to be at. This is my application has to run with say 10 replicas. This is what we are going to say it in the YAML file. Kubernetes takes care of creating 10 replicas. If I'm not creating replicas in a loop, I'm not executing the command 10 times, but Kubernetes is able to understand that. So how the simple example in layman terms is when we book Uber, we just say that I need to get to Vidhan Soda or some example like that. And we just pin in what is the destination we have. But when we get into the Uber cab, we do not give directions like, hey, turn left, turn right, go here, avoid the signal, this is one way. We don't have to tell all these details. So that, but then usually the system, the Google Maps will assign allocated and which work in association with the Uber app, they actually tell the driver to take you to the location in the best possible way, which is the minimum time. Here, what is happening? Exactly that way. Kubernetes also, We just need to say that I need to get there, but we don't have to tell how. The how piece is not needed to be told. What is the declaration is always about what the system has to look at. So, and when this operator, how it operates is, it observes the system. So usually say I went to Vidhan Sauda and then I decide to go somewhere else. But then to Kubernetes, I said I'll have to be in Vidhan Sauda. So it will put me back to Vidhana Sauda again. So it has observed that it frequently it observes and then notice that there is a diff, that Lakshmi Gayatri is supposed to be in Vidhana Sauda, but she's not there. So what Kubernetes does, it acts and then puts me back to the place where I told the system to be. So this is a beautiful cycle. So it observes, it identifies the difference. If there is a difference, it acts so that it corrects the change and brings it back to the original state. So any deviations, it doesn't like it. It bring it back to the standard state. So here in for day 2 operations is what usually operators are very helpful because they help us to manage the stateful and some complex workloads. And here you see custom resources that we are going to talk next. And this operator is nothing like it's a method of packaging, deploying, and managing a Kubernetes application. And it can be anything. It can be deployments, as we have seen in demo 1 and demo 2. And it could be stateful sets. So these applications can have two forms. One is it can be a stateless application where the state is not reserved. And if the pods restart, then you lose the state of the system. It is, so stateless is like you be in the queue for an IVR, for a voice system. And then it keeps saying that you are in, say, position number 2, the people are busy, they'll come back to you in a minute. And if you lose the state and again dial in back, you lose the spot on the queue. Again, you will be placed at the bottommost of the stack. So that is stateless. So stateful sets we use especially, it's very useful. It's majorly used in production environments. For databases, it is the best example what I can take. Because database cannot say that, okay, some pod restarted, I lost the state of the system. That is unacceptable. So we use stateful sets. For one example is for the database pods. And then we have autoscalers. So in Kubernetes, we have both horizontal pod scalars and vertical pod scalars. It's called HPA and VP. So in horizontal pod scalars, like what happens is we have a metric server. So in the metric server, you say that, okay, if my peak load hits 70% or 80%, then you know that you need additional worker nodes to keep the system alive and running. So this automatically, when this threshold is met, the action is taken in order to make the cluster happy. So this use case, we can think of it like Diwali sale or something, wherein there will be a huge surge in demand. And during that time, when the demand is very high, we have a lot of people trying to access, say, Amazon app and trying to book the items which they want to buy and give the location and get it shipped. And this will be unusual traffic during Diwali time, depends upon the discounts what they're giving or the festival offer which is happening. So during that time, we cannot expect that there will be people stationed in the data center. They know that, okay, from today is when the sale is going to have, and then let us deploy new servers, let us power them on, configure the network, have storage configured, and then be ready for the load. This has to be happen very quickly. So if the demand is peaking, then the cluster has to be so elastic that it expands itself, it scales out in order to support the load which is coming as an input traffic, as an ingress or something. So this is where this automation of autoscalers help a lot. And then we have secrets and config maps, which we'll talk about in the next talk. And we'll just see how the operator's framework is. So this is how the operator framework is built. It has an operator SDK, which is used for building and developing operators. We have operatorhub.io, so we can just go there and then see what kind of operators are already there. If we want to write our own operator, we can write it by using some standards and then be able to publish it also. And then next is operator lifecycle management. It's called OLM in short. That is the CLI also what we use. This is for managing the lifecycle of your operator. And then next we have the metering. That is the metrics for the operator's resource usage. So if you see this framework here, right? You have we have clients, we have Ansible also. We'll come to the maturity models. So we have operator lifecycle management and the metering. So this all together, this is called an operator framework. And there are a lot of operators which are already there. Helm is what we use for the packaging and management. It's exactly like RPM. We have Red Hat package manager, right? So in a Red Hat machine, when we'll have to install an application, we just say that apt get install and then the name of the application. We don't say you need to get this shared object, we need to have this libraries, we need to have this dependencies. We do not define all that. We just say I need this package name, get it for me. So like that, Helm also what it does is when it packages the operators, the user does not have to take care about what goes in and what is required or or the steps which are required even before you get there. Everything is taken care in operators. So you can go to like operatorhub.io and then see how the operators are written, what happens when we run it, how the installation happens, and what is the maturity of the operator. Let's see the Helm and operator. This one, as I said, Helm is the package manager for Kubernetes. So it's actually called a Helm chart. So that is from the Helm repository, we can pick this chart and then apply it. The CLI for Helm is Helm. In the initial versions, we used to have Tiller also. But now with Helm 3.0 version, there's no Tiller. It's only, you can just use Helm. It was like client and server side components. But now forget Tiller, so we only have Helm now. And the second picture here, what we have is the operator. So operator is the method of packaging Kubernetes application and also managing. Helm is only for the package manager, but this is for deploying and managing the application. And so it takes care of the Kubernetes resources. And the most important thing for operators is the maturity models. So there are 5 levels here with respect to the maturity model. The first one is basic installation. Just like RPM-IVH, and then you give the location of the RPM or something, it just does a basic installation, right? So that is the first step. And then it is seamless upgrade. So in the like how we had seen, and we have actually seen a downgrade as an example in the demo one. So here the seamless upgrade is to be able to patch versions. Like now we are at Kubernetes version 1.19, right? Maybe you want to move your application from X version to X+1. So Helm will be able to help there. Then for the full lifecycle management, wherein it is application lifecycle management, storage lifecycle management. So what exactly storage lifecycle management is when we have to create persistent volumes, right? We'll have to create a persistent volume claims also. And then there is a retention policy, whether if the associated entity for which you are adding this storage, this persistent volume, if it gets deleted, do you want to retain it? Do you want to delete it immediately? Or do you want to use it for a reclamation in future? So the storage lifecycle management is also very important when we are handling with stateful applications. And then recovery mechanism, like in case anything goes bad, right? It is recovery. And one aspect I want to let you know that we have something called Velero. Velero helps you to take backup of a Kubernetes application, and this is very useful when you have a large set of custom resource definitions and lot of data being written also, right? It will be able to get into the cluster, understand all the entities and take a backup of the system. And then in case of any disaster, then we'll be able to recover back from this backup image. And the fourth one is deep insights. So it depends on the application, whether you are looking at some deep insights to act better, because your operator always like observe diff and then act, right? So for all the metric correction and load corrections, from this stage onwards, from stage 3 onwards, we use Ansible and Go. So Ansible based operators, they run playbooks, And they have roles to react to any changes for the tracked custom resources. And the last one you see is the Go. So Go-based operators, we write the code for the action we need to perform for the state of our CR changes. And the last one, level 5, is autopilot. So wherein completely like no touch, no human touch, and the systems are able to self-recover, self-heal, monitor, act on thresholds, and then scale up and scale down as required. Any anomaly detection. Anomaly is something that it never happened before, happening for the first time, and you need to isolate that and get to the root cause. So any abnormal detection or any tuning which needs to be done, right? Everything is automated. So that is the level 5 of this. And yeah, that brings us to the custom resource definitions. So yeah, custom resource definitions, as I think this is the only text slide which I have. So this is like an API resource which allows you to define what are the custom resources we want. Why do we need custom resources, right? It is actually custom resources are an extension of Kubernetes API. It helps us write resources which are not already present in Kubernetes. Like we have seen kubectl get deployments, right? I want to say kubectl get Lakshmi Gayatri. So Lakshmi Gayatri there becomes a custom resource definition because I will decide what has to be in the custom resource definition called Lakshmi Gayatri. And then I can write what I want to. So that makes it very extensible. So not all platforms which we have are so extensible and then easy to write. And then I can put in whatever logic I am looking at into the custom resource by my name. So these custom resources, they appear and disappear in the cluster through dynamic registration. So we'll see a demo here that will be interesting to understand why we need a CRD. Yeah, here I have taken the sample from Katakoda. I'm also going to share some of the learning places where you can go and check. So this is available for anybody. So that's when I have taken this example. Sorry. Yeah, I have taken this example so that it will be easy for you to go back and do it at your own pace. So the website name I'll be sharing on the slide also. So it is katakoda.com. You can log in using GitHub or LinkedIn or there are some other common login methods which you can use or create or sign it up for that. So here we are going to see this custom resource definition. So we'll see how the YAML looks like. And then we already have seen how to apply the YAML, right? And then we'll quickly see how to make your own custom resource definitions. Just a second. Yeah. So so in the custom resource definition, what happens is the kind is custom resource definition. We have seen the kind as pod, service, and deployment, right? So here it becomes custom resource definition, and then we will be able to choose whatever the name what we want, the short names and the verbs, the plural, other things. So here we are taking an example of thermometer, and that becomes the API endpoint also. So this is anyway, this lab environment is free. So anytime you can just go and do the lab. And during the lab time, it also explains like what is the concept about. So let us just try to apply this. I think the demos don't like getting paused in between. Yeah, it's back. So once we create a custom resource definition, we can use kubectl apply -f, the crd.yaml, and then using kubectl get CRDs, we will be able to see what are the CRDs which you have created. So within that CRD, we can also create the other types with the kind as CRD and then extend it. In the interest of time, I will just move on to the next slide. I think this demo seems to be hung. Yeah, but you will be able to do this. Don't worry. I mean, just go to Code and look for custom resource definitions. You'll be able to see that. And yeah, these are the learning platforms. So it's very important that whatever we learn, we continue learning. Otherwise, we forget. And Kubernetes is a release which rapidly keeps updating. Like every 3 months, we have a new release. It comes with a bunch of new features. So if we are not up to date, then probably it's out of mind, is out of sight. So keep looking at these are learning platforms. What I usually look at, one is Cube Academy. So in Cube Academy, you can learn everything about Kubernetes. They have short videos which are like 15 to 20 minutes duration and multiple chapters in them to get an idea about the concept. And then for hands-on experience, like if you're interested to learn by yourself, then you can use the Katacoda, which is free. And then the next one is Code. Code you can use for if at all you want to appear for the certification exams. It has a handful of material there. And then, yeah, lastly, this is, yeah, so thank you so much. Hope you enjoyed. That's my LinkedIn handle. So in case you have any questions on this talk, so please connect and you can ask. And thank you so much for the opportunity.
Thank you so much, ma'am. That was a wonderful session. And moving forward, we've got our next speakers, and then we've got 3 people in this particular session. Ms. Ranjani Swaminathan, who's a senior MTS at VMware, Ms. Ramya Victor, Java Storage File System QE at VMware, and Ms. Shweta Lakshman, MTS 4DT, VMware.
Hi, good afternoon all. My name is Ramya Victor. I'm a senior MTS at VMware as well as the Women to Code City Director for the Bangalore chapter. So I have over 7 years of experience. So we are very passionate about machine learning. So today we'll be doing a workshop on time series with my friend Ranjani. So over to you, Ranjani, to introduce yourself.
Hi all, I'm Ranjani Swaminathan. I am a senior MTS with VMware. I have over 11 plus years of experience in the software industry, and I am one of the city directors for Women Who Code Bangalore Chapter 2. And one of my recent passion has turned out to be machine learning, where we have tried our hands on several problems, and time series forecasting is one such problem that we will be sharing about today. Yeah, over to you.
Yeah. Okay, so let's quickly dive into some of the interesting things that we will walk through today. So let me share the slides. Okay. So as our title says, today's talk is about demystifying time series. So before we go into hands-on and make ourselves more well-versed with time series, let us go through a little bit basics on what we want to cover today. So when we are talking about time series, what exactly is time series? So before we understand time series, let us understand few concepts. So by end of understanding this concept, you will get a brief idea on what time series exactly is. So the first concept that I would like to share with you is time series data. So what is this time series data? So time series data is nothing but whenever a data is associated with time factor, right? That data is referred to as time series data. So one such example can be like how we are going to explore today is we are going to see how to forecast weather for a given city, say for example Bangalore. So here we are going to have historical data of Bangalore from say 100 years. So here the data that we have is about average temperature. So this is the data, and since it is associated with time, that is from past 100 years we are having data. So this data is known as time series data. Okay, moving on. So next one is time series analysis. So what exactly it means? So as the name indicates, right, what we are going to do is we are going to do analysis on the time series data in order to see what are the different trends and patterns in that data. So if we take our today's data set that we are going to explore, so in that data set, we are going to do some EDA to understand what are the patterns that have been represented in the historical data. So when we do the hands-on, you can see that the temperature will increase in the month of March, April, May. So that is kind of persistent over the years. So that is one of the pattern or trend that we can see in the time series data. So the entire process that we do to understand or see that pattern is called as time series analysis. Okay, the next one is time series forecasting. So what is that? So as the name indicates, right, forecasting is nothing but predicting the future. So the same thing applies here. So when we are trying to use the time series data and apply some model to it, like there are various time series model. One such is the ARIMA. So suppose we are taking the time series data and we are applying some model to it in order to predict some data about the future. Okay, based on the historical data. This is called as time series forecasting. So today we are going to do more hands-on on time series forecasting. Okay. So when I talk about forecasting, basically there are two types of forecasting that generally people should be aware of when they're dealing with time series. So the first one is called as qualitative and the second one is quantitative. So what exactly is qualitative? So as the English name suggests, right, quality is the emphasis here, not the quantity. So here what we emphasize on is that when we do not have huge historical data, but still we want to do some forecast and prediction, right? That time we choose the qualitative forecasting approach. So since we do not have any historical data, we cannot see any patterns in that and we cannot assure that that pattern will repeat, right? So then how do we do the forecast here? So here one of the approach used here is we call a group of people who have a really good knowledge in the domain of the problem that we want to do forecasting. So suppose we want to forecast the weather and we do not have historical data. This is just an hypothetical example. So that time what we do, we call a set of folks who have good knowledge on the weather data over the past few years, and we use their knowledge in order to predict the future temperature. So this is called as qualitative. Because here humans are involved and no mathematical model per se is used, the forecasting is usually biased. So that is one concern in the qualitative. So one such example for qualitative can be the Delphi forecasting method. So you can just Google on that. That's really interesting to explore. The second one is quantitative. So quantitative means quantity. That means you have some huge quantity of data. So quantitative forecasting is used when you have huge amount of historical data available. So with this huge amount of historical data, what we can do is that we can use that data, see some patterns in that data, and then we can try to use that pattern in the data and the historical data to do some prediction in future. So this is what we are going to emphasize in the workshop today. That is the quantitative forecasting. Okay. Yeah. Now Ranjini will take you through about the approach for forecasting and application. Over to you, Ranjini.
Thanks, Ramya. So as we have seen the different types of forecasting, and we are going to take quantitative forecasting, where we have a lot of data that is available, historical data available for a particular problem, and trying to forecast for the same over the period of coming years. So the approach for forecasting, as our slide mentions, these are the steps that are involved in forecasting. So the first step is defining the problem, as it would be for any solution that we are coming up with. First step is to define the problem. So now we have a problem of predicting the weather or the average temperature for Bangalore city for the next year. For example, if we take the next year for which we are going to predict, that is the problem statement. So the next step would be to collect data. So now that we have a problem statement, we have to collect the appropriate data set from the different open sources available, Kaggle or Data World or Uniset or all the other data sources available. We collect the appropriate data set on which we can work so that we can achieve a solution to our problem. So the next step after collecting data is to analyze the data. The data cleaning and making all the exploratory data analysis all come under this step of analyzing the data. So whatever data we acquire may have null values in others. So we clean them. We try to resample the data. So if we have a huge set of data, and say for example you want to predict the weather or average temperature of Bangalore monthly and not daily, but you have daily data in the historical data set that you have collected, you will have to resample, and you can downsample it to monthly data and then make your predictions. So that is the sampling part of the analysis or the exploratory data analysis. So there may be various steps like this which are involved. So once we have a clean data set, we will then try to do exploratory data analysis. If there are variables or there are many variables available in the data set, we try to see the correlation. And as it is a time series data, straightforward, there is a trend, seasonality, and what is the cyclicity of the data repetition, or all these are the factors. For example, if there is a trend in the data set, we say that it is increasing year on year or it is decreasing year on year. Or you can also find a trend like in the month of March, it will be the highest, and in the month of December, the temperature would be the lowest. Kind of intuitions can be got from the data. And seasonality. Seasonality is the repetition of several patterns over a period of time. So for example, in our data set of Bangalore's temperature, there may be a higher temperature recorded during March and April or February-March timeframes, and the lowest temperatures recorded during the December, January or November, December timeframes. So this is the seasonality, when the pattern repeats again. Like every year, March and April will be the peak, and every year, November and December will be the lowest temperature hit at the year's duration. So that is the seasonality in the data set. And for this, as this is yearly data set, this is called seasonality. If there are repetition of pattern in several data sets which are not following yearly patterns or monthly patterns, they may be acyclic. Those are called cyclic patterns in the data. So these are the several factors which we can analyze, and we can have some intuitions from the analysis that we have made. So as I mentioned, we saw that there will be a higher temperature during several periods, several months in the year, and the lowest temperature hit at several months in the year. Those are some of the insights that you can draw by doing exploratory data analysis on the time series data that is in hand. And the next step after analyzing this data is to actually solve the problem of prediction. So we should build a model based on our understanding, and then predict the temperature for the upcoming year or so. That would be the last step that we would do in finding the solution or our prediction problem. So these are the basic steps that are involved in forecasting. Yeah, we can proceed. Yeah. So as we have seen some of the steps that are involved, now what are the applications of this time series forecasting in our real life scenarios? So we have listed several of the applications of time series forecasting. Like the first one is economic outlook. So we can, based on the history of our GDPR or the development numbers that we have, we can predict how our world economy is growing or is it deteriorating, and kind of such things can be forecasted, or analysis can be done, and forecast can also be done on the economic status of the world. And the next is sales forecasting. So as we see, every company would have a sales team, and the sales numbers is what defines their success. So every company would invest in having some forecasting for their sales to get to know how their upcoming year would be, or where to invest more kind. So such questions can be answered by the sales forecasting. And inventory planning. So in case of warehouses, there will be an inventory that is maintained for the retail business. So in every warehouse, what can be stored, how much can be purchased, and how much will be sold. Based on that, the planning for purchase and stocking in a warehouse can be done. That is one of the applications. And workforce planning. This also means like, to give with an example for workforce planning, we have the airline industry, where we see that during, at least in India, during the summer holidays, where during the April or May time frames, there will be many people who are traveling to various places. So at that time, many extra flights would be deployed, and they may be functional. So such kind of deployments or new deployments can be planned, and workforce can be planned accordingly based on our historical data that has how many people have traveled during the time frame to different places. So we can get an insight about how much more resources to deploy during April-May time frame from specific location to a specific location for working on the airlines. So such is a workforce planning application. So the last one is what we have taken, the weather forecasting. So right now, everybody has the habit of, if we have to go out, we have a habit of checking how is the day going to be. So if we are planning to go out to a park or somewhere with our kids, we see that it should not be a rainy day. We make sure that the weather predictions are favoring us before making a decision to go out. So such kind of tasks can be planned based on the weather forecasting. So these are some of the applications of our time series forecasting. And with this introduction, I think we can move into the workshop directly. Yes.
So let us move on to the hands-on now. So as I said that we are dealing with quantitative forecasting, so we need a historical data. So the data that we have taken is for weather forecasting, as explained by my friend Ranjini. So we have got the data from this website called data.world. So you can just go to data.world/data-society/ and you can search for global climate change data. So that is the data set that we are using for our hands-on today. So you can just go here and download the data set. So let us go to the Jupyter node. This is where we have the code working for our model. Okay, so we know the problem definition. As mentioned, we are using a historical data in order to predict the average temperature for a given place. So before we move on to the actual coding, there are some of the imports that we want to focus here. So pandas, NumPy, Matplotlib, these are the generic libraries that are used in most of the machine learning model coding. So here I want to emphasize on this ARIMA and mean squared error. So ARIMA is one of the models used for time series. Later in the code, Ranjini will give you more insights into what exactly is ARIMA. And mean squared error is one of the methods used in the time series to evaluate the accuracy of the model that we have built. So we have downloaded the data into a CSV here, and we are reading it into a data frame. So when we look at the data frame, we can see the various attributes in this data set is average temperature uncertainty, city, country, latitude, and longitude. So this data set, we notice here that it has the average temperature for the majority cities across the globe. So moving on. Let us take only one city now, because we see here the number of entries in this data set is pretty huge. So here for the hands-on purpose, let us focus on one city called Bangalore and see how the analysis can be done and forecasting can be done. So here we are picking up the city whose entry is Bangalore. And now let us do some cleaning of data. So before we do that, let us understand how many entries are there in Bangalore. Here we can see that there are around 2,600 plus entries for Bangalore. So now, as you know that the latitude and longitude for Bangalore will remain the same, so it doesn't make sense to include those attributes in our model. So let us take the attributes which are important for us. So leaving those, the name, the longitude and the latitude, the attributes that are of relevance is average temperature and average temperature uncertainty. So that is what we have taken here. So this is how the data frame would look. We have just printed the top 5-6 entries by using the head command. So this is what you can see. So now what we will do is, as you see, we are going to use time series. So as we mentioned, for time series, the data should be relevant with the time. So as you can see here, the date is a separate attribute in our data frame. So now we will make this date as an index to our data frame data. So that's what we are doing in the subsequent cells. If you see, we are setting the index of this data frame to date instead of having just the row numbers. So post setting, you can clearly see that now the index of our data frame is date. Now let us understand how the data is visually seen. So to see that, we are using the plot library that we had imported earlier. So what we are doing here is we are plotting our data for the Bangalore city according to the various years on how the temperature is visually seen. So on plotting, you can clearly see here that, let me just scroll down. Ranjini, can you just scroll down? Yeah, so here you can see, since we took two attributes, that is the average temperature and the average temperature uncertainty, we can see here the data is too clumsy. Because we have taken for many years, almost more than 100 years, so we cannot visualize properly what exactly is happening. But one thing which is very prominent over here is there is a discontinuity in the data that is being plotted. So that is a clear indication that we have some NaN values over here. So let us see how we can impute these NaN values. So now to impute these NaN values, we have to come up with one logic to understand, right? So let us see what logic we can use. So as I told you, since the data was clumsy, what we have done is we have taken a mean of the data over a year and plotted it so that visually it can be more palpable to see. So the same data above here is taken by plotting the rolling mean. So here you can clearly see, right, there are multiple gaps over here. These indicate that it is a NaN value. So now, how do we impute the NaN value? So there are multiple ways to impute the NaN value. So when I tell impute, I am referring to how to replace this NaN values with a suitable numerical value. That is called as impute in machine learning jargons. So there are multiple ways to impute. There is like taking the mean value in that column, taking the median value in that column. But the most commonly used one is called as interpolate. So in interpolate, what we are doing, there are different methods applicable in interpolate, but here we are using the method called time because our data is confined to time, and on using this time method, we seem to get a better representation of the NaN values with the numerical data. We are using the time method, and that is the most commonly used method for interpolating time series. So we are choosing that. So here you can see that we have done interpolate for our data frame, which contains the Bangalore data with NaN values. So on doing interpolate, we can see that when we print the data frame, we can see that all the NaN values have been replaced by one suitable values. So there is no more NaN values. But how can I visually confirm that there is no more NaN values? I can go ahead and again print out the graph to understand whether there is any gaps. As you can see here, there is no any gaps over here. That clearly shows that all the NaN values have been removed and they are imputed with an applicable value which is in trend with the data that is present. So, and when I said in trend, let us now understand, as Ranjini explained earlier, that yeah, Ranjini, just hold on here. So as Ranjini explained earlier, whenever we are dealing with time series data, right, there is certain trend in that data and certain seasonality that we have to look at. Here, if you see, right, so whenever we talk about a trend in time series, right, we tend to focus on stationary data. So the data should be pretty stationary with a repeating pattern. But here, if you see, right, the data is not having a specific pattern per se. Here the data is going up, down, and doesn't follow any specific pattern. So what we have to do, we have to remove this trend and make the data more stationary so that we can see the inbuilt seasonality in that data. So how we can do is that there is a method called diff, using which we can kind of remove the unstationary factors in this data and make it stationary. 1 minute, Ranjini, you're going too fast. Just go a little up, please. Scroll up. Yeah. So there is this method called diff, using which what we can do is, let us consider the first order difference. So we take the previous value and the next value and we do a subtraction to find the difference between them, and then we plot in the graph. So we do that for each entry and its previous entry in the entire data frame and then plot the graph. That is when we can clearly see the seasonality and the data, and we make the data stationary. So here you can clearly see that when we print the data over here, it follows a certain pattern here, right? So with this pattern, we can clearly see that there is definitely a seasonality in this data, and the method that we are using to make the seasonality more amplified is called as diff. This is the first order difference that we are using. And also one thing that we wanted to emphasize here is, since the data that we had for Bangalore was more than 100 years, in order to visually give you a better representation, we have just taken data for around 8 years and we have plotted here so that you can clearly see how visually it looks. Ranjini, can you move down? So after doing the diff method, right, you can clearly see the pattern over here. Since we are plotting for both average temperature and average temperature uncertainty, right, we can see both of them overlapping here. But our more concern here is about average temperature, which we want to predict over here using this data set, right? So let us exclude the average temperature uncertainty and kind of focus only on the average temperature to see how the plot looks. So when we just focus on average temperature, right, you can clearly see, can we scroll down a little bit, Ranjini? Yeah. Yes, that's fine. So here we can clearly see a seasonality. So what exactly is that seasonality? See, at the beginning of this year, we can see that the temperature is high and then it comes down. Again, towards the end of the year, we can see there is a peak and again it comes down. So this up-down pattern is repeated. If you move on to the next year, right, 1797, you can see at the beginning of the year, the temperature is high, then it goes down. Again, there is a spike and then it goes down. So this pattern kind of repeats almost in a similar way throughout the year. So this is the seasonality. So seasonality is nothing but a pattern which is being repeated consistently over the entire time duration. So this is what we want to see, because this is the pattern which can help us to predict the future data. So now Ranjini will take you to understand how we can use this pattern and kind of forecast the future temperatures for the Bangalore city. Over to you, Ranjini. Ranjini, I guess you're in mute.
Thanks, Ramya. So far, we have seen how we have acquired the data. So we have defined the problem statement. We had acquired the data from a source and we had done the cleanup of the data, and we have seen how we can analyze the data. So the problem in hand now is forecasting the data, the actual forecast that we are interested in. So to have a forecast of this data, what all do we need? So what model do we use? And all these things have a role to play, and how we choose the model which we have to use. So that is the part that I will be focusing on now. So as Ramya mentioned, we had removed all the trends and other components from the data set. Now the data is stationary. So the model that we are going to use for prediction is ARIMA model, which is auto-regressive, integrated, and moving average model. So why do we use an auto-regressive model for this problem now? So as we have seen that there is a relationship between the data that has occurred in the past and the present data. So as there is a relationship, we see that auto-regressive model can be used. And we have to predict, so for example, if we have to predict for 1 year, then it's a longer duration and not a shorter duration. So we are using an integrated model to predict it. And moving average is something that can be used when the present data depends on the residuals or the errors of the past. So to get higher accurate predictions, we are going with the ARIMA model. So the reason for using ARIMA model is being specified as 3 folds, that the data is the past data and the present data are correlated, which we can show using this autocorrelation plot. And the second one is to tell that the prediction is done for a longer duration, so it is integrated. And the moving average is when the predictions are going to be dependent on the residuals or the errors of the past. So that is the explanation that we have given for using ARIMA model. So as I mentioned, how to check that the data, the present data, is correlated with the past data. So that is why we have used the autocorrelation plot. This autocorrelation plot that we have plotted using this method shows that there is a positive correlation of the data set for a period of approximately 2.5 lags here. So this is how we will choose the parameters for ARIMA model. So for ARIMA model, we have to give some parameters like what is the lags, number of lags for which you have a positive correlation, and the order of difference that we are taking on the data set. As we have done one diff, the order of difference is 1. So the order of difference and the Q, which is the residual, which is for the moving average. So those are the 3 parameters that we have to specify for the ARIMA model. So now let's go straight into the ARIMA model. So we can use this ARIMA model from the stats model library. So from stats model, you can import this ARIMA model and use it in our code. So we see that we have defined a model to see the statistics of the model. So what will be the AIC, BIC and all these values which will help in understanding what will be the accuracy of the model. So we see that the parameters of the model can be seen by the summary value, and we can then move to the actual implementation of the model as such. So we also see that the way that we will confirm that our model has been accurate is using the mean square error, or residual is something that is residual errors is the method that we will use to fit and find the errors. So that plot is also done. For the data set in hand, we have done this ARIMA model summary, and we have done this residual errors plot. So we see that the residual errors is having a Gaussian curve, so that the errors are centering around 0, and it is reducing when it is moved forward in both the directions, moved backward or it is moved forward. So this is a good a model that can be used for the problem in hand, and the predictions are expected to be of more accurate ones. So that is the surety that we get by doing this plot and checking the values. So now is the implementation of the model and prediction as such. So for any prediction with a data set in hand, we should have a training data set and a test data set. So that is how we have also split the data set into training and test data set. So we have a 66-33% training and test data set split that we have done, and we have so that the model does not learn from all the data, so that there is some data which is unknown for the model to predict and test the accuracy of the model. So with the first 66% of data that we have, we are going to build the model and learn. And on the remaining 33% of the data, we are going to do predictions and check the accuracy of the model. So as I have mentioned, we had a positive correlation till 2 lags. So the 3 parameters that I mentioned for ARIMA model are the number of lags where there is a positive correlation, that is 2, and the order of difference that we are using, that is the first order difference that we had done previously. We had done diff method once, so this is the first order difference. So the other parameter for difference is 1, and the next one is the residual errors, which is 0 that we have considered. So from this, we have again built the model and trained it on the 66% of data, and model.fit would be used to fit the model. The model is built, it is fit on the data set or the training data set, and then we do the prediction using model fit.forecast. Forecast is used to do the predict part. So once we have done all these, we should then find out whether our predictions are accurate, or there should be some way to find the accuracy of the model that we have developed. So as we have seen on the test data, we have done the predictions, and we have got some predicted values and the expected values. So these are the predicted and expected values that we have got. If we just look at the values, we see that they are more or less equal, and the difference is less. So this is by seeing the results we get to know these values, but there is a way also to do it using a Python method to find out the mean squared error. So let us try and do the mean squared error on the test data for our predictions and the expected values. So that is what we have done here. We have done the mean squared error calculation on the test data and the predictions that we have done. So as we have seen, the mean square error is plotted as the graph, and we see that the difference between the predicted value and the expected value are usually very less. So from the data also we can see that, and once we have done this mean squared error, we got a value of 0.908, which is very less. So as we know, the lesser the mean squared error value, the accurate the model prediction that we had done. So this is how we ascertain that the predictions that we have made using this ARIMA model are more accurate. Okay. So this is the complete model that we have implemented, and we have tried to predict. So now the solution, the problem, the data acquisition, the actual model building, and the prediction, all of these are covered.
So thanks, Ranjini. So this is what we wanted to explore in this workshop. We wanted to show you how you can use any data set relevant to the applications of time series. So you can pick up any data set from Kaggle or even from the data from the website that we have taken, and you can try exploring the same flows that we have covered here. So I believe you can just go back and revisit this recording and see what are the steps we have used. So this is the basic of time series, and there are a lot of advanced version algorithms of time series which will be good for you to explore, given that the foundation is clear. Right, Ranjini?
Yeah. So as Ramya had mentioned, there are various other models that can be explored. We had taken ARIMA based on the data and the type of data that we have chosen, as it is stationary and it is something that is the data is the present data is related to the past, and the errors are the residuals of the data also. The present data is dependent on the residuals of the errors also. So those are the factors that would be influencing the model that we are choosing. So there are other models that can be explored, like auto-regressive separately, or only moving average, or there are other least.
ARIMA also. ARIMA is also one of the algorithms, right?
Yeah.
So, yeah. So, and I think one more thing that I would like to add on to what Ranjini said is that we do have, like how women in data science do conduct a lot of wonderful sessions on data science. So as Ranjini and I are also part of the Women Who Code nonprofit community, there is a multiple events that we also conduct related to data science, because we both co-lead the machine learning study group. So you can also check out our meetup and see if you are of any interest to any of the machine learning events that we conduct. Please feel free to attend them also, because they are also absolutely free, just as in Women in Data Science does. So, and I think, Ranjini, we should stop sharing and probably conclude our workshop. Yeah, thanks. And we are very thankful to Women in Data Science Mysuru chapter for giving us this opportunity. Yeah, over to you, Ranjini.
Thanks to Women in Data Science for this opportunity. So I believe like all of you have good takeaways from this session, and would be working more on time series without any hesitation. You might have got a good start here. Thank you all for sparing this time to learn on time series.
Yeah, thank you all.
Thank you so much, ma'am. That was an amazing session. And next up, we've got Mrs. Kumari Deepshika, who's a senior data scientist at NVIDIA. And today she's here with us and she's going to be talking about interactive conversational AI with NVIDIA, Jarvis, and Nemo.
Excuse me, ma'am. Can you please unmute your mic because it's on mute right now?
Hope it is unmuted now.
Yes, ma'am. It's audible now.
Okay. Thank you. Hello, everyone. Good evening. I would like to thanks Usha and the whole Women's in Data Science team for having me today for this session. Myself, Deepshika. I'm a senior data scientist at NVIDIA. In NVIDIA, I worked in developing end-to-end optimized deep learning pipeline. My research area around in reinforcement learning, active meta learning, and multimodal. Today, I'm going to talk about the challenges of conversational AI and how in NVIDIA we are tackling those challenges with Nemo and Jarvis. Today's session has divided into two segments. For the first segment, I'll cover the Nemo, which is a neural module toolkit, where I'll discuss how essential it is to create very accurate model for conversational AI and how Nemo can help you to do that. I'll also do walkthrough of some of the application that is built or that model that is trained using Nemo. In the second segment, I'll cover Jarvis, where I'll talk about the challenges of deployment and what are the optimization technique that you can use, which is helpful to give you near real-time inference. So without investing time, let's get started. So what exactly is conversational AI? In layman term, if you have to say what is conversational AI, it is anything that like a messaging app or speech-based assistants and chatbots or automated communication which give you a personalized customer experience. We called it as a conversational AI. Now, the real power of conversational AI lies in its ability to simultaneously carry out highly personalized interactions with large number of individual customer. See, conversational AI is a two-way interaction which happens between human and AI. And when it is combined with automation and artificial intelligence, these interaction can connect humans and machine through virtual assistant and chatbot. Now, to make such conversational AI, it is really needed that the model should be very precise and efficient. Also, it needs to understand what is being said across every context and not just syntax of the conversation. Understand the nuances and then respond in real time. In past couple of years, the state of the art accuracy has increased and it also leads in increase in model size. But at the same time, you are required to do the deployment in real time. For say, the state of the art model currently that is being used has more than 8.3 billion parameters, which is a large model. But with time, this model is growing, and it is expected that it will grow more in the near coming futures. But at the same time, we also have to manage the real time inference, which is much needed in a conversational AI models. You can see various applications and industries are utilizing conversational AI in multiple ways, be it in a video conference or call center or retail assistance or maybe in car assistance. Apart from this, in daily life, you are using some form of conversational AI, like when you wake up in the morning asking for direction on your communicate, or when communicating with your chatbot while shopping online, you speak in your normal voice, the device understands, find the best answer, and replies with a speech that sounds natural. So there are various places where we are using conversational AI without realizing it. And there are places where industries are getting benefited by utilizing or by adapting the conversational AI or automating the conversational AI model in their regular workplace. Now, let's see what are the challenges to build such a conversational AI. For example, here in this diagram, what I'm showing here, I'm trying to show a multilingual chatbot where someone is asking question in English, and the response should be in Hindi. So if you see that, what would be the workflow is like, first the audio of the person will be feeded, the ASR pipeline or a speech synthesis pipeline will run. I'll cover the detail of ASR later in the talk. Here, the ASR consists of the feature extraction, acoustic model, decoder, and to make it more efficient, we are using language model as well. Once we have the transcript of this audio, that is what date is the Hindi New Year, then machine translation model will work. What machine translation model does that it will transfer this English transcript into Hindi transcript. Now once you have this Hindi transcript, your question answer model will run to give you the response in Hindi. Once you have the response in Hindi, the next step is to get the speech or the audio from the text that you have. And for that, you will run text to speech model, which again will consist of multiple components. So here it has a speech synthesis and voice encoder. Finally, you will get the response in Hindi, that is 3rd of March, which is written here. Now, to complete this whole pipeline, there were multiple components that was involved in the pipeline. And to run this pipeline, it is very much needed that these modules should be integrated, and not just integrated with each other, but also the infrastructure that is provided to it. Second challenge is mixing and matching, manipulating and experimenting to get the best performance is very hard. So how NVIDIA is working will help to solve this problem through Nemo. We'll see this in next slides. So NVIDIA Jarvis platform consists of two components. The first component called as NVIDIA Nemo. The second component called as NVIDIA Jarvis. NVIDIA Nemo is for training and fine-tuning of conversational AI models. It could be your speech model, it could be your CV models. NVIDIA Jarvis is for deploying of these models efficiently on a scale. Nemo models leverage, so as you see in the picture, Nemo, the whole module, NVIDIA neural modules works or uses NVIDIA accelerated libraries, CUDA libraries in the backend. But as a programmer or as a developer, you are not required to know what has been written to accelerate your workflow using NVIDIA CUDA libraries. On top of that, we have optimized PyTorch framework to accelerate the workflow. NVIDIA models, Nemo models leverage PyTorch Lightning modules and are entirely compatible with the entire PyTorch ecosystem. This means that users have the full flexibility of using the higher level APIs provided by PyTorch Lightning as well as the library provided by PyTorch directly could be used. Now, neural module are logical blocks of AI application which takes some typed inputs and produce certain typed output. Why it is needed to give a typed input or typed output, I'll talk about it next slide. But in neural module is the central concept of Nemo. It has collections of module for core tasks as well as specific to speech recognition, NLP or speech synthesis that help develop modular, flexible, and reusable pipeline. Nemo can be used to train new models or perform transfer learning on existing pre-trained model. We have experienced that transfer learning gives better performance in less time than training it from scratch. And we'll see this example later on in the talk. Pre-trained weight per module help accelerate model training for domain-specific tasks. For Nemo developer, model definition is not restricted to only neural network, but it also has infrastructure supporting those networks wrapped into a singular cohesive unit. And these will include neural network architecture, which will be the modules that are required for the model, dataset plus data loader, which will have all the components that prepare the data for consumption during training or evaluation, pre-processing and post-processing, all of the components that process the data set so they can easily be consumed by the modules. And the last component would be optimizer and scheduler, which is the basic default that work out of the box and allow further experimentation with ease. Nemo is completely open source code and it is available on the GitHub. How actually Nemo provides very efficient training. Using Nemo, basically one can use directly mixed precision to accelerate training speed while protecting against noticeable loss. What happens that when one does automatic mixed precision, it uses tensor core. Tensor core is a specific hardware unit that comes with NVIDIA latest architectures like Ampere or Volta to accelerate large matrix to matrix multiply add operation by operating them on half precision inputs and returning the result in full precision. And we all are aware of that. This matrix to matrix multiplication and add operation is the fundamental of deep learning compute. And that's the reason by using this tensor core, we expect it to give very good speed up neural network which usually use massive matrix multiplication can be significantly sped up with using mixed precision and tensor cores. Nemo also have this capability of multi GPU and multi node training. So as a programmer you are not required to do any major code changes to use multi GPU or multi node training except few configuration that you have to do in your config file. It also take care of distributed training across GPUs, that is model distribution as well as data distribution. In that way it makes a lot easier for a programmer or a researcher to do the training and experiment with the models. Now let's see neural modules in little more detail. This is the flow diagram with the example of speech synthesis or automatic speech recognition model. So the whole neural module could be defined as the block diagram of different modules. The first module in this picture is audio to text data layer. What it is doing basically, it is proceduring your audio and corresponding text file. Then in a ASR pipeline, you will have some kind of pre-processing. Let's say you can apply a Fourier transform on audio signal to get something more useful, a spectrogram, which is a representation of the energy levels of each frequency of the signal over the duration of the file. Further, you can make it more useful by using a MEL spectrogram instead of a normal spectrogram. So these kind of pre-processing would happen in audio processing. Once it got pre-processed, it will send to Jasper encoder. Jasper is a model developed by NVIDIA for the ASR application, and we'll see in detail how the architecture looks like, how does it perform. After Jasper encoder, it will go to the Jasper decoder for CTC. Here we are using greedy CTC decoder. We can use beam search with the language model as well. Then CTC loss is applying, and we'll see how basically CTC helped, or when CTC comes into the picture, basically how the ASR pipeline becomes way easier. So these are the basic modules that is in your ASR pipeline. So here you can see we had data layers, we had data augmentation, then encoders, decoders, and then language models. Now let's see in generalized fashion what are the modules that is present in Nemo. The first module is trainable modules. These modules are that contain trainable weights inherit from trainable NM. That's basically contains the model file, weight file, where which actually going to be trained. Second is data layer. This layer that perform the feature extraction, transformation, loading of data, feeding of data. So this module consists of these operation. Then the third is the loss modules. This module basically compute the loss function. The fourth and the last module is the non-trainable modules. This module basically does example like this module does operation like table lookup, data augmentation, greedy decoder. So in our previous workflow, the first module, that is audio to text data, will actually fall into data layer. The audio pre-processing would fall into data augmentation. Then CTC loss will fall into loss module. Greedy CTC decoder is a non-trainable module, and the Jasper encoder and decoder for CTC will come under trainable modules. So this is a simple, this is one example with the ASR pipeline. These four are the major modules that will be for all the conversational AI models. Now, I mentioned that the input and output in neural module is typed. Let me start with little motivation why it is needed. Suppose you train a model, then give it to someone, but they say it doesn't work. Then you spend an hour to figure out what exactly is the issue. You realize that you have trained it on 16 kilohertz of data and they are using 24 kilohertz of data. So that is the reason that it is not working. Further, you modify the code a little and it no longer works for you. Then you again spend an hour to do the debugging and you realize the error could be the encoder output is time based channel, but decoder expect batch based channel. So that is the reason it is not working. And that's the reason it is very necessary that your input and output of neural modules should be strongly typed. Now let's see example of how exactly it is different from the regular tensor. So neural type is type of input and output to neural modules. This is similar to named tensor, but it has additional parameters, and these additional parameters are axes that represents what varying a particular axis means, like batches, time, etc. The second is elements type, which represent the semantic and properties of what is stored inside the activations. Could be audio signal, could be text embedding, could be logics, etc. Now, user can define their own types and type hierarchies. So, for the example, let's see, Mel spectrogram is a type of a spectrogram. MFCC is another type of a spectrogram, but you cannot change or interchange Mel spectrogram by MFCC spectrogram. However, your data augmentation can expect any type of spectrogram. So user can define their own types and type hierarchy. Here, red line basically shows all invalid connection, and the green arrow shows the valid connection. So the neural type that you have defined can inherit any of the type of a spectrogram, but you cannot interchange those spectrogram. Uh, Now, if you want to define your own neural type itself, how you can do it? So there are various ways. Either you can do it in your Python. So what you will do is that if you need to add your own element types, you can create a new class inheriting from element type. Here in this particular example of code snippet, this example ever we created a special element type called as class for bounding box, which stores exactly 4 values. We also add our own axis kind, which is image here. So the final neural type, that is, let's say T1, represent list for batches of list for images of bounding boxes. Under the hood, it should be a list of 4 by 1 tensors. Nemo core package comes with common collection for PyTorch built-in libraries. It has 3 major collection: Nemo ASR, which has a model, which has a pre-trained model, Jasper, QuartzNet, RNN with attention, transformer based; Nemo NLP, which has natural language processing models, BERT and its variations, glue tasks, language modeling, neural machine translation, intent classification, and many more. Then Nemo TTS, which has Tekkatron 2, fast speech, and WebGlow. Let's say end-to-end speech recognition pipeline inside Nemo. ASR is a challenging task in natural language as it consists of series of subtasks such as speech segmentation, acoustic modeling, and language modeling to form a prediction from a noisy, unsegmented input data. Luckily, the introduction of the CTC, which is also called as connectionist temporal classification, removed the need of pre-segmented data and allowed the network to be trained end-to-end directly for sequence labeling tasks like ASR. As a result, a CTC-based ASR pipeline consists of following blocks in general, which is shown in this picture. Of Here, what is happening? First, it is receiving the raw audio, then feature extraction is running. What it does is that audio signal pre-processing happen using normalization, windowing, spectrogram, and others. The second component is acoustic model, a CTC based network that predicts the probability distribution over vocabulary characters for each time step. For this block, we use NVIDIA's high performing acoustic models, that is Jasper and QuartzNet. The third component is decoding. Decoding could be greedy, it could be beam search or beam search with language model. In the greedy approach is the simplest strategy for the decoder. The later with the highest probability is chosen at each time step without regard to any semantic understanding of what was being communicated. Then the repeated character are removed and collapsed and blank token are discarded. So we can see in this particular example, the hyphen symbol is has the probability of zero point 0.2 at a timestamp t0. So at the timestamp t1 also it has the highest probability. So it is selected without considering the context of other alphabets or checking preceded or the successor alphabets. The second is the beam search with language model. A language model can be used to add context and therefore correct mistakes in acoustic model. A beam search decoder weights the relative probabilities the softmax output against the likelihood of certain words appearing in context and tries to determine what was spoken by combining both what the acoustic model thinks it heard and what is likely next word. So this way it works better than the greedy decoding methods. This slide basically talks about what we have just seen, the three the decoding methods, that is the greedy methods, the beam search with language model. How does it work? As I mentioned here, for this particular lab session, I'm considering the NVIDIA models, acoustic models. These are Jasper and QuartzNet. Just to give a brief description of what Jasper is. Jasper architecture consists of a repeated block structure that utilize 1D convolutions. In a Jasper, K by R model R is chosen. Now here K is basically represent the blocks and R represent the repetition of the block, or R is the sub blocks. So this here in the picture I have extrapolated the R block. R block it consists of 1D convolution, batch norm, ReLU and dropout are grouped into a single block, which is then repeated k times. We also have one extra block at the beginning and a few more at the end that are invariant of k and r, and we uses CTC loss. The second model that we do have is QuartzNet. This is a variation of Jasper, and the key difference between these two is that it uses time channel separable 1D convolution instead of regular 1D convolution, and because of which it allows dramatically reduce in number of weight while keeping similar accuracy. So you can see the difference in the parameter that both the model have. QuartzNet have approximately 19 million parameters, while Jasper have around 333 million parameters. Now, if we look into the code of the workflow that we have talked about for ASR initially, what would it look like? First block would be you would import the Nemo the way you used to import Python libraries. Then you will import the ASR Nemo ASR collections. So that could be imported using Nemo -ASR. Then you will define your data layer, your Jasper, your decoder, your encoder, your loss, and later on you will start the training. Before starting the training, you will define neural module functions. So these are the basic steps that would be required. uh, I will do a code walkthrough that will give a better perspective on what are the components that is involved in a Nemo and how you can define those components. So just give me a second, I'll reshare my screen. So here we are. So I have created three example for this session. The first where I talk about, which will give the perspective of what all are the components that is essential in a Nemo. And second is how you can do the training of ASR model. And third is how you can do the training of your question answer model. So here the first step is that, as I mentioned, is to import Nemo. You will require to install Nemo, that you can do using simple pip command, or you can use the GitHub of the repository to do the installation. Here we are importing all the necessary libraries that is needed. The second step is that you have to create neural modules. Like we have discussed these modules: data modules, trainable modules, non-trainable modules, loss modules. And these modules comes from the class known or instantiate the neural module factory. So you have to initialize neural module factory before you can actually create any neural module. So using nemo.core.neural module factory, it will initialize the neural module factory. Now we can see like what are the data layers and tokenizer that is available here. That could be seen simple for command, or you can run the list to see what are the methods that is available here. So here, particularly in this application, this is I'm running for classification. So, and the data layer that I'm seeing here under Nemo NLP. So these are the model that is available, like BERT infer data layer, BERT joint infer slot data layer. So you can we can choose one of them. As I mentioned, we are working with classification, so I've chosen BERT text classification data layer. You can see how this data layer looks like using the command inspect.signature. This will basically give you what it is, what parameter it is expecting, that is the input file, tokenizer, max sequence length. So this will give the signature of this particular data layers. Now the second is tokenizer, which is again needed for the classification. Like we have seen initially, what are the data layers available using nemo nlp.nn.data layer. We can see what are the tokenizer that is available with the same format. Once you have these methods like chart tokenizer, or you want to use nemo bot tokenizer or nemo gpt tokenizer, you can choose among them. Like I mentioned initially, if something is not here, you can create your own module as well. So here I'm choosing nemo bot tokenizer. Again, I'm assigning giving this nemo bot as a name, and the pre-trained model that I've chosen is bird based uncast. There are various model available, pre-trained model available, that you can choose, or you can do your training from scratch. Now this simple example that show token from an input. So here is the sentence is how about this stupidness sentence. So what it will do is that it will give you the tokens from this input sentence, which you can see here. Now we can instantiate a nominal data layer neural net module, and that could be done using nn.data layer bot text classification data layer. So this is the place where actually you are initializing the data layer. Before that, we were just seeing how what are the options available as a tokenizer, what are the uh, methods available as a classification, what are the models available for classification. So it will expect the input file, the type of tokenizer, and the maximum sequence length. So once you give this, it will give the tokens of the files, and that would be the output. Now the next step is to define the language model and classifier. Similar to previously, you can see what are the language model that is available. Your language model is could be found in trainable modules. These are the language model that is available for you to use, and we can use like get pre-trained language model method to specify a language model. We can see a list of available model for us to use that is pre-trained. So from here we have chosen the bird base and cast as our language model. Now similar to earlier, you can inspect basically what it has as a parameter. So you can use the inspect dot signature to get the ideas of what are the number of layers it has, hidden size, what is the loss function, dropout, and all those parameters. Here, then you will finally initialize the classification neural modules and the which using the nm.trainable sequence classifier. Once you initialize the classification neural modules, the next task is to choose the loss function. Again, these cells that I'm writing here to showcase what are present as a model is not actually required. If you are this just to show like what are the options that is available for you to choose. So once I have this like when you are working on your model or when you're training, you might be familiar like what exactly you are going to choose. This is just to make you familiar that these are the option that is available. So here we have chosen the softmax function, and then the last step is to create a neural graph. So we have already chosen our data layer. We have taken our trainable modules. We have taken what tokenizer we wanted. We have taken what pre-trained model we wanted, and we have also selected the loss function. Then you can create the neural graph that here it is like it will take input data, token type, attention mask, labels. Once it has, then next step is to determine the embeddings or output from the language model based on the data inputs provided by the data layers. So that could be done using embedding and the language model that we have selected and the parameter. Like I mentioned that if you're not initially aware of what should go, you can use the signature function to get the idea, and then these parameters could be passed. Last step is to start the action. This start action means whether it generally refers to training or inference or transfer learning or data augmentation. These methods comes under start and action. So here what we will do is that we will train the model using once we have initiated everything. The start and action here was that will train it, and that will give the embeddings of the sentences that we have provided. So this is very small application using language model, but that gives a perspective of what are the components that is involved in a Nemo and what all you have to define or take care. Now I'll go to the next Jupyter that we talked from the beginning, that is the ASR pipeline. So here to build the ASR, I have taken AN4 dataset from Carnival University. If you have your own data set, then you can choose it. And if that data set is currently in some format which is used by some other framework, then also you can convert it for Nemo. And as I walk through, I'll talk about it. So in the first cell, basically, I'm just installing all the prerequisite, the Nemo, the wget commands, and all those things. The next step here is to get the data and pre-process it. So in this particular cell, what I'm doing is that I'm downloading this data set, and once I have the data set, the dot SPH file needs to be converted into .wav file before I can give it to the acoustic model. So this particular cell is downloading it, unzipping it, and then converting the file to WAV file. Once we have that, uh, I'm not I'm not sure whether it was audible to everyone, but it basically I just played one of the wave file. How does it sound? Now the next step is to do the pre-processing. Here what I'm doing is that I'm applying the Fourier transform to get the spectrogram. So this word that I have loaded is only GLENN, that is Glen. So if you see the waveform representation of this word, you find that these represent basically the energy. The shape is basically represent the energy, and if you notice the last two is somewhat similar or more similar than the other shapes, and this is because both the character represent n, and that's the reason it has certain similarity. Now to get a better understanding, we'll convert it to spectrogram. Once we have the spectrogram, we can get a very close relationship of the energy level of this spoken characters. Further, we convert it to MEL spectrogram. So, like I mentioned, that MEL spectrogram gives better understanding, and even you can visualize it, the difference between the normal spectrogram and the MEL spectrogram. This has more significance, visibility than the spectrogram. Now here I'm using the Jasper model. So similarly, like I've shown earlier with the example, first you will import Nemo, then here the collection would be Nemo ASR. Earlier it was Nemo NLP because we are using the NLP, natural language processing workload. So we have imported the Nemo NLP collections. Here we will import Nemo SR collections. Once you have that, you will load the model. Here I'm loading the Quartzinet model, and that is coming from Nemo SR models in encoder decoder CTC model. So we can load the pre-trained model here. Once we have that, then we can do the inference here. So basically this audio file get converted or transcript is generated. So we have seen it initially it was Glen, so the transcript has been generated as GLEN. So this is like you have a pre-trained model, you took it and then you did the inference. Now if you take it directly and do the inference for other language, does it perform well? And probably not. Like if it is trained on English and if you expect it to perform well on your Hindi dataset without doing any fine tuning or data augmentation or transfer learning, probably you will not get a good accuracy. So what you will do here is that we'll do further training for our data set. So for that, the first thing is we have to create the manifest. In the Nemo actually expect to manifest the training manifest and the validation manifest. The manifest looks like you will have the audio file path, then you have duration, and then the text. You have to create this manifest for both training and validation. So this particular cell is basically doing this task of creating the manifest. Once you have that, you can specify the YAML file. YAML file here is for the defining your configurable parameter. Let's say in this particular example, I'm giving k equal to 4 and r equal to 1. If we recall initially, I mentioned for this k and r, k represent the blocks sub-block that you have, and R represent repetition of that sub-block. So we do have 4 blocks and the repetition is only 1. So this is what could be defined in the config file. Apart from this sub block, the k the block and the repetition, there are few more layers would be, that is initially and at the end of this architecture, which actually to specify how you will handle the training and validation data. Using this YAML configuration, it is very helpful because it makes life easier to change certain parameter and do retraining again and do multiple experiments without writing a code or doing a change in the code itself. So that's way it makes the life easier. So this is the YAML file that we have in our configuration. Once we have this, we can start the training. Again, like I mentioned that Nemo uses PyTorch Lightning. PyTorch Lightning has certain features and that's what it is using. So you can train it using PyTorch Lightning like pl.trainer, or you can use the PyTorch library itself to train it, or you can use the Nemo library to train it. Any option would works here. Sorry. So once you do training, here I'm training it just for 50 epochs, so it doesn't take much time. Again, like the few things that I spoke about initially, your using of AMP for training, that is the optimization, and using multi GPU training, these are the configurable parameter that you can configure or set in your configuration file so that it can use those features. So once it got completed the training, you can evaluate the results. Also, you can monitor the progress of the training. You can monitor it on TensorBoard, or you can monitor on Collab. There's various ways that you can monitor the progress when you are changing the hyperparameters. Now, once you do the inference, you will be in better position to realize whether this is giving good result or you need to do something else. So here I've tested on 4 wave file. I realized that there is a scope, it could be improved. So what you can do, there are various methods that you can use. Since I've chosen very small data set, not even the complete AN4 data set, I've taken a sample of AN4 data set. So the size is small, and there could be chances at various place you would have the small data size. Then you can use data augmentation method to make your or increase the size of your training set, and this is what I'm doing here. Once I complete this, then I can do transfer learning. So what transfer learning will does that instead of training from scratch, it will take the pre-trained weight and do for the training. Now what is the thing that Nemo brings here is that Nemo automate this transfer learning component. So when I say automate this transfer learning component, what exactly in transfer learning you do, you actually take the train weight and you use the learn parameter to create a new model. During that process, sometime you prune some of the nodes, or you remove some of the layers, or you make the changes which is suited for your new data set or new use cases. And to do that, you do multiple experiment to come to a conclusion what should be removed or what should be kept. And it is time consuming process. Here this transfer learning capability of Nemo makes the whole life easier by making it completely automated. So this is what the this is the features that has been incorporated to make the training more efficient. Now, once you did transfer learning, you can again check, do the inference and validate whether it is working well or not. Like I mentioned initially, when you do this trainer using PyTorch Lightning, you can choose the this level of optimization. Will it be 0? When it will be 0, then it will not choose the optimization, so it will not use mixed precision training. When it will be 1, it will use the mixed precision training. When it will be 2, it will be quantization aware mixed precision training. So that would be most efficient. Similarly, you have the option, you can simply pass number of GPUs, number of nodes, and you don't have to write the codes, which you generally does using Horoword or maybe using multi-GPU library of a PyTorch or TensorFlow itself. So this is the simple ASR pipeline. If you have your own data set, then you can change the data set and you can try doing the transfer learning and see how does it work. Now I'll go back to my slides. Just give me a minute. So here we were. From there I went to the Jupyter to show like what exactly you have to write to perform or train your model or build this application. As I mentioned, transfer learning is something that is incorporated into Nemo. We do have something named as transfer learning toolkit, which is integrated with Nemo. What it does is that it basically automate the whole process of transfer learning, which is very much essential when you want to use some learned parameter by one of other models to create new models. And that would be very useful to fine tune your pipeline and make your model more efficient. Transfer learning could be done to adopt for new data set or for new task. Here we'll see further how exactly it helps when you use the transfer learning. This is this graph is basically iteration versus the word error rate, and the green one shows the fine tune or the training from transfer learning training, and the orange one shows you the training from scratch. You can see that the transfer learning training is actually working well, not in just in terms of uh, getting better optimization, getting better accuracy in less time, but also it is giving you better performance. So both in terms of time and accuracy, it works better than the data model that is trained from scratch. Again, you cannot generalize it. Sometime it may not work, but most of the time these are the trend that we have noticed. Here the model quartznet, we have chosen the quartznet model. In the first scenario, the quartznet is randomly initialized. In the second, we have taken a pre-trained quartznet which is trained on the English data set. What we did that for both the kind of models, which is first which is randomly initialized and second which is pre-trained, we have applied we did the training for Spanish data set, and we have noticed that this is the graph that we are getting for different data sets. So the first graph you can see, when we did this the experiment on a Spanish data set, and you can see that the curve nature of the curve shows that the transfer learning training actually perform better in terms of accuracy as well as convergence of the whole training. So it reaches out the convergence point much earlier than the model which is getting trained from scratch. The second graph is for Russian dataset. So we have done this experiment on multiple data sets to come to this conclusion. Now I have trained my conversational AI model. Now what? So here I'm completing the first segment of the talk, which was Nemo, and I would do the second segment, which is Jarvis. I would try to wrap it up faster. Uh, so Nemo basically allows you to do very efficient training, hyperparameters tuning, fine tuning, all those things. Now you need to take those model, export it, and deploy it in real time. Jarvis is actually a fully accelerated application framework for building multi-model conversational AI services that uses an end-to-end deep learning pipeline. Uh, it How does it help you? That it provides real-time performance. We have observed that using Jarvis, the deep learning based conversational AI application gives latency less than 300 millisecond, which is very real time performance. Second thing, multimodal. It can fuse speech and vision to offer accurate and natural interaction in virtual assistants, chatbots, and other conversational AI application. Third, it is automated. The deployment is completely automated. So you can use one command to deploy conversational AI services in the cloud or at the edge. Again, the similar pipeline that I have spoken earlier, this pipeline for the deployment we have benchmarked, and it is giving latency less than 300 millisecond using Jarvis. Jarvis service are so Jarvis services uses AI services are a set of gRPC endpoints that implement specific functional. The building blocks of conversational AI Jarvis include APIs. These APIs have ASR function, NLU function, TTS function, and CV function. The whole API services server are divided into three component. The first is Triton Inference Server, which is a backend server responsible for hosting the models, and there are two more servers. The second is Jarvis Speech Server, which is a middleman server that provides API for speech related Jarvis AI services like ASR, NLP, TTS, or NLU. The second is Jarvis Vision Server, which is a middleman server that provides API for vision related Jarvis AI services, computer vision based. Now, these on the client side, one can have the application in Python or Java or Golang or C++. User here make direct requests to the Jarvis speech and vision servers, which in turn call the Triton inference server in backend to do the deployment. Jarvis ASR API consists of support basically to support these features. You can do the offline as well as online deployment. So offline here called as recognize, and online I'm showing it as a streaming recognize. It has GPU accelerated feature extraction. Also, these models are optimized using NVIDIA TensorRT that make it lightweighted and give you 7 to 10x kind of speed up during the deployment. It has beam decoder based on n-gram language model, and voice activity detection algorithm is also implemented. Basic punctuation based on voice activity detector WAD algorithms are there. Also, you can deploy it over an orchestration like Kubernetes, and Helm chart is we can be used to easily deploy it over those orchestration. It also have the ability to return top and transcript from beam decoder. These are major features of Jarvis ASR. What happens, how does it works that once it receives the audio from the client, it calls the Jarvis speech API, give it to the Jarvis speech server, which uh, uh, which start NVIDIA Triton server in the backend. And on the NVIDIA Triton server, the ASR pipeline would be deployed, which consists of the component feature extraction, acoustic model, LM decoding, and LM rescoring. And once it got deployed, the output of Triton inference server will be passed to Jarvis speech API and Jarvis speech server. This Jarvis speech server will use Jarvis speech API to give that output to the client. Now the second component Jarvis has, Jarvis NLP. Jarvis NLP is a flexible sequence classification and sequence labeling toolkit. It takes text as input and perform a number of analysis algorithms such as named entity recognition, intent classification, punctuation, and translation, and many more. Jarvis NLP is built based on common text processing models that can be adapted for multiple common NLP tasks. Here, Jarvis NLP services expose two different APIs. It has high-level API that is called as Jarvis NLP and a low-level API that is called Jarvis Core NLP. The high-level API exposes task-specific functions for popular NLP tasks, including intent recognition as well as port filling and intent extraction. The low-level API, on the other hand, provides generic NLP services for custom model use case. The intent of this service is to allow user to design models for arbitrary use cases that conform simply with inputs and output types specified in the services. As an explicit example, the classified text function could be used for sentiment classification, domain recognition, language identification as well. Similar to Jarvis ASR, Jarvis NLP works. You will have textual input that will go to Jarvis speech API. This Jarvis speech API will start Jarvis speech server, which will start NVIDIA Triton server in the backend, and where you will deploy this NLP pipeline. Then the output is passed from NVIDIA Triton to Jarvis speech server, and using via API, the output is given to the client or over the network wherever it is supposed to be sent. The third component of Jarvis is Jarvis TTS. Here again, like ASR, this Jarvis TTS pipeline can have do this synthesization on online as well as offline. So it is called as synthesize when it is happening online. If it is happening, sorry, if it is happening offline, if it is happening online, it is called as synthesize online. NVIDIA developed WebGlow for faster, high quality vocoding compared to WebNet, similar to what we have seen, Jasper and QuartzNet, and we are using that as a vocoding for the TTS pipeline. Again, you can use WebNet as well, and then we have trained it using on voice. You can train it using your voice using Nemo. Similar to ASR and NLP, TTS have the similar stack where the text input will come. It will taken by the Jarvis API and give it to speech server. The speech server will pass it to NVIDIA Triton server where the whole deployment will happen, and then the output, that is the speech, will be given to the from NVIDIA Triton server to Jarvis server, and via API it is sent to the client, or it is sent over this protocol network protocol, or wherever it is supposed to be sent. This configuration could be chosen by the user. Now we have used certain optimization technique apart from optimizing model to give lighter weight. There are certain optimization that has been done to take care of batching and all those things. We'll take the same ASR example to understand how what optimization has been done. What we have used for batching strategy is that, let's suppose that you have three utterance 0, utterance 1, utterance 2. Now we need batches large enough to saturate the GPU. How will you ensure that we have large enough batches that will saturate the GPU also and give the lower latency? First scenario is that you can choose one complete utterance as one single batch. Point is that you will get good throughput, but here you will have high latency, which is not very much expected or needed. Second thing what you can do is that you can have you can divide the utterance into chunks, and you can assign one chunk as one batch. Using that, the latency will decrease, but it will result in low throughput. Now, the third scenario, what we can do is that we can create batching across utterances, and it will result in low latency as well as high throughput. And this is what we are using. So, we are processing batches faster than real time. For this, we are first creating the batches around the utterances and then passing it. So, we will add to the batch any available chunk. So these features are already available. The batching across utterance is certain optimization that is available in feature extraction, acoustic model, or HMM language model. Similarly, other optimization method has been done to optimize it further during deployment. One other example is GPU-friendly WFSD decoding. So in Kaldi, which was a popular speech framework or a toolkit that works on CPU, and it uses CPU WFSD decoder. What we have done is that we have redesigned it from scratch for GPU processor. So basically, what has been done is that we have removed some CPU optimization, that is token unicity, trading marginal extra work for smoother memory access and asynchronous work. So we have designed the task from the ground up so that they will yield coalesced clean memory access. And we have splitted the algorithm into different stages that will make it less compute expensive and smaller and more modular. The another thing is done is that on high level algorithms, this CPU decoder is this GPU decoder, basically we splitted the work in two steps. So as you can see here, the first step is to create the structure, and the second step is to generate metadata. So first is the expand and contract. In CPU, decoder is doing expand contract structure for each generated token. On GPU, we have divided this in two steps. In first steps, we'll find which subset of the search space will use to represent the current time step. And in the structure, once we have finalized this set, we'll perform the expensive operation of structuring the graph subset, that is in CSR format, and generate the metadata used for fast lattice generation. What would be the benefit is that we have observed that the magnitude difference between size of discovery set and finalized set. Using this optimization, we have received a very good speed up. So for the same GPU infrastructure, using this optimization, we have received an improvement or speed up from 11x to 41x, which is compared to previous GPU implementation. So that way it is much more efficient deployment than we used to do earlier. And like if you have certain infrastructure, you would like to utilize it to its best in an optimum way. And this actually show how you can use it in optimum way. This shows the benchmark that has been received on the same infrastructure before using Jarvis and after using Jarvis. So I'll summarize what we have learned in Jarvis, or what you can do, or what are the steps that is needed to be done. First, you have to configure the deployment. You have to select the model and the server preferences. Then you have to download the model, optimize and prepare the models. Second step, you have to start the server. So if you are running the speech models, then you have to start the speech server as well as Triton inference server. If you are running Vision server, then you have to start Vision server and the Triton inference server. If you are working on multi-model that has a fusion of speech and vision, then you have to start both the speech and vision server and Triton server. Third, you have to launch client that you can launch. The example is there in Jarvis underscore start underscore client.sh. You can use it to launch your container. Then you will test the example. There are couple of notebooks that could be used to understand how you can run the client side story. Then you will download Helm chart. Again, this Helm chart is needed only if you are going to do the deployment on an orchestration setup like Kubernetes. If you are not doing that, then these steps would not be needed. But in general, whenever a deployment happens in any industry or organization, it happens on a large scale where the QPS or the throughput is very high. So that requires this orchestration setup. So you have to download the Helm chart, then configure the deployment. Next step is to install the Kubernetes. Uh, and you can easily install the Jarvis API using on Kubernetes using Helm install Jarvis API. Once you have this, you can follow the same steps. You can launch the container and do the deployment. Currently, Jarvis is in early access and you can apply to get the access and do the experiment. So today's takeaway is that there are various scope of conversational AI in current area, and a lot of progress is happening on daily basis. When we build a conversational AI, it's not only that a simple chatbot, but it requires a lot of integration and it requires to be very, very precise and accurate. Using these toolkits, you can create easy reusable pipeline and make you available to train fast than you would are doing earlier. So I would like to end the session with this. If you have more question, you can reach out to me on my LinkedIn, or you can visit the NVIDIA Jarvis or Nemo forum to get more ideas on this. With this, I would like to thanks the WIDS team for having me here for today's talk. And I would like to hand over the session to Nidya.
Yeah. Thank you so much, ma'am. That was an amazing session. Sure, a lot of people had a lot of takeaways from that. Thank you.
Thank you.
So moving forward, we've got our next speaker, that is Mrs. Shailaja Grover. She is the director of Awesome Stats and also a consultant for IIM Bangalore. And today she's here with us and she's going to be talking about AI in fantasy sports. Hello, ma'am. Ma'am, your voice is not audible. Hello, ma'am.
Ma'am, you're still not audible. No, ma'am.
Not audible.
It seems Shalja ma'am is having some sort of technical issue, so stay with us. She'll be back in another, I think she'll just be back in a moment.
Hello.
Can you hear me now, Shashank?
Yes, ma'am. Now you're audible.
Okay, thank you.
Yeah.
Okay, can I start?
Yes, ma'am. You can start. You can share your screen, ma'am.
I can share my screen. Okay. Is my screen visible, Shashank?
Yes, ma'am, visible now.
Okay, perfect.
Yeah, you can start.
Okay, good afternoon, everybody, and sorry for this last minute technical glitch. I'm using my son's laptop and he has done something on it. Anyway, so good afternoon, everybody. My little background about myself. My name is Shailaja Grover, and I work for Indian Institute of Management, Bangalore, as a consultant in the data center analytics lab for last 8 years. And before that, for 16, 17 years, I worked in corporates in companies like GE, Highgate, TCS, and mainly the IT industry. But 8 years back, I did my business analytics course from IIM Bangalore. And since then, I've been working with the data center analytics lab. And the main work that we do in this lab is basically teaching, workshops, faculty development programs for academia, as well as workshops and training programs for corporates, as well as we do a lot of consulting work for corporates. So today, what I'm going to talk about, I think the topic that has been shared is little misleading. There is nothing to do with AI in my presentation. I had, it's so this the topic that I'm going to be covering today is basically a very simple implementation that how analytics can help, in any domain. So there is not much here. There is no AI here. So I would like to make that change. So the topic of my presentation, a case study, is fantasy sports, skill or a chance. Right. So this is one of the cases. As I told you that we do a lot of consulting work for corporates. So and in mainly the areas which are research based, right? So this is one of the works that we had done for one of the fantasy sports company, and I'm going to be presenting that case study, that how using just the simple techniques we were able to solve their problem. Right. So if people who have joined are interested in AI or a very technical presentation, I'm sorry, I'll be disappointing you. But this is more of a application of analytics in sports, right? So as the name says, right, fantasy sports. We all are aware of fantasy sports, IPL happening, right? So all of us, I'm sure most of us would be knowing what fantasy sports is. But still, the way I have structured this presentation is I'm going to be talking about a little bit about what fantasy sport is and what is the problem that we are trying to solve. What is the fuss about the fantasy sports, and how we try to solve this problem. Right. So moving on to the next slide, I have a small video that I have created. I hope, Shashank, just tell me if you guys can
Daily
hear the video.
fantasy is the hottest new way to make real money.
Yes, ma'am, it's audible.
I was hooked. I turned $35 into $2 million into $40 into $0 on FanDuel.
Daily fantasy is the best. I get to play every day.
You mean you get to gamble?
It's not gambling.
Oh, it's definitely gambling. You have a massive gambling problem.
It's actually a skills-based game that is going to make us rich one day.
You're an idiot.
I'm a winner.
With daily fantasy, anyone can win.
I've won $784,000 on FanDuel.
See? You can compete against millions of regular sports fans just like you.
I have a master's degree in statistics and have designed an advanced algorithm that incorporates real-time weather condition updates and can calculate an earned run average to the 20th decimal point.
Daily Fantasy Sports is the only skills-based entertainment product where you can win big money. Listen to the critics. Daily Fantasy is a legitimate business.
Daily Fantasy has the support of the NFL. When have they ever been associated with anything shady?
The best part about it is that it's currently legal. So I'm excited about that.
Daily Fantasy Sports is just pure fun, and it's so simple.
I just watch football and win money. I know that sounds too good to be true. In fact, even saying it out loud now, I'm realizing that can't possibly be true.
And if you're concerned that Daily Fantasy sounds like gambling, don't worry, it isn't.
It's not gambling. It's playing a game where my cash winnings depend on the performance of professional athletes. Wait, I described gambling again.
With Daily Fantasy, all you need is a love of sports.
Okay, so
Daily
this video actually summarizes the problem that we are dealing in this case study. Fantasy sports is kind of a, it's all very, it's not very clear, right? It's becoming very, very popular, but sometimes, as the person was saying, it becomes legal. Sometimes it becomes illegal. Whether it's legal, whether it's illegal, what is legal, what is illegal. So there's a lot of confusion towards this entire fantasy sports thing, right? In some countries, even in some states, they make it legal. Somewhere it makes it illegal. So there's a lot of confusion over all this. So that's what this case study that I'm going to be talking about is about. That what exactly it is, and how we can use data to prove whether it should be categorized as a legal game or illegal game. And how we are going to do is, first we'll understand what fantasy sports is and what kind of a data these guys collect, and based on that data, how we can use that. And then we also will try to understand what makes a game legal and illegal, what does the law says about it, and then how, by using the data and using the what the law definition of legality is, how we can use the data to prove whether it's a legal game or it's a illegal game, whether it should be categorized as a gambling, or it should be categorized as a skill based game. So that's what is the topic of my presentation today is, and that is what I'm going to be talking about. So let's first understand what is fantasy sports. I'm sure most of you understand, but I'm not a big cricket buff. So when I started doing this project last year, I didn't know what it is. So for people like me, I'll just take you through, what fantasy sports is. Basically, fantasy sports is, it's an online gaming, and you select a match, like an IPL is happening. So you select a particular match in which you want to create your team. For that match, the players of both the teams are available to you, and you create your own team. And at the end, based on the performance, how the players performed actual on the field, you win, right? You win cash, you win whatever, so points or whatever. So, and that is where there is a confusion which comes, whether it is betting, whether so that's where the gray area of legality comes into picture. So that's what fantasy sports is. And actually, fantasy sports is not a very new concept. Yeah, with the league-based sports becoming more popular nowadays, we are hearing about it a lot. But actually, fantasy sport is pretty old concept. It started in, if you see the timeline, the history of fantasy sports can be traced back to actually 1960, when Bill Gampson, who was a former professor of psychology at Harvard and Michigan University, he constructed a game called the baseball seminar. And after that, David Orent, his student at Michigan University, learned about baseball seminar and created his own version of the fantasy sports called rotisserie football. And since there's nothing very fancy about rotisserie football, it's just that because he developed this game sitting in a very fancy new Manhattan restaurant called Rotisserie Franchisee, and that's why he named that. So fantasy sport is not new. It's not that it is it's just come into picture. It's been there for decades now. But what has happened is that over a period of time, with sports becoming very popular, especially the league-based sports becoming very popular, the popularity of fantasy sports has increased exponentially. You can see the number of people playing fantasy sports in US and Canada, if you see my screen here, has been going up exponentially, right? And they're actually, the year on year growth rate for 2018 was estimated around 11%. So now, okay, good, it's there, it's been there for decades, it's happening, people are playing it, number of users are increasing. Why are we talking about it? What's the fuss about, right? So the fuss about it, that this kind of a game lies in somewhere in between, right? Skill and a chance. There are certain games like chess, football, basketball, baseball, which are pure skill-based game, right? There is always, you can't completely eliminate the option of chance, and that I'm going to talk about in my last slide. But primarily, these sports are skill-based sports. But there are some sports like, card-based games, blackjack, roulette wheel, all those slot machines. Those games, like especially the slot machines and the roulette wheels, those are completely chance-based games, right? There is no skill. So if you guys have gone to these, in Las Vegas or Atlantic City, there are these slot machines, and where these old grandmas will keep sitting and putting the coins and waiting for a jackpot to happen. There is no skill there. You're just sitting and waiting for a chance to happen that you are going to win. So we have to define whether it's a skill-based game or a chance-based game. Why are we talking about a skill-based or a chance-based? Why do we have to define that? Let's talk about that. So basically, what is happening across the world is the whole world is actually divided with large number of lawsuits against these fantasy sports, right? People are left, right, and front putting lawsuits against them that it is gambling. It's not actually it should not be legal, right? And because of that, the recent surge in fantasy sports popularity and the old laws of gambling do not work well with the online gaming industry. So what is happening is there are gambling laws very, very clearly stated for the games which are not online, right? But for online gaming industry, still these kind of old laws are not very, very clear, and that creates always a confusion. And hence, because of this confusion, somebody somewhere will always keep posing a lawsuits on these fantasy sports company that it is not a legal game. It's a and they it's a gambling happening, and they try to close it down. So that's what is happening in the world. And also the lack of standardized and uniform law is creating a lot of confusion and inconsistency. So, and also what is happening is when we started this project and we were trying to do a research on what is happening, why, how are these lawsuits being fought? What are the arguments which are being given, whether it's a fantasy sports is legal or not, are basically mainly on the features and the rules, right? How much control you have over the game variables, what is the owner motivation, what is the team adjustment, and these arguments are mostly not data driven, right? And we being a data COE, we wanted to test whether whether whatever is happening in fantasy sports can, by using data, we can try to find out something, whether it's legal or not. So in order to find whether it is legal or not, so this is supposed to be a very interactive session, but I'm not able to do that, so I think I'm going to move ahead. So before to use data to prove whether it is legal or not and how we can use that, we first need to understand what does the law says, right? So as per the law, Pre-Independence Law, Public Gambling Act, it criminalizes gambling in public forum in India, and game of mere skill differentiated bit from the game of chance. So in other words, if I say how the law is discriminating between legal and illegal is based on the dominant factor. So what the law says is that if a game is purely skill based, it is a legal game. It's not gambling. But if it is purely chance based, it is random, there is no skill required, then it is then it's a gambling game. It's not and gambling is not legal. So basically, in any game, we have to find out that what is the dominant factor, whether the dominant factor is skill or the dominant factor is chance. If we are able to differentiate using data, whether the game which is being played in these fantasy sports, it is skill dominant or it is chance dominant, we will be able to differentiate whether, as per the law, it should be considered legal or it should not be considered legal. So this was the basic premise that we had taken for our analysis to start with. We need to prove, or we need to test whether the data says that it's a skill-based game or it's a chance-based game. So we need to understand, we had to study what defines a skill-based, right? And what is a chance-based. So hence, to summarize whatever I have spoken till now is that yes, fantasy sports is becoming very popular. It's a very old concept. It has become more popular because of the league-based sports, because of very uneven, non-uniform, inconsistent laws. There are lawsuits which keeps coming on these fantasy sports company every now and then, and most of these lawsuits are fought just based on arguments, not based on data. And as the law says, if we try to understand the law, the dominant factor test is what been put to test, whether it's a pure chance based or a skill based. If skill is dominant, it's not gambling, it's legal. If chance is dominant, it's gambling, it's illegal. And that's how it is getting demarcated. So now we have to find out how, using the data, we can actually, so skill dominance or chance dominance games classify legality. So if, just for example, if we look into these three games which have been very popular, like obviously these are not fantasy sports, these are real games. So horse racing, rummy and bingo. In all these three games, horse racing and rummy are not illegal, right? Horse racing actually works on the objective assessment of the fitness of the horse, the skill of the horse, how many wins the horse had before, what is the fitness of the horse. Based on all that, the person who is actually putting money on that horse has to apply his skill in choosing a horse. So it's skill dominant and hence legal. Same way, rummy also, you have to memorize the fall of the card. So skill is needed to decide whether you have to hold the card or you have to discard the card. Vis-a-vis a game like a bingo, which is pure chance based, right? There is absolutely no skill required. It is completely based on what number will come next and whether you're going to win based on that number or you're not going to win. And this is how, hence, these are how the games are demarcated between legal and illegal. So what did we do? So we know that these are the major fantasy sports company, Mobile Premier League, 11 Wicket, Star Pick, all these are fantasy sports company, but we went to the leader of the fantasy sports company, and I'm sure you all must have heard about Dream 11, right? They are currently the leaders. They have become a unicorns, and they are currently the leaders in India in terms of fantasy sports. So we went to them, and we wanted to analyze their data to find out if we can somehow demarcate between skill and chance. So basically, just a little bit about Dream 11. Dream 11 was founded in 2008, and and we all know that how their user base has been exponentially increasing over a period of time. They started with cricket, but now they have football, kabaddi, all that they have added into their this thing, and they have 90% of the share in the fantasy sports market in India. So you can see that how big this company is. Just I'm sure most of you who are actually right now watching this would have played sometime this game in Dream 11, but people who have not played, I'm just going to play a small video just showing that how this game is played in Dream 11.
On Dream 11, you are the selector. Select the match you want to play and create your dream team. Pick 11 players from both teams using 100 credits. Create a balanced team with a variety of players. Remember, you can choose a maximum of 7 players from either of the teams. Finally, choose a captain and a vice captain. Captains earn twice the points they score and vice captains 1.5 times the total points scored by them. While selecting your team, tap on Team Preview to check your combination. After creating your team, choose from the list of cash contests and join the contest you like. Once the match starts, you can see your ranking and player performance in the contest leaderboard. That's all. Start playing and win big on Dream 11, India's biggest sports game.
So that's what is Dream 11. It's very easy. Basically, whatever two teams are playing, you get a chance. You get some credits, like say 100 points, and every player, based on the past performance of the player, has some points given to that player. So you make a team. You can actually choose your players from both the teams. So you make your own team using the available players from both the teams. And also based on the number of credits which are available, you have only 100 credit points, and then every player has some credit points. Obviously, a good player like a Dhoni or a Virat Kohli would have higher credit points. So taking that person in your team, you'll have to shell out more of your credit points, and that's why it creates a balance in the team, right? So you make your team of 11 players, then there are constraints like you can have only one captain, one vice captain, one wicket keeper, and then you create a combination of batsmen and bowlers, and finally you come up with a team. Just before the match starts, this team is frozen. It's not that you can change this team as the match is going on. So once this team is frozen, as the match starts, based on the actual performance of the players, the scores gets generated. If the team that you have chosen, based on each player's performance, the aggregate score will be allocated to you. So obviously, as they said, that captain will get twice the points he scores, and the vice captain will get 1.5 times the points he scores. So this is how the data is getting collected. So for a user level, we have this for all the games which events or the matches which have happened. For all the users who have played in those matches, and the teams that they have created, and the scores of the team is available to us. So that was the data which was given to us. And obviously also, once you create a team, you also have an option of what kind of a contest you want to play, whether you want to play a free contest or win for all. So this is the kind of data which was given to us. So we had around 2.5 years of anonymized data of cricket. And the way the hierarchy goes, we had the round, which we call the matches. Under every match, every round, there are multiple contests which are getting played. And for a particular contest, the user will create a team. So under the contest, you will have multiple users who are playing. And for every user, you will have the team. So one user can actually create multiple teams. So based on the amount of money that you want to put in. So an innings would be around. So we had around 4.5k rounds data. We had around 8.2 million contest data. We had around 2.1 million users ka data and 3.2k players data. So all this data was given to us. Now you have this huge data of multiple rounds, multiple contests, multiple users, multiple teams available to you, right? And also, as I told you, that there are certain rules and constraints based on which the game is played. Every player comes at a price. So a budget of 100k credit is available, and these constraints were there when we actually did this project, when we did this case study. Now I'm sure they would have changed it. It would have, because those constraints and rules keeps changing, so that people don't understand the game and so there's more fun in playing. But at that time, these were the rules and constraints which were given to us. And also a user can create multiple teams, and he can choose to join any contest which they wanted. So then you can have 11 players based on the combinations which are given there. So now, if we have this kind of a data, right? What our next step was, how should we determine that it is a skill dominance, right? Whether skill is dominant, whether chance is dominant, how using this data we can, determine that. If it would have been a interactive game, I would have asked you guys to tell me, because it's a very interesting case study to go through. Because there are certain things that we thought is a way to determine skill versus chance, but when we interact, when people tell, if you guys have some inputs, or you guys feel that you understand how we can test for skill versus chance, please, I would request you to type it in your comment section, and so that I also can get more insight that what other people think, that how we can test the skill versus chance. But what I'm going to talk about is that how we did it, right? So there were few hypotheses that we had, right? How can we determine a game is played, or in fantasy sport, whether it's a skill-based game or is a chance-based game? The one very key differentiating factor between skill and chance is random versus strategy. If it's a pure chance-based game, the scores, the teams chosen will be completely random. That means every player in a team has equal probability or equal chance of getting selected. That's how we call it a chance based game, because if you go to a slot machine, in all the three slots, it's completely, every possibility has an equal chance of coming there, right? Same way, if fantasy sports, or choosing a team in a fantasy sports, is pure chance based and there is no skill required there, then every player would have equal chance of getting selected. So somehow, if we can prove that from the data, that the teams which are chosen by the Dream 11 users, people who are playing in these fantasy sports, are actually skilled. They are applying some strategy to choose the captain, to choose the vice captain, to choose their bowlers, to choose their batsmen, and also to choose and also to divide their whatever the 100 credit points that they have given very wisely for creating their team and finally getting a score, rather than completely randomly deciding. We should be able to prove that it's a skill based game. So that's something that we are going to see how we did that. Then we also have a skill based game will always have a skillful team selection, right? Players who are skilled, the past performance of the players should play a key role in the selection of the teams. So how can we prove that the users who are actually selecting players in the teams while playing the games are actually selecting the team skillfully? Skillfully in the sense they are selecting the players who are more skilled and they're leaving out the players which are not skilled. Another important aspect of skill versus chance is that if it is random, completely random, or it's more of a chance driven dominated game, there will not be any learning effect. There will be randomness everywhere, right? You will not see that the users who are playing more are coming in top more. So if learning effect means if I'm playing more, I'm learning the tricks and trades of the game and applying those tricks and trade into my selection of my team, and I'm coming consistently, my scores are consistently coming high. So that learning effect will be seen only if it's a skill based game. In a chance based game, that learning effect will be random, right? It will not if, people are just selecting the random teams, and so you will not see any kind of a users who are who are choosing the right teams coming into the top. And finally, consistency. If we see consistently some good use consistently the users are some users are coming in the top quartile of the scores, that means yes, the consistency versus randomness shows that it's a skill based game. So these were a couple of hypotheses that we thought that we can test from the data to see whether it's a skill dominant game. So now the second challenge is, now you saw what kind of a data was available to us. The kind of data was, we had all the rounds. For every round we have contests. For every contest we have number of users who are playing and the teams that they have selected. Now how can we test this hypothesis? Because to test the hypothesis, we all understand we have to create our data in the way that we can run some of the hypothesis tests, whether it's a parametric test or a non-parametric test, but we have to go and create the data in that. So we'll talk about that, how the data that was available to us was actually created in a way, or actually sliced and diced in a way that we could test these kind of effects. Another thing was a very simple case, something like a contest, right? There are different types of contests which are being played in fantasy sports. There can be free contests, there can be paid contest. A very simple test, like, if you guys understand hypothesis testing, something like a two sample t-test, right? Where we have two samples, one sample where of the scores of the users who are playing free contest, another sample of the scores of the users who are playing paid contest. And if we see that there is a statistical significant difference between these two scores, that shows that users who are actually doing a paid contest are applying more skill, and hence they are getting higher scores versus somebody who is playing a free contest, because there is nothing in line, there is nothing that he's going to lose, so probably he's choosing teams more randomly and not getting that high score. So that was another simplistic test we could do. So when we talk about random versus strategy, we created two data sets. One data set was the data set which was given by the Dream 11 itself, where we have the users, the teams that they have done, and the scores that they have got. Parallel to that, we created another data set for exactly the same teams which were available to the users, that if those users using those teams would have randomly selected the players under the constraint. So we create another data set with the random selection of the players. So my teams remains the same, my constraints remains the same. Only thing that differs is that and based on those constraints, I randomly pick up the players. I randomly pick up a captain, a vice captain, and I create my 11-member team. And because I know the actual scores of those players in the games which I have selected, I can actually give a score for the random team. So now again, I have two scores. One score of the team which was the users who have played in the in Dream 11, and another of the same users if they would have selected the scores randomly. Now, with these two data sets, if I just run some simple hypothesis test, and if I find that there is a difference in the scores between these two data sets, that means it shows that the Dream 11 users are not playing it randomly. If they are getting higher scores, that means they are playing a more strategic game than a random game. So that was one of the ways we tested the random versus strategy. Skillful team selection was tested. Basically, you can actually every player, if it is again a chance based game, every player has an equal chance of getting selected as a captain or a vice captain. So again, you do a non-parametric kind of a test here where you see that users who selected a specific good captain or a vice captain, how many times that user came in the top quartile of the scores, and vis-a-vis another user who did not select it and how many times he came. So you kind of create a contingency table with the 4 selections where the users who selected that particular captain, how many times he came in the top quartile, how many times he did come in the top quartile, and other is where the user did not select, and those users how many times they came in the top quartile. So like that you have a 2 by 2 kind of a contingency table, and you do a simple chi-square test of independence, and we found that so basically chi-square test of independent tests whether the player selection has to do anything to do with the user scores coming in the top quartile, and we were able to establish that the selection of the players has something to do with the was dependent of the players coming in the top quartile, their scores were dependent upon the selection of the players. So this again proved that it is a skillful team selection. The third hypothesis that I was talking about was a learning effect. What does learning effect means? Learning effect means that as I'm playing more, I'm actually my scores are appearing in the top quartile, right? So we did a simple linear regression here where we created a association between number of times the user's score appeared in the top percentile and number of rounds the user has played, and we could see that there is a clear-cut positive association which says that as the number of, so here my y was number of times the scores appeared in the top percentile, and my x was, my independent variable was the rounds the user has played. So as the number of rounds the user plays increases, his number of times he comes in the top quartile increases. So that means there is a learning effect. That means as I'm playing more, I'm coming more in my scores are in the top quartile. If it would have been a random game, I would not have been able to establish this kind of a correlation. So this again proved that there is some kind of a learning effect which is happening. Then finally, consistency. So consistency means that every user has an equal chance of coming in the top players. And we see that the few users who are playing are consistently coming in the top quartiles, right? So again, we can do a simple kind of a chi-square test of independent, whether the number of times the user has played and the number of times he has come in the top scorer list, is there a dependence or not? And we found that there is a dependence, that as the users is increasing, the number of times he increases, playing is increasing, he is actually coming into the top quartile. So these were some very basic hypothesis that we could test from the data which was available, and which proved that yes, probably the fantasy sports user are mostly playing a skill-based game and not a chance-based game. So finally, the hypothesis says that there is a skill-based team selection which was happening, which means that users are selecting teams based on their past performance, because we were able to establish a difference between the scores of the high performance players vis-a-vis the users who have not selected them, right? There was a learning effect. That means as the users are playing more, their scores are coming in the top quartile. We were able to see the consistency that same users who are playing are coming consistently in the top quartile. If it would have been a random game, that consistency would not have been visible using the data, right? They would have been randomly shifting between the top quartiles and lower quartiles. Past performance of the players is taken into consideration. Applying strategies within the defined constraints to get the maximum score is happening. And then also the choosing the appropriate contest to win. To which contest should I play in is also my skill, right? Because there are different types of contests, having winner takes all, whether I take 50% of the money, all that. So which contest I'm actually playing is also defining whether I'm going to win or lose. So with all that saying, right, we were able to establish that yes, fantasy sports using the data, we can say, not just based on some arguments, using the data, we are able to prove that it's more of a skill-based game and not a chance-based game. So this is where the story ended. But when we were looking into the data more in detail for certain specific games and all, we found certain basic anomaly. If you guys look into this distribution of points which was scored by the user, you can see that there is one spike. Otherwise, it is normally distributed, but there is one spike, which are the points scored by the users. Large number of users are scoring very high point, right? So what is this anomaly? And we wanted to analyze why is it happening, right? Why for one particular game there is this huge number of users who actually got the higher points. So we looked into the data, and we found this data was for IPL 2016 finals, which was between Sunrisers Hyderabad and RCB. Right, so this was the game which was happened, and in which Sunrisers Hyderabad won by 8 runs. So when we looked into the teams which the users has created for this kind of for this game, because both RCB and Sunrisers Hyderabad players were available to them to create a team, and based on whatever hypothesis till now I've spoken about, obviously users will go and choose the top players, right? David Warner from Sunrisers and RCB के लिए Virat Kohli. Obviously, look into their past performance. Good players, they are chosen as the captains, right? Many people did that. It's a skill-based game. I'm using the past performance of the players, and I have chosen these guys as my captains, right? And then these were the teams which were played. But there was a slight twist in this game. In this game, actually, Chris Gale was the top scorer, right? So users actually, so that is where the difference came. So users who actually chose, he was not playing well in the previous games, so he was not selected that much. But the users who selected Chris Gale as the top scorer actually showed that spike of the huge number, the high scores. And that is where the difference comes, and we call this the skill paradox. Basically, skill paradox is the key of this idea is basically as people become better in an activity, the difference between the best and the average and the best and the worst become much narrower, right? So the luck becomes more important. So no matter how much we try to use the skill in a game, no matter how much we try to differentiate between a good player and a bad player, but if two players are both equally skilled, right, then it comes to a chance that in that game which player actually plays well, and that's called the skill paradox. So if you see, this is the equation that we have for skill paradox. In this, all these guys who are actually playing at the Olympic level are all highly skilled. I can't choose whether I should choose number 7 or number 6 or number 8, because all of them are very highly skilled. And that is where the final luck comes into picture, because then the difference in their scores is based on the microseconds based on which they come first and second. So, but even so we can't negate the final aspect of luck when it comes to all good players, but still using the data overall at a high, at an overall level, we could find that there is a skill dominance which is happening in Dream 11 users who are playing, and with the data we could prove that. So that's all I had to talk about this. I hope you understood, you appreciate what, how using the simple analytics technique and using a complicated data set, we were able to establish a very controversial or a very, very sensitive topic. And this is actually published as a case in Harvard also. And that's about it. Thank you, guys. If you have any questions, comments, please write it in the notes section and I'll take a note of it. Thanks a lot for hearing. Thank you.
Thank you so
Yeah,
much, ma'am. That was a wonderful session.
Thank you, Shashank.
Thank you. Thank you so much, ma'am. Okay, so next up, we've got our next speaker, that is Dr. Pooja Rajdev. She is the director of Optum Advisory, and today she's going to be talking about analytics in healthcare.
Welcome to my brief talk on the Here is something about me. I'm Sunita John, and I love Bengaluru. I'm a mother to 2 young engineers who serve the IT industry. I work at MathWorks, the makers of MATLAB and Simulink. It may not be a marketing pitch if I say that most of you would have heard of MATLAB. Today, MATLAB is also used to design AI models and AI-driven systems. I practice
Hello everyone and welcome to the session today. I'll be talking about analytics in the healthcare space. We will start with the landscape of the healthcare domain, how analytics plays a role in this area, especially deep learning, artificial intelligence, machine learning, and also some of the challenges in applying all of these analytical techniques in the healthcare space, right? And a quick example here, for those of you that follow Hollywood, you would have heard that just about 5-7 years back, Angelina Jolie got a mastectomy done. And the evidence that she had, according to me, to do it can simply be attributed to machine learning in the healthcare space. So we'll try and cover some of those items as well. But before we get there, a little bit about myself. I am currently a director at Optum Global Solutions, which is a part of United Health Group and the largest healthcare company in the world, also Fortune 6. So very proud to be a part of it. I have been in the healthcare space for almost 15 years, started with a lot of research and disease prediction, especially in epilepsy and sleep, and further moved on to the consulting space where we've also used analytics for automation, operations, and just completely different facet towards it. However, all views expressed in this talk are my own and do not represent my company. All right, to get started. So, healthcare is ultimately about taking care of sick and injured people. In this world filled with pandemics now, diseases, accidents, dangers, risks, the patients and doctors have enough to worry about, right? They're mainly looking at solving for treatments. They shouldn't have to really worry about inefficient systems, processes, or even bad data for that matter. But the reality is that hospitals and healthcare facilities struggle to take advantage of the extremely useful data that's just scattered around across multiple applications across the EMRs. And in addition to that, the hospitals and healthcare systems struggle to thrive in this world where they're being asked to do more with increasingly complex population and fewer resources at the same time, right? And as we speak to some of our clients, we've realized that improving outcomes and quality of life is definitely the biggest aim of a healthcare environment. However, they're also looking to increase access and affordability, reduce costs and expenses, and also manage a lot of the risk that they have to take. So, with all of that in mind, we actually had a triple aim in healthcare. That's quadruple on the slide, but I do want to talk about triple aim first that we've had. So, the triple aim in for the first part, like the most important part that it had to take care was making sure that the population's needs are met. So being able to manage population health, being able to support the population health objectives, testing the population, identifying focused interventions and things of that sort. In addition to that, the second aim in the triple aim used to be improving patient experience. So you want to make sure that there are safety measures to improve the experience, avoid harm, decrease a lot of disparities, decrease the variations across the healthcare system. Then, while doing all that, you also want to manage the cost. So these were the three main aims that we used to have in the triple aim. However, the physicians, other members of the healthcare workforce started reporting widespread burnout and dissatisfaction as all of this triple aim had to be met. So that changed the triple aim to the quadruple aim, and we now also have added in the goal of improving work life of a healthcare provider, especially clinicians and staff members there. But how do we meet all of these needs, these four big aims that we have to do in healthcare? And over here, I do say that the biggest benefit of artificial intelligence in healthcare is the concept of human augmentation, or as we call it, human intelligence plus the machine intelligence, or human in the loop. So for most of these clinical related items, you always still have a human in the loop. For a lot of the operations related items, costs and revenue related items, machine learning and artificial intelligence have taken over as well. So the introduction of AI to the healthcare industry is akin to none other to other sort of notable medical breakthroughs such as X-rays, as it really allows the healthcare practitioners to evaluate patients with greater precision and detail. This also translates into faster, more accurate diagnosis, reduction of human errors, personalized care and treatment, and the concept of remote medicine can even reduce the healthcare costs and improve patient access and experience. So, one of the biggest shifts that we've seen is that there's a lot more data being available, and it's humanly impossible to keep up with the science from that perspective. And that's another area where a lot of artificial intelligence has started coming into the picture. Okay. In order to implement analytics in any healthcare system, I would say there are three main parts to it. The first one being the foundations, the data foundations. There are multiple different data sources. It's coming from various applications. So you have the clinical data, you have the claims data. You also start looking at social, environmental, behavioral data, pharmacy data, multiple other sort of data sources, and a strong pipeline or a data pipeline is very, very necessary to lay the foundations for future analytics. The next step that most organizations tend to take is around business intelligence. You want to be doing reporting, so looking at some of the advanced reporting, eliminating inefficiencies. In this case, we do see providers and payers, so hospitals and insurance companies looking at different metrics, but they're also looking at clinical as well as administrative or operational metrics. You want to look at how the utilization is being managed, how there's a variation in care. So you're looking at all of those items as well. And finally, you come to the predictive or the prescriptive analytics where you've got all of the foundations laid out and you can move to bigger and better things. Talking about the first step, right? Data aggregation or curated data. Let me start with a quick example and just compare it to the financial industry. So I have a bank account at this point in time, and it's with SBI here in India. I have to travel abroad for work. So I reach New York, go to the ATM and withdraw some dollars. Did we notice how advanced this whole nuanced process was? I could withdraw money from a different country, a different bank's ATM. My bank got notified and it also pays off the bank for it. So in healthcare, if I compare a similar situation, I go to Fortis on Cunningham Road to see a gynecologist today, and tomorrow I go there to see a gastroenterologist doctor. Same hospital, next day. I don't even think they would know about me being their patient or what I came in for the previous day. They will have no records of me. Maybe some if I in the EMR if I was an inpatient, but that's hardly utilized. And forget moving to a different fortis or to a different hospital completely, right? So that's the level at which we are in from a foundations perspective, where there's a lot of scope, especially from a pipeline perspective, to bring all the data together within a hospital, within a network, within multiple hospitals even. So the first step is in creating an accurate picture of your patient that actually links your clinical claims, social, environmental, behavioral data at a personal level, and then also at a population level. And that's when you start deriving insights and taking out actions out of that. The second step, like I was speaking about, a lot of operational metrics around cost and revenue. So you want to look at how many members you have, how many patients you have, what is the utilization management going on, how are your ERs utilized, are there variations in cost, are there variations in treatments that your doctors are giving to your patients, how do you benchmark yourself against the market. You're also looking at clinical metrics over here. So you're looking at claimants, costs, inpatient, outpatient data, top diseases, top drugs that are being sold, disease mix, and even quality metrics. So a lot of insight comes from this level of analytics. And finally, and the most important one that we look at is your AI for outcomes. So where you start looking at how can you apply artificial intelligence, how can you even apply machine learning or deep learning to make sure that the patient outcomes are appropriate. So you can reduce admissions, you can close gaps in care, you want to prevent adverse events, and even enhance disease management. I think there are a few very nice examples over here, especially, and the first one I definitely want to talk about is IBM Watson. I've worked a lot on it as well. A lot went into sort of getting this to run because you want to use all your doctor notes and you want to convert them. So you use natural language processing to convert all of the doctor notes such that it can be ingested. So you convert your unstructured data to structured data, ingest it into the systems, and further allow the system to make some predictions. At this point in time, Manipal and Apollo are using Watson for 13 different cancer types. And it's very interesting because it does give you personalized evidence based care. It's very difficult at this point in time for the oncologists to actually keep up with the rapidly changing scientific evidence, drug approvals, and treatment guidances. And at Manipal, the Multidisciplinary Cancer Board also used Watson to review some of its challenging cases, and they did realize that there was 92% concordance with the tumor board. So this is a very strong example of where AI is being used currently, especially for cancer. The second case here is of CDSS, or Clinical Decision Support Services, that actually provide the physicians with decision-making capabilities. And this is the case in Angelina Jolie's case that I was talking about as I started the talk. So she had a family history of breast cancer. Her mother had breast cancer and also died of ovarian cancer at a very young age. Jolie also revealed that she had a gene mutation in the hereditary breast cancer gene, so the BRCA1, placing in a very high risk group for developing breast cancer in the future. And it's only by collecting all of this data, understanding it, that we've actually understood how it can help you with making future decisions and maybe even identifying diseases before they actually occur. So this is another very strong case, especially CDSS systems, where they're augmenting the physician's decision-making capabilities. Another very strong place to use artificial intelligence for outcomes. And finally, we're in this era where continuous monitoring has just become the new way to go. We're all wearing Fitbits, monitoring our heart rates regularly, monitoring what we eat. So based on that, identifying your rising risk patients is very important at this point in time. Also trying to understand who will best respond to intervention so that you can help them take care of themselves before the diseases actually start showing symptoms. So these were some of the examples for our AI, especially in the healthcare space as they're coming along. And with this, I will end the talk. Thank you so much for being here. My contact information is on the slide here. Please feel free to give me a shout on LinkedIn, and catch up soon. Bye-bye.
Thank you so much, ma'am. That was really insightful. And moving forward, we've got our next speaker, that is Ms. Sunita John. She's a marketing manager at MathWorks India Private Limited, and she's going to be talking about the diversity divide.
But first, here is something about me. I'm Sunita John, and I love Bengaluru. I'm a mother to two young engineers who serve the IT industry. I work at MathWorks, the makers of MATLAB and Simulink. It may not be a marketing pitch if I say that most of you would have heard of MATLAB. Today, MATLAB is also used to design AI models and AI-driven systems. I practice yoga, and my favorite Shakespeare play is Merchant of Venice. And yes, I believe that the mind can be one's greatest ally or greatest enemy. So let's start off with diversity. Diversity means comprising different elements. Our world today is all the more diverse now than ever before. New thoughts, new mindsets, new ideas have spurred on a generation that is vibrant with diversity. Our differences allow us to make unique contributions to an organization and to the world. However, one aspect remains though, that the gender inequities have remained relatively the same. And that section is the largest among the diverse aspect. We have large volumes of resources lying untapped in this section of our society. Look at the research findings of McKinsey. It clearly shows how much of untapped potential lies with women, who are such a large population of our diverse society. Untapped women workforce reservoirs could rob our nation of its GDP by a large chunks. Why am I discussing this now? Because in the light of the current pandemic, it has become all the more important for women to step in stronger as the economic scenario is more challenging. So it is important for them to rise up to the challenge and to build strong careers which will support them, their families, the societies, and the nation in the long run. Here is an interesting phenomenon, the double shift. McKinsey finds that in countries like India, women do almost 10 times as much unpaid care work as men in their homes. This phenomenon is by no means confined to developing economies. Women work in double shifts in advanced economies too. In the United States, for instance, women still do almost twice as much unpaid care work as men, says McKinsey. 54% of women, but only 22% of men, report doing all or most of the home housework. 43% of women are primarily household income earners. However, they continue to do all or most of the housework as compared with only 12% of men. In addition, working women are more likely than their male colleagues to have a working spouse. 81% of women are part of a dual career couple and have two careers to balance, while only 56% of men are part of a dual career couple. During the pandemic, even more unpaid care work, such as childcare and homeschooling, fell to women as nurseries and schools closed, taking an ever bigger toll on their time. Women face a bigger challenge in the tech industry. Lower-end work tends to get automated, while the higher sections of work need more skill. Hours are grueling and long. Competition is tough. Technology constantly evolves and changes, requiring them to upskill constantly. Now here comes the catch. Being caregivers, women have lesser time to spare for reskilling and training. They may also face financial constraints in doing so. Another aspect that inhibits growth for women is that they may not have professional networks and sponsors that could make it easier for them to navigate job transitions. Women tend to have lesser access to digital technology. It takes time to build networks, and time is a precious commodity for a woman. If women overcome these barriers, they could find productive, better paid work. If they don't, they would find a growing wage gap and a tough market to share with their male counterparts. I will quickly share two key aspects that can help keep focus on a strong career. The first is career commitment. I'd simply define career commitment as a feeling of responsibility that a person has towards their own career goals and its mission. Commitment to building your career, strengthening it despite the odds, building your skills, building your network. Women often struggle to commit because the demands of balancing home and their partner's work can be overwhelming and sometimes can create conflicting priorities. The most tumultuous phase of a woman's career is the middle stage, when the juggling act is at a max: marriage, children, parents. However, women who persevere through the challenges in the middle of their careers find satisfaction in the end. Just remember, there is a price to pay for every reward, so stay committed. The second is career adaptability or career resilience. This is defined as the ability to successfully adapt to changes in the work environment. Today's emerging careers are characterized by a high degree of mobility and unpredictability. Take the example of this pandemic. In a matter of few days, nearly the entire IT workforce transitioned to work from home. What is your willingness and ability to adapt to changing work environments? Do you have a focus on the future? Are you ready to develop the new skills that are required? Self-development aligned with the future requires high degrees of self-discipline and effort. Imagine yourself in different possible roles at work. Do you have the confidence and self-belief in managing it? Career adaptability can be learned and practiced and can ensure overall career success in the long run. In conclusion, I would like to take the example of a woman whom I really admire in terms of pursuing a tough career against all odds. Mangte Chungnichang, Mary Kom, an Indian amateur boxer and Member of Parliament Rajya Sabha. She is the only female to become the world amateur boxing champion for a record 6 times, the only female boxer to have won a medal in each of the first 7 world championships, and the only boxer, male or female, to win 8 world championship medals. She was awarded the Padma Vibhushan, India's second highest civilian award, recently this year. Born in a village in Manipur, she took India and the world by storm. All this after being a mother of 2. And so I urge you, stay strong, stay resilient, and help all of us to close the diversity divide. A special request to our male fellow allies: be the support that we need. Thank you, and I wish you all the very best.
Thank you so much, ma'am. That was really amazing. And next on, we've got our next speaker, that is Ms. Priyanka Sawant. She's a data scientist at InvestNet in Yodlee, India. And today she's going to be talking about knowledge graph embeddings.
welcome to today's session on knowledge graphs for recommender systems. So before we start with today's session, let me just introduce myself. I'm Priyanka Sawan. I'm currently working as Associate Principal Data Scientist at InvestNet Audley. So prior to working at Audley, I did my master's from IIT Bombay, and I'm majority working in the data science area of deep learning, natural language processing, and recently I've got interested in the knowledge graph. So here is my LinkedIn link, so you can reach me for any further communications. So let us get started with the today's discussion. So here is an agenda for today. So we'll discuss what are the recommendation systems, some examples of the traditional recommendation systems, and then we will see what are knowledge graphs, how knowledge graph embeddings are generated, and how we can incorporate these knowledge graphs into recommendation systems. And then we will see a case study of RippleNet, which uses knowledge graphs for recommendations. So let's dive in. So why exactly there is a need of the recommendation system? So as we all know, there is a tremendous amount of the data generated every second of the day. So for example, millions of tweets are generated, thousands of the YouTube videos are generated. So there is definitely a need for recommendations. Recommendation systems are also beneficial for users as well as for companies. So from the user's perspective, they get recommendations from this millions of YouTube videos or thousands of Amazon products. You get to know which exactly is you might be interested. So you don't have to scroll through entire catalog of the products. So which definitely increases the customer satisfaction. And when the customer satisfaction is increased, there is a definitely increase in the purchase from the customers, which increases the sales and revenue of the company. So here are some examples of the recommendation systems which are at play in the tech giants. So for example, Netflix has a recommendation system which suggests us which movies or TV series we might be interested to watch. So from the thousands of movies available, depending on what you recently saw or depending on your particular interest, Netflix suggests you movies to see. And it is also has been analyzed that 80% of the people watch the movies or TV series from their recommendations only. And obviously, these recommendations are driven by machine learning. So similar to Netflix, Amazon also provides recommendations. So depending on your previous watch history, so as you can see here, depending on which category of the items you have previously bought, Amazon will recommend you products you can buy. You can as well as from your recent view history, they will suggest you the items to purchase, which is definitely useful. So now let us see how exactly this recommendation systems work. So in a typical recommendation system, there is a user. There are millions of users which interact with the system, and you get this user click, watch, and browse history from the clicks of the users. And for the e-commerce websites, you get the purchase history of the user. So all this information of millions of users is passed on to the recommendation engine, and then recommendation engine, depending on the user preferences, user history, and similarity between the different users and items, suggests the next recommendations to users. And also after these recommendations are provided to user, depending on which recommendation user accepts by clicking or purchasing that product, that feedback then flows into the recommendation system. So more and more you interact with the this recommendation systems, better and better your recommendations will be. So what are the techniques used in the recommendation system? So recommendation system is basically divided into the two systems. So one is a collaborative filtering and another is the content-based recommendations. So what happens in the collaborative filtering? So as we saw earlier, you get this user item interactions, which is which will be via clicks on the various items, or people may give explicit feedback by commenting on that product or giving reviews for that product. So these are various ways you can get the user interactions with those products. So in the collaborative filtering, we basically leverage this interaction matrix which is present. So for example, if the user A has watched these two movies and there is another user who has also watched these two movies, so we can say that because they have watched the same movies, these users have similar interest in the similar interest or similar taste in the movie. So if the next time user A watches this third movie, we can definitely recommend this movie to user B. So this is how collaborative filtering comes up with the similar users and recommends similar movies to similar sets of users. So how content-based system varies from the collaborative filtering. So in the content-based system, instead of coming up with the similarities between the users, we come up with the similarity between the items. So if the two movies are very similar, so they have similar genre, so both are belonging to the fiction genre, and or both have the similar actors or similar cast present, there is these movies are considered as similar. So if the user A watches one of the movies from this cluster of the same movies, next time we can recommend the another movie from that same cluster. So you can see here the basic difference between these two methods. So collaborative filtering considers the history of the user clicks or views, while the content-based system considers the characteristics of the users or items to come up with the similarities between the two entities. So there are various hybrid recommender systems which are developed, which basically leverages both collaborative and content-based systems characteristics. So they basically consider both the history of the user interactions as well as the characteristics of the items. So now let's see what are knowledge graphs before we go into the how knowledge graphs are used in the recommendation systems. So what exactly is a knowledge graph? So knowledge graph is basically represents this large knowledge base which consists of the various entities, objects, various relations between the objects. So these objects can be either people, or in the movies case, it can be movies or news or this Amazon products, various Amazon products, categories of these products, and then there will be a relationship between these products. So how this information is represented? So it is represented in the form of the triple. So there is a head entity, tail entity, and a relation. So this head entity is related to tail entity by this relation entity. So for example, if there is an information present that Tom Hanks starred in Castaway, so how we will represent this is Tom Hanks, which is the head entity, starred, which is a relation, and Castaway is the tail entity. So this is how triples are generated for this knowledge base, and knowledge graphs are created. So as you can see here, there can be in numerous amount of relations can be present, and relations can be different. So starred is one form of relation, then there can be directed, then there can be genre, etc. So now let's see what are the knowledge graphs is used in the industry. So knowledge graphs basically became famous when Google published its Google Knowledge Graph in 2012. So Google Knowledge Graph is based upon this huge knowledge base, which basically is leveraged when we search any query into Google. So for example, if you type India into Google search, you will get this web page, and as well as in this web page there is this box which has all the information for India. So what is who is the president of India, what is the capital of India, what is the population of the India. So at the back end of this information population, there is a knowledge graph present which basically extracts this relations and entities from this knowledge graph. So here India is related to New Delhi because New Delhi is the capital of India. So here the relation is capital. So India who is president of India is Ramnath Kovind. So Ramnath Kovind and India are entities here, and relation is president. So similarly, there are knowledge graphs leveraged in the social engines. So Facebook has this huge social graph where people are related to each other because one person is a friend of another person, or one person is following another person, or people and groups are related because people are part of some groups, or people like some some Facebook pages and all. So this is how this social graph works, and this is how basically you get a recommendation when you see in your Facebook app. You get a notification that people you might know. So this is how using these social graphs you get this recommendations that you can be friends with this person, or you can like that group depending on your common interest or your past. For example, you get the recommendation to add a particular person who was your college mate or school mate, etc. So similarly, LinkedIn also has a knowledge graph, which basically has entities like members, which are basically people. Then there are jobs, job titles, companies, colleges, universities, and various courses, various certificates, which are very popular. So, and this is how people are connected in this LinkedIn graph. So for today's discussion, we'll consider this movie knowledge graph. So here you can see entities are basically your movies, your actors, your various genres, directors, producer, etc. And there are then these relations between these different entities. So what are the entities here is Castaway, Green Mile, Back to the Future, Tom Hanks are all the entities, while relations are genre, star, directed, style, etc. And so how we will come up with the triples from this is when there is a relation between movie and genre or movie and actor, we will derive a triple. So for example, Tom Hanks starred in Green Mile. So that is our triple, where this is head entity, relation, and tail entity. Similarly, Castaway, genre, adventure is our triple, head entity, relation, and tail entity. So this is how knowledge graphs looks like. So why exactly do we need KG in the recommendations or knowledge graphs in the recommendations? So as we saw earlier, there are these two techniques which are majorly used in the recommendation: collaborative filtering, which uses the user item interaction matrix. So we all know there are millions of items, millions of videos, millions of Amazon products which are present. So if we build such a matrix, user item matrix, it will be very sparse, and it is very difficult to handle such matrices to come up with the relation because of the sparsity. So there we get an advantage in the knowledge graph because we have these connections between the users and items, users and their interests. So we can definitely leverage that. Another problem with the traditional recommendation system is the cold start problem. So a cold start problem is basically faced by the collaborative filtering method, where we need the history of the user purchase or user watch history. So whenever the new user comes in, we don't basically have a history for that user. So it is very hard to recommend products to those users. So what are there are a couple of things which are done to solve this problem. One is you basically recommend which are the popular items or which are the popular movies. You basically recommend those items to that user. Or another way is you basically you will have some profile information for that user. For example, people in India might like Bollywood movies, specific Bollywood movies, or people in USA will like Hollywood movies. So this is how cold start problem is solved. So and another problem in recommendation systems is we have to come up with basically in the content-based recommendations, we have to come with the user or item characteristics, which are basically most of the time hand-driven. So what is the age of the user? What are or for any item, for example, for movie, what is the cast of the movie, who directed that movie? So in the knowledge graphs, because we have this connections between the items, we can come up with the characteristics very easily. We will in the next couple of slides, we will see how these embeddings are generated for the items from the knowledge graphs, which basically combines all of these characteristics of the items. And then the next major difference between the knowledge graphs and the traditional recommendation system is explainability. So it is difficult to let aside the recommendation system. So in any deep learning system, it is very difficult to come up with some explanation why that recommendation was done, or why the particular item was classified in some class. So knowledge graphs also solves this problem through the interconnections which are present between various users and items. So in the next few slides, we will see how knowledge graphs basically comes up with the explainable recommendations. So as we saw, there are these embeddings generated for each of the entities. Now we will see how this knowledge graph embeddings are basically generated. So what exactly are embeddings? So embedding is a low-dimensional continuous vector representation, which is learned from the this huge corpus which is present, which is available. So, for example, in any deep learning or machine learning system, you can't just input text as is to your system. You have to basically convert that text into numbers. So embeddings is basically a way to convert that text representation into the vector representation. So there have been various developments, lots of development in this area. So first we started with the one-hot encoding, which is basically you take entire corpus and come up with the vector of corpus. Suppose you have 10,000 words in your dictionary, then your vector size will be 10,000, and you basically one-hot encode that vector. So for example, your word is start. So then only index of that start word will be 1, and that is your basically embedding. So there is another method which is called as the bag of words method, or DFIDF method, which basically considers the frequency with which that particular term or word occurs in your data set. So next there is a word-to-vec, which was a neural net based method, unsupervised learning method. Then there is GLOVE, FastX. Elmo is basically which considers the contextual word embedding. So what happens in the word-to-vec and GLOVE is you consider only the context present in that particular sentence for a word. So suppose word bank, which can be a financial institution, or it can be a river bank. But this non-contextual embedding techniques will come up with only one representation for both of these words. So Elmo basically comes up with the two representation or multiple representation for word, depending on the context, depending on the semantical context or sense of the word. So it will, for example, for bank, it will come up with the two embeddings. So then there is a recent development in the transform area, which basically derives the embeddings of the word. So let us see how word-to-vecs comes with the word embedding. So basically, the main concept behind the word embedding, generate the embeddings for the words which are very close in the meaning or in the context, which appear in the same context in your corpus. Those words basically will have same representation or same vector representation present. So for example, if we have this huge movie data set where we will have sentences like Tom Hanks starred in the movie Castaway. So here let's just not get into details how this Tom Hanks was combined as a face. So suppose you come up with these phrases, Tom Hanks and Castaway, which is actor and movie. So after applying your word embedding techniques, ideally you should get all your embeddings for the actors, actresses in the same cluster or nearby. Similarly, all your movies will be collected together. Obviously, there will be some distance between what in which context those movies occur, but but more or less you will have a one cluster which is dedicated to particular words which appear in the same context. So how exactly are this word embeddings generated? So as we saw earlier, here the context is the main important factor. So we in word embeddings, basically we decide how much context we want to consider when we come up with this embedding. So in the skip-gram model, what happens is, for example, you want to generate embedding for the start. So in the skip-gram model, given the start word, you try to come up with the embeddings for its neighboring word. So if the context we are considering is 1, so given start word, you have to come up with embeddings for Tom Hanks. So this is basically your positive samples, and you also come up with the negative samples, because your objective is to gather together words which appear in the same context, while the words which do not appear in the same context should have the embeddings which are very distant. So that is the reason we also consider the negative samples. So basically we sample positives from our entire data set of words which co-occur in the context window of 1, and negative samples from the words which do not co-occur in that data set. That is our negative sample. So our objective here is to maximize the probability, or maximize the or minimize the distance between the positive samples, while maximize the distance between the negative samples. So this is basically objective function or loss function. So basically for each of this positive pair, we come up with some predefined or which is a hyperparameter. We can determine how many negative samples which we want to sample from the data set. So if we take this analogy of the word embeddings to the knowledge graph, so knowledge graph embeddings are basically motivated from this word embeddings. So similar to the data set we have for word embeddings, for knowledge graph embeddings, obviously we are training it on the knowledge graph. So if you consider our movie knowledge graph, which looks like this, we can come up with the positive triples and negative triples. So positive triples are basically relationships which are present in your knowledge graph, while negative triples are relations which are not present in your knowledge graph. So for example, here, because Tom Hanks starred in Castaway and Green Mile, we have positive triple. Tom Hanks starred in Castaway, Tom Hanks starred in the Green Mile. So we basically, this algorithms, what they do is they generate the negative triples using the positive triples by corrupting your tail entity. Corrupting is basically you replace that tail entity with the entity which is not related to that head entity. So for example, here we have Tom Hanks starred in Interstellar, so which is your negative triple. So similarly, we have positive triple Castaway, genre, adventure, and your negative triple is Castaway, genre, documentary. So which is basically not true. So here again, our objective is to keep embeddings of the positive triples close together, while embeddings of the negative triples should be far away. So here basically our what we are trying to achieve is, when we add embedding of the head entity and a relation, we should basically get the tail entity. So which is very similar to what we all of us know, that king plus man is equal to woman plus queen, right? So that is the analogy we can bring to knowledge graph embedding. So here we want to maximize the margin between the positive and negative triples, but at the same time we want to minimize this score between the head and tail entity through the relationship R. So we'll see in the next couple of slides how this score function is determined. So there are multiple models which are present, which basically tell us how we can come up with the embeddings for the head and tail entities. So there is this trans-E model, which basically tries to obtain a embedding of the tail entity, so such that if we add the embedding of the head entity and relationship entity, we will get the tail entity. So here score function is basically a difference between H plus R minus T. And you can take the L1 or L2 now for the score function. So for example, in our movie scenario, if we have this relation, Tom Hanks starred in Castaway. So here basically what this model will try to achieve is embedding of the head entity plus relationship should be equal to T. So what there is some obvious problem with this method, because the head this model assumes that the head entity will be related to tail entity with only one relation. So basically there is only one outgoing edge from the entity, so which is not case in the knowledge graphs. So what happens in typical knowledge graph is entity can be related to multiple entities through multiple relations. So for example, Tom Hanks starred in Castaway as well as Tom Hanks starred in Last Mile. So because this model tries to approximate the embedding of the tail entity by adding head and relation entity, what will happen is this model will try to achieve Ti and Tj so that they are very similar. So which is not really a case, because Castaway and The Last Mile are two different movies which belong to two different genres, which are directed by two different people. Only the common link is Tom Hanks. So this is not really feasible in the real life scenario. So there is another model called as the trans edge, which basically provides solution for this. So in the trans edge model, it assumes that the heads it assumes basically that head and tail entities can be related via multiple relationship, and it assumes that there is a hyperplane which is associated with each relation. So basically the embeddings for this head and tail entities are obtained after projecting your actual head entity onto this projection space or hyperplane of the relation, which is very specific to one particular relation. So you will basically so this model also tries to achieve same. So when you add head and projected embedding of the head entity and projected embedding of the tail entity, and add the relationship embedding for that particular relation, then we will get this is what it tries to approximate. And score function is also very similar. It tries to achieve the minimize the difference between this embeddings, this two sets of embeddings. So as opposed to trans-edge basically is capable of representing this one to many, many to one, and many to many relationships basically. So another problem, there is another problem with the trans-edge. Basically what happens here is it assumes that the entity space and embedding entity space and relationship space is basically the same. So there is only a hyperplane associated with each relation, but the embedding space are assumed to be the same. So there is another model called trans-R, which basically considers that the entities are altogether located in the different space and relations are located in the different space. And then there is this projection matrix which converts the head entities to the relationship entity to the relationship space using these projection matrices. Which are basically very specific to each of the relation. So similar to trans-E and trans-H, the objective function is basically the same, and trans-R is also able to achieve one-to-one, one-to-many, many-to-one, and many-to-many relationships.
So these are some of the embedding techniques which are used to generate the embeddings for each of the nodes in the knowledge graph, which is basically entities and relationships. Now we will see how all of this combines together to add it into the recommendation systems. So KGN recommendations basically. So we saw how embeddings are generated for the knowledge graphs. So we will see how these embeddings are used in the recommendation system. So typically in the recommendation systems with knowledge graph, we will have a knowledge graph. We will also have a user feedback, which is in the form of the clicks, views, settings, purchases, etc. And then we will have this item attributes, which are characteristics of the item. So we can basically use all of these features together to come up with the recommendation systems. So how these are converted into into basically embeddings or representation, which can be consumed in the your algorithm. So for the knowledge graph, we derive the knowledge graph embeddings. For user feedbacks, we have this user item interaction matrix. And for item attributes, there is this paper called collaborative knowledge base embedding, which uses which is basically a recommender system for movies. So there, what they have used is for item attributes. Also, they derive embeddings using the text which is associated with each movie. So, for example, each movie will have cast associated, what is the plot of the movie in 2-3 sentences. So we can basically convert it into some form of embedding. Similarly, they also use a poster of the movie. So there is a poster associated with each movie. You can convert that into some representation, and that is also fed into your recommendation systems. So then all of this data, all of these representations are fed into, you can basically apply any sort of function, any dot product or anything, any simple function also to come up with the recommendation. So this is how the embeddings are incorporated into recommendation. So problem with this approach is it does not incorporate the structural benefits of the knowledge graph. So there are this relation, even though they are basically condensed into this embeddings, it is not explicitly used in the recommendations. So there is this another set of the recommendation systems called as the path-based recommendations, which basically leverages the structural information of the knowledge graph. So here also we have knowledge graphs. Then we have this user item interaction matrix. For the knowledge graphs, we basically what here we do is we calculate the connectivity between the users and items using various meta paths and meta graphs. So what a meta path is basically, in the simple terms, it is just a subset of the path which is predefined, and meta graph is also a graph which is predefined. Last few years, there has been a development to come up with through deep learning methods what can be those paths or graphs. So typically these paths can be predefined. So for example, our movie case, there is this graph which is predefined. So if the user has watched a movie, it is starred by some particular actor, and its genre is it has some particular genre, and then there is another. So this is basically our graph, or this is basically our graph. So user, watch, movie, star, actor, then there is movie, genre, some genre, right? So then there is this another user who has also watched some movie which has same same genre. So basically, through this connectivity between different entities of the graph, we can identify that this users might be seen. So here also objective is to come up with some sort of similarity between the users or items depending on this connections between the users. So this is very similar to the concept behind the collaborative filtering. So there also we try to come up with some sort of similarity between the users or items. Here also we are coming up with the similarity between the users depending on the structure of the knowledge graph.
right? So after we have this some sort of connectivity score between the users and various items, we can apply a feed forward network, deep neural network, or simply use a collaborative filtering methods to come up with the recommendation system. So this is how path-based recommendation systems using KG work. So we saw how embedding-based systems and path-based system works. So there is a basic flaw between these two is they both do not leverage all of the information which is present in the knowledge graphs, right? So a path-based system uses the connectivity between the users, but it does not use the embeddings which are associated with each of these entities, while the embedding-based system does not use the structural information which is present in the knowledge graph. Okay, so now we will see a paper which is a RippleNet paper, which basically combines both of these approaches, which is embedding based and path based, to come up with the recommendations. So idea behind RippleNet is it tries to propagate, so using the structure of the knowledge graph, it tries to propagate user preference across the various entities present in the knowledge graph. So it is very similar to ripples which are generated in the water. So when you drop a stone into water, you get these ripples which are basically propagate into water, and as you go further away, the effect of this ripples is diminished. So similar to that, if the user has watched a movie Forrest Gump, so it is because of this connections between various entities and Forrest Gump, we can say that user is interested into a drama genre, user is interested in films directed by this particular director, or user is interested in movies of actor Tom Hanks, or user is basically interested in movies from USA. And then there is this next level of the connections between the this first level of connections, which is basically we call hop 1 ripple set, then there is a hop 2 ripple set, and then there is hop 3. So you can go till some k hops depending on your requirement. You can basically tune this parameter, so till which hops you want to go ahead. So basically this is how ripples or interest of the user is propagated through knowledge graphs. And RippleNet basically leverages this into recommendation generation. So we'll see now how exactly this is done. So RippleNet basically has a knowledge graph. It also uses the user item interaction matrix, which is basically your click history. Then we basically try to predict a function using this embedding U of the user and embedding V of the user. And so as we saw earlier, the basic idea behind the RippleNet is preference propagation. So seeds are basically items which user has viewed, and then we propagated it to one level items which are basically one distance or one relation apart from the seed items. Then there are hop 2 items and hop 3 items. As you can see in the picture, of either you go away from the your seed items, the lighter the node gets. So the analogy here is lighter the interest, so it user interest fades away. So items which are very close to the purchase item or watch history of the user is more interested in those items. So you can basically then suggest only items which are related to hop 1 or hop 2 and don't go away from the seed item. So this is how RippleNet architecture in details looks like. So this is basically your knowledge graph. Seed is user click or watch history. Then there is a embedding associated with each of these items, which is your item embedding. So which can be calculated using knowledge graph embeddings, or you can just embed it. For example, the textual and visual embedding we saw, you can do that also. So after we get this embeddings, what we want to see is how much the relevance of this seed entity and hop1 entities, hop1 head entities is there. So this relevance probability is calculated using the softmax across head entities and the seed item embeddings using the relationship matrix through which the items are related. So this is how we get the probability scores for the Ripple one set. So this blue block is basically your probability score, so which determines this item embedding is how much relevant this entity H1 from the Ripple set 1 is relevant to item embedding. So darker box means the this fourth head entity is basically more relevant than other entities. So this is very similar to the attention mechanisms which we use in RNNs. So after we get this probability scores, basically what we do is we weight the tail entities using the this probability score. So and we get this output matrix. So this tail entities are weighted averaged using the weight of the this relevance probabilities. Okay, so this is how first hop works. So in the second hop also we will use the tail entities from the first hop and we will propagate it further to second hop. We will similarly get the relevance scores between these entities from the first hop and entities on the or items from in the second hop. And this basically relevance probabilities are propagated into the knowledge into your network. And finally what we do is we basically get the user embedding in the form of represent, so weighted average of the tail entities in the hop 1, weighted average of tail entities in hop 2, which is basically this O vector. So this is how you get basically the concept here is you get the relevance which is propagated from your hop 1 to hop n or hop h. So this is how user embedding is achieved. And then you combine user embedding and item embedding. So here also you can basically use just a simple softmax, simple sigmoid function, or you can attach some feed-forward network or with the recommendation score. Okay, so important factor here is how this basically this relevance probabilities are generated. For example, if we consider the our movie data set, so there if user is interested in the movies by Tom Hanks, then that relevance probability will be higher than probably if user directed. So user might not be that interested in the who is the director of the movie. So that relevance probability will be basically less than the relevance probability between the user and actor Tom Hanks. So that is here our movie is basically a seed and actor is basically your head entity. So this relevance probabilities are basically useful when we want to explain the recommendations. So we can basically propagate this relevant probabilities backward and come up with some score and explain why this particular recommendation was done. So we'll see an example how this recommendations are explained. So here is an example from the RippleNet paper. So they basically what they did is a news recommendation approach. So here we have a click history. So we will basically have the user click history. So from this click history, you know that user has clicked on this top row items, so which is Navy SEAL, North Korea, nuclear weapon, and all that. So then there is a second layer. So user has clicked on US. So this US is basically you can see that it is relevant through multiple path. Then finally using this propagation method, basically you propagate this relevance from the item which are clicked, 2 intermediate items, hop 1 items, hop 2 items, and finally you get the final recommended item. So here candidate or recommended news is Trump announces gun verdict. So here basically your entities, final entities are police, Donald Trump. So as you can see here, there are various scores associated with each of these ages, which are basically the relevant probabilities. So basically you can explain now why this police Donald Trump, why this candidate news or was recommended. So depending on this score. So since you can backtrack this because this was the higher probability path, this was higher probability path, and then this was higher probability path. So probably because user clicked on Navy SEAL, then through this path you can explain why because user clicked on Navy ships and US, this particular news was recommended to users. So this is how recommendations from knowledge graphs can be explained by backtracking this relevance probabilities to the user history items. So this is all for today's discussion. What are the takeaways for the today's session is knowledge graph basically is improves the precision of the recommendation system because it comes with the large side information which can be incorporated into knowledge graphs by various methods. Also, because of the heterogeneous nature of the knowledge graph, since it has various different kinds of the relation, it can incorporate multiple domains. For example, in the news case, we have this multiple domains present. So knowledge graph can integrate this information also and keep track of varied interest of the users through these connections. It basically is improves the performance of your recommendation systems. And last but not the least is you can explain your recommendations through backtracking this connections or relevance probabilities between various entities. So that's all for today's session. Let me know if you have any queries. These are some of the references you can go through. Let me know if you have any queries, questions. You can reach me at my LinkedIn. Thank you.
Thank you so much, ma'am. That was an amazing session. And moving forward, we've got a next speaker. That is Miss Maddie Mantha. She's a senior technical analyst at Raza, and she's going to be talking about Raza Deep Dive.
Hi everyone, I'm Maddie Mantha and I'm a Senior Technical Evangelist at Raza. Today I want to talk to you about some things to think about when you're building production-grade AI systems. If you've built an AI system before, you'll know that it's really hard to build a good one. It's easy enough to build a prototype or a simple chatbot that you can, stand up in a couple of hours, but to ship something that actually solves a problem, like automating 30% of conversations or decreasing card abandonment rate, is difficult. POCs don't really uncover the hard challenges, going to production does. And the way that you build really great conversational AI is you need great research. You need great models for both NLU and dialogue, so we'll talk a little bit about what we're doing in this space. And just like with any other software application, conversational AI isn't that much different. You need engineering best practices. It's not enough to have the most accurate or performant models. You need solid engineering principles like CI/CD, integrated version control, a microservices architecture, if that makes sense for you, like using Kubernetes or Docker and so forth. And one of the really cool things about conversational AI is that users will literally tell you what they want. They'll ask the contextual assistant something in a way that you haven't trained, or they'll tell you if your answer is irrelevant or wrong. So listening to users and using those insights to improve your assistant and automating that process is known as conversation-driven development. And this practice is an effective way to build those robust and resilient assistants that work in production. So we'll talk about this. And we're still kind of in the early stages of conversational AI, to be honest. Even though this is something that's been around since the 1960s, we're still in the early stages of building something that everyone can use. And in order to accomplish this, we need to find a way to bring everyone into this community so they can contribute in a meaningful way. And that's been our mission at Raza, is to include everyone in this technology wave this time, and to empower everyone to build and use conversational AI. Raza builds the standard infrastructure layer for conversational AI. So as a data scientist or a developer, you'd use Raza to build robust contextual assistants that go beyond answering simple FAQs and really engage in multi-turn interactions. And the way that we do that is by building open source models and infrastructure and championing other open source tools. We have a great community that's nearly 10,000 strong, and we support them. We also have a research team that ships applied research directly into the product so that it works reliably when you use it. And we'll talk about some of the latest research here today. And we're really blown away by the community that we have. And we know that it's essential, especially when you're building open source products and tools, to have developers from all across the world build assistants with Raza. It's in production in some of the largest companies in the world today, from Walmart to JPMC to Lemonade, N26, in all industry verticals like insurance, healthcare, banking, customer service, and so forth. And feel free to check out our showcase page. There's some great open source and free examples there, and also videos of what some of these companies are building or maintaining in production today, to see how NLP and conversational AI is being leveraged in the real world. So before we talk about some of the things I mentioned today, on a high level, right, here's how you use Raza in your project. And here's where it fits in your stack. As we talked about, Raza is a customizable infrastructure layer that provides conversational AI building blocks in a plug-and-play architecture. And every conversational AI application, regardless of what framework you use or if you're just building everything from scratch, is made up of several distinct layers. The computation layer, which is consists of programming languages or machine learning frameworks. You have the conversational AI infrastructure layer, and then you have the tools and services layer that are on top of the standard infrastructure layer. And then you have the application layer as the place where your assistant resides. It can live alongside other systems and web applications. For example, if you're building an enterprise help desk assistant, an enterprise's payroll, HR, and IT systems live here. And depending on your AI assistant's use case, it might interact with one or more of these systems. And applications at this layer also have user interfaces that your users will actually see and interact with. So I know you're probably all wondering about the slide here, but let's say you're making a pizza, right? If you know how to make pizza, you know that you need raw ingredients for the dough. You need cheese, you need sauce and toppings and so forth. And you might have three options. You could make all of the ingredients yourself. You could customize prepared ingredients and put all of the components together to make a pizza that's tailor-made for you. Or you could buy a pizza with everything pre-built and pre-chosen that you can customize. So just like you can't write your own programming language and you can't write your own machine learning framework. I mean, you could, but you typically don't. You don't have to build everything from scratch, and you can extend these tools, customize and transform them to fit your use case. You can use open source infrastructure layers to stand up an assistant, because it abstracts away some of the complexity involved in having to build your own, and instead you could go to production sooner. And before you start building a contextual assistant, it's important to know that not all AI assistants are the same. There are some assistants that are basic command line tools, and some that can handle multi-turn natural interactions and actually handle dialogue. There are, akin to the 5 levels of autonomous vehicles, there are 5 levels of AI assistants that can be explained by their capabilities. And the driving force behind these levels and really behind building AI assistants is that conversational AI allows you to interact with technology the way that we interact with each other. It's natural, intuitive, seamless, doesn't need onboarding, and typically should not have any barriers to entry. That last part is important. You don't have to be a machine learning researcher or a scientist to build AI assistants. You shouldn't have to be a technical expert to use technology. So on a high level, right, the TLDR version we have two perspectives here. We have the end user perspective and we have the developer perspective. So at level 1, we're really just putting all of the onus, all of the burden on the user to figure out how to use the bot. And developers at this level are using the command line to create a chatbot. And as we move up these levels, we're using conversation-driven development where we're listening to users and understanding them better to automate that process over time. And from the end user perspective, at level 1, they have to figure out how to use the chatbot. But as we move up, the assistant starts to do more and more on the user's behalf, and they simply have to talk to it. You know, the user doesn't have to say things exactly in a way that they think the bot would understand it. They would just say something as they would, as if they're talking to a person, and the bots, it's the assistant's job to disambiguate what the users want. So the driving theme is that the assistant feels more like something that's built to help us and less like an API endpoint. So, you know, let's walk through these levels from the developer perspective, right? Because, you know, in this talk, we're talking about how to build those performant and production-grade assistants. So at level 1, you have a command line app, and it can send you notifications and perform some kind of calculations on the user's behalf. And it's very easy for the developer to add new functionality because it's just changing some code and not really giving much thought into making it easier and more seamless for end users. And at this stage, you have traditional notification assistants or something like a mortgage calculator on a website. And at level 2, you have a basic chatbot. You can ask the assistant a simple question and expect a pre-built response. It can even handle some basic back and forth and dialogue. But everything is rule-based and powered by if-else statements or state machines. At this point, intent identification and entity recognition happens, but the dialogue management is not powered by machine learning. End users still have to do a fair amount of work. And for developers, it gets harder and harder to maintain lots of rules as this project scope increases, you know, because they have to continue to cater to those edge cases with if-else conditions. And they have to ensure that things don't break as they keep adding new functionality. And this is the most common type of assistant that we see today, and it's probably something that you've already built. And at level 3, the assistant is able to build up some more and pick up on context, or what the user has said before, and when, where, and how they said it. Level 3 assistants are also capable of understanding and responding to different and unexpected inputs because the assistant learns from previous conversations, and it improves in accuracy and in generality over time. These assistants are buildable today. At level 4, right, the assistant gets to know you over time, and at the end is, you know, as a result, is super personalized to you and to your use case. And at level 5, you know, at level 4 and 5, users simply have to talk to the assistant to get the help they need. And the assistant adapts to what the user needs. The user doesn't have to put in the effort like they would in the case of a level 2, right? So at level 3, 4, and 5, the developer's job is to use the process of conversation-driven development to listen to users, to collect user conversations, and use those insights to make iterative improvements to the assistant. And over time, they can automate this process by using CI/CD, by using integrated version control and things like that. But the entire process at level 5, although it can be automated, although we can build adaptive assistants that really adapt to what the users are saying, right? We don't want to automate that entire process because we still want humans to intervene and supervise this process. So, right, at the most basic level, an assistant has to do two things, right? It has to be able to understand what a user is saying, and it needs to decide what to do in response. So we start with a message, right? For example, here the user wants to change the address associated with their account. They send their message through a messaging channel like Twilio or WhatsApp or Facebook Messenger and so forth, or it could even be, you know, a chat widget on a website. the text of that message is handled by the NLU model, where it's transformed into a numeric representation that the machine learning model can interpret. The NLU model makes a prediction to classify the meaning behind the user's message, the intent, and it extracts key details like the entities, right? And the output of that model is sent to the dialogue management model, whose job it is to decide what the bot should do next. At this point, the next action might be to make a call of some kind, make a call to a backend system like a database to retrieve the user's account details and something like that. Then, Raza's open source decides to, choose a response to send back to the user. And so we need good research to handle both NLU and dialogue. So let's first talk about NLU. The past 2 and 3 years have been amazing for NLP, right? The past 20 months or so, especially because we saw Google's BERT, which is an NLP pre-training technique released by Google. And one of the cool things about BERT is its ability to pre-train bidirectional contextual language representations that are modeled on very large text corpus. And as a result, the pre-trained BERT model can be fine-tuned with just one additional layer, and it can really be used to create state-of-the-art models for a lot of tasks, a lot of NLP tasks like question answering, language inference, named entity recognition, and it can do that without any kind of substantial task-specific architectural modifications. And this was great, right? It allowed us to create better representations, better applications with better accuracy. And not just BERT, but a lot of large-scale pre-trained language models have shown promising results on language understanding benchmarks like GLUE and SuperGLUE. And since these embeddings are typically well-equipped to generalize across tasks, they're pretty popular. But large-scale pre-trained language models aren't always ideal for developers building conversational AI applications. Large-scale pre-trained models tend to be compute-intensive, training time intensive, and they actually present pragmatic challenges for software developers that want to build robust AI assistants that can be quickly trained and quickly iterated upon. And if you're building multilingual AI assistants, right, it's important to achieve high-level performance without large-scale pre-training, because most of these pre-training models are trained on English text. So that's another problem if you're trying to build an AI assistant in Thai, Vietnamese, or Hindi or something like that. So it's not always necessary for conversational AI applications either. A lightweight model like Convert, trained on just conversational data, can be more performant than a large-scale model trained on entire wiki databases in some cases. So if you're building an AI assistant, it might be important to know what kind of metrics you're going on and make a decision accordingly. But at Raza, to effectively handle intent classification and entity extraction, we recently updated our NLU model and built something called DIET, or Dual Intent and Entity from Transformers. It's a transformer-based model that does joint NLU prediction. And prior to DIET, Raza's NLU pipeline used a bag of words, or a non-sequence model, where there was one feature vector per user message. And it was a pretty fast, tough to beat baseline, but now we're going beyond it. And DIET uses a sequence model that takes word order into account, and thereby it offers better performance. So DIET is a multitask transformer architecture that does intent classification and entity recognition together. It consumes one message, and it spits out intents and entities at the same time. So, it's one model that does both. And it can use any kind of pre-trained language model in a plug-and-play architecture. So I just want to go over the architecture diagram here with you, so you can see the various pre-trained embeddings like BERT, GLOVE, Convert, and so on. You could just plug them in right there. And in our experiments, there wasn't a single set of embeddings that was consistently best across different data sets. And so that's why we thought having a modular architecture was really important, because you can plug and play and choose the kind of components that work best for you and your use case. So how this happens, right, is that raw text is split into tokens. In the simplest case here, it is splitting the sentence into words with white spaces. We just use a white space tokenizer. The tokens are then represented numerically with vectors, and then processed even further by identifying the intents and entities. So let's take a look at the pre-trained path here on my screen. The token gets fed into the algorithm. It is then represented numerically with vectors. And you can plug and play any pre-trained model here, like BERT, convert, glove, embeddings, right? And that happens in all of those places where you see the red arrow pointing to pre-trained embedding. And on the other side, we're generating sparse features from the tokens. So think of this as a one-hot encoding of the word. And we also take character engrams. And then this is passed into a feed-forward layer. First, everything is concatenated and processed in a feed-forward fashion. Then the output from the pre-trained path and the concatenated output from the sparse features path is concatenated once more and inserted into another feed-forward layer. So let's take a minute to actually look at the feed-forward layers across the diet architecture. You see that in 4 of those places. All of these feed-forward layers here in diet are sparse from the get-go, which is more conducive to conversational AI because, dense layers are pruned after the fact to make them lightweight, and all of the feed-forward layers are sparse, right? So after this processing occurs, the result is a vector, which is then passed onto the transformer layer, 2 transformer layers actually. And a sequence of entity labels get predicted through a CRF, or a conditional random field tagging layer, on top of this transformer layer output sequence that corresponds with the input sequence. So for the intent labels, the transformer output for the classifier token and the intent labels are embedded into a single semantic vector space, and we use the dot product loss to maximize the similarity with the target label and minimize the negative samples. And if you're a developer that's trying to build really robust conversational AI, all you need to know is that Diet is a lightweight plug-and-play multitask transformer architecture for NLU prediction, joint NLU prediction for intents and entities. That's all you need to know. And here's how you can use Diet in your Raza project. So here's an example configuration file. The configuration file in Raza is where you define and set your NLU pipeline and policies. And before the Diet model, you can specify any kind of featurizer. We use the convert featurizer, and you also need a tokenizer because these models don't split on whole words. They have embeddings for subwords and pieces of words, so you need a specific tokenizer to go with the featurizer. And you can just select that when you're using Raza. And features get passed into the Diet classifier, and then use to predict intents and entities. You can also tweak hyperparameters on the Diet classifier. And in our experiments, we tried 4 different types of features to pass into Diet. We used sparse features, we used glove, which is a word-to-vec model, and we also played around with BERT, and then we looked at convert, which is from Matt Henderson and co-authors, released in 2019. And the data sets that we used for doing the experiments is called the NLU benchmark data set. The repo is actually on GitHub, and the domain for this data set is human-robot interaction in a smart home type settings. It's a pretty large data set, actually, 64 different intents, 54 entity types, and it has like 26,000 labeled examples. And we also, used ADIS and SNPs, and the focus of the experiments was on the NLU benchmark data set. This is because this is the most challenging of the 3. The state-of-the-art on ADIS and SNPs is already close to 100% test accuracy, so it's not super meaningful for us to continue to use those. And the previous state-of-the-art was on the NLU benchmark dataset was the Hermit NLU model. Right, so the first result that we found is that even with just the sparse features, Diet outperforms the previous state-of-the-art. The previous state-of-the-art is the Hermit NLU model, right, which uses Elmo and Elmo embedding. So there was a lot of pre-training that went into that model, and Diet outperforms it by nearly a point on the intents and entities without any pre-training models, with just counting the character engrams. The second result that we saw is that, which is also interesting, is with glove features, Diet outperforms, so that the glove features perform better than BERT. So glove features allow Diet to perform better than using BERT as a featurizer. The third result that we saw was that the convert embeddings perform best on the NLU benchmark dataset that we used. Convert features have actually been available in Raza for some while now, and when you use convert features with Diet, in our experiments, we found that it performed best overall. And another super exciting result that we found is that not only does Diet outperform BERT when using BERT as a featureizer, right? Glove worked better in that scenario. It actually outperforms fine-tuning the whole BERT model. Fine-tuning large-scale pre-trained models can be computationally intensive, but of course you can take advantage of, NVIDIA's really great GPUs to be able to do something like that. But using Diet with sparse features and convert as the featureizer without any fine-tuning outperforms fine-tuning BERT. And so this is using BERT within Diet and back-propagating all the way through and fine-tuning all of the weights. And not only does it outperform, it's also 6 times faster to train, which is really exciting. So now let's talk about the second part. The first part of what an assistant should do is to identify the intents and entities, right? And the second part is to be able to, for the dialogue model, to be able to predict what to do next, whether it's to call a database or send a response back, and if so, what kind of response it can send back to the user. And you can have rules, definitely, like in this case, right? In the case of level 2 assistants, but rules don't scale beyond a certain point. And even then, they're not going to be really helpful in supporting multi-turn dialogues. But they're certainly helpful to get you started if you wanted to build a basic chatbot. So let's say, in addition to looking at your account details, which we saw in the example a few slides ago, you also want this assistant to be able to tell you how much money you spent, and you want this assistant to be able to perform a checkout for you, right? In order to perform a checkout, it needs things like it needs your address, it needs your credit card info if it doesn't have it on file already, and it needs a shipping method, right? It needs something like, okay, well, express, regular, or whatever. So it's going to try to gather this information in a form setting before it can perform the next task or action, which in this case is processing your order. But real conversations, don't follow the happy path. They often deviate from a linear or sequential path. Users often interject with off-topic messages. Like here, the assistant says, hey, your total is $1,550. Can I just use the credit card you used last time? And instead of, you would expect the user to say, hey, yep, go ahead, do that, and the assistant to place the order. But here the user said, hey, hold on, do I still have credit on my account from the refund that I got before? So you want to be able to handle that little sub-dialogue and then move on, right? And if you're using rules, you can't necessarily do that. The main task, which was to check out, has to be placed on hold, and this sub-dialogue has to be handled first. So you probably want to keep, let's say you're trying to handle this, right? You probably want to keep a list of all of these sub-dialogues and check them off one by one, and then return to the main task at hand, which was checkout. But what happens sometimes is that users will loop back to earlier topics. Here, they went back to asking about the credit they had in their account towards the end, right? And you simply can't anticipate human behavior, right? Because in the middle, they engaged in like a little bit of chit chat here and said, wait, hold on, are you a bot? And then the bot has to answer that and then move on, right? So that's why it's critical to test your assistant with real user conversations. Our recommended approach is that as soon as you build a minimum viable assistant with some basic happy paths covered, test it with real users and add that training data and train with it so that your machine learning policies can better generalize from them and better predict how to handle unexpected user behavior like what you see on my screen. So if you want your assistant to, which we do in our case, like handle a certain amount of customer service requests or automate a portion of conversations to reach a goal or a business outcome, you have to be able to handle these paths. And state machines aren't always going to be best suited for this because, as you can see, they can't scale beyond if-else statements, and there's no way you can predict all of the ways that users behave. So Right. Well, how do we handle this type of complexity and handle these types of multi-turn interactions within a model if you want to use machine learning? And we worked on a way to attempt to solve it and built something that didn't have to use a state machine. And we released something called the TED policy, which is a transformer embedding policy, right? And people typically use a recurrent neural network to be able to handle subdialogues. And it makes sense, right? RNNs are not stateless. They have memory cells or a special memory effect, allowing information to persist. And as a result, they can keep track of context. Here in this diagram, we have a series of outputs, right? We have Y1, Y2, and Y3. And these are the predictions that the model has to make. So here at Y1, this prediction is, if you look on the left-hand side, this prediction is the question that it has to ask. And at Y2, it has to listen to user input. And at Y3, it has to respond this way, right? And the W's are weights. The input is multiplied by a set of weights, and then we apply another set of weights to keep track of the middle state there. So we apply another set of weights before we go to the output. And when we make the second prediction at Y2, that memory is evolved throughout the sequence, and this happens in a loop during the conversation. So the prediction at Y3 is dependent on not just the input, down here, but on all of the previous inputs. So as a result, this model takes conversation history and context into consideration before it predicts the next action or response. But, as you can probably guess here, right, that you'll find that this memory, this middle state, can be quite problematic because it has to be updated each time there's a new input. And this operates on the assumption that every input is important and meaningful. And that might not be the case in a conversation where certain turns in a conversation, certain dialogue turns, may not be that important or relevant to the outcome of the conversation or the goal at hand. So, if the user says, hey, tell me a joke, that's not, that important to the goal at hand, which is to perform checkout. So this brings us to a natural next step, which is not all input is equally important. So not all input should be treated equally. You want to be able to pick which turns to pay attention to and which ones to ignore. And so attention has been a pretty useful concept in conversational AI. In this example, is the connection between the word it and the words preceding it. So in the first one, right, it says, the animal didn't cross the street because it was too tired. And the word it here refers to the animal. The animal didn't cross the street because the animal was too tired. And here in the next one, it says the animal didn't cross the street because it was too wide, right? And here, it refers to the street. So the animal didn't cross the street because the street was too wide. And here's another translation model between English and French. And you can see that the model is paying different attention to different words in the input as it's producing these tokens. Some have a pretty simple one-to-one correspondence, and some are not so simple and have contributions from, as you can see, a lot of the previous pieces from this sentence. So transformer works with self-attention, and you're looking at the sequence to produce the next token. So TED has a predefined architecture. Here, what you see on my screen here is what we call a story, which is a conversation path. And the setting is that of a hotel check-in assistant. It again needs some information before it can search hotels and make a booking for you. And here in the middle, where you see chit chat, is the user digressing or engaging in conversation that doesn't have an outcome on the goal, which is the goal is to confirm what the user wants and make a hotel booking. And on this graph here, you see that we plotted attention or attention weights. On the vertical axis is our predicted dialogue turns, and the horizontal axis is the dialogue history over which the TED policy attends. And we have a unidirectional transformer, so the upper triangle is masked with zeros to avoid attending to future dialogue turns. So the model learns essentially, right, which conversation turns to pay attention to and which ones to ignore. It ignored most of, as you can see, it ignored most of the chit chat history. And it started paying attention again when the user started cooperating with the assistant and answering a question about the hotel price range and the number of people traveling. And you can add more chit chat or some other kind of digression here asking about something else in that conversation, and the model will still be able to like not pay attention to that and recover from that when the user starts cooperating again, because it goes back to look at the last relevant piece of information that the user provided, which is up there talking about start and end dates, and which parts to ignore in order to make that next prediction. And because it does this, it's much more equipped to handle unexpected user behavior. With a recurrent neural network, each of these inputs gets tracked and added, and it becomes harder to recover if a user were to cooperate again. This is a pretty useful way for you to handle those kinds of sub-dialogues in ways that users will definitely behave when you're trying to build and release a contextual assistant in production. And this is a great way to handle those kinds of sub-dialogues and unexpected user input. Of course, you also need a lot of training data. You want to be able to collect real user conversations and train your machine learning models with that, so you can handle unexpected user input. So basically, this model is open source. It's available on GitHub, and it's a way to handle unexpected and uncooperative user dialogues on fewer training data, on fewer examples. So it uses these examples and is able to better generalize from these examples. It looks at previous conversations, trains on them, and thinks, okay, well, I kind of know this. I kind of know what you're talking about. When it sees something unexpected or something it hasn't seen before, it's better equipped to make a reasonably confident prediction as to what should happen next, and based on that, what it should respond with. So no rules, but data and machine learning, specifically self-attention to solve for sub-dialogues and multi-turn interactions. So we talked about the first piece, right? For building great conversational AI, you need great research. So great research isn't enough to build those contextual assistants, because machine learning is no longer a niche field, but it's a foundational piece of software engineering. So we need to treat it like that. And in order for us to be able to do that, we need to follow software engineering best practices, such as implementing a CI/CD pipeline and doing what we like to call, everything ops, right? It's an extension of machine learning ops, but you should also take security and privacy and other ethical considerations into account when you design and build. So we wanted to abstract away some of the complexity involved in deploying conversational software. And because we definitely spend a whole lot of time, hyperparameter tuning or collecting data and using that data to train our models, we wanted to make some of these other things easier, like deployments easier. And so if you run that script, within 4 minutes, you can have a fully containerized deployment of Raza open source. And what it does is that it installs Kubernetes Lite rather, installs Helm chart with everything. And we wanted to make it easier for teams to use the best technology and still build production-grade assistants. So great research and engineering principles aren't still exactly enough. You want to follow the process of listening to your users, or following the practice of conversation-driven development. And there are 6 actions involved in conversation-driven development, and these aren't linear actions, as you can see. And you will often find yourself going back to reviewing your conversations after you've annotated training data, or you will test things at several stages within your applications. So let's walk through what conversation-driven development is and what each of these steps are, so you can try to follow them as you build out your assistant. So the first step is to share. Give your prototype to users to test as early as possible. People will always surprise you with what they say. Teams spend months designing conversations that might never happen, right? Or they will over-engineer solutions. So share it with test users, and so that they'll talk to it, and you can start to analyze user behavior and use those insights to improve your assistant. And then review, so take time to read these conversations that people have with your assistant, whether it's in the test phase or in the production phase, right? From prototype to production. Too many teams get caught up in looking at things, looking exclusively at metrics like what % of my users express this intent, or what's the sentiment like, and that's not super helpful immediately. But looking at what users are saying And using those insights to train your assistant and making those adjustments will really improve your assistant in production, and it will make sure that it's production grade. So annotate is the next step here. Improve your NLU model based on these messages from real user conversations. So when you're building a POC, you can come up with examples yourself or generate hypothetical conversations and synthetic examples, and that'll help you get started, just like rules. It's a good way to bootstrap your assistant. But make sure that before you go into production, not more than 10% of your data is synthetic, because in production, it's not gonna perform super well if all of your conversations are synthetic. So use those test user conversations to train your assistant. And then obviously the next step is test, right? Use whole conversations as end-to-end test for your assistant. Professional teams don't ship applications without tests. So you should be writing unit tests, integration tests, functional tests, and you should also use whole end-to-end conversations as tests for your assistant. And then the next step is track, right? Come up with a way to identify successful conversations, like beyond successfully answering the question, which is one way to track a successful conversation, but look at actions and other ways to identify successful conversations. You know, for example, a user taking an action like signing up for your service, or a user not taking an action like not getting back in touch with support within 24 hours. Use that data to tag and filter conversations and understand what's working and what's not working. And then obviously the next natural step is to fix it, right? So when you study conversations that go smoothly and ones that failed, study them, and successful conversations can become tests right away. And you want to use end-to-end conversations as tests. Unsuccessful conversations, on the other hand, show you where you need more training data or where you want to fix your code. So track the different ways that your assistant fails, so you're reducing failures over time. And CDD is a user-centric approach to building AI assistants, and it requires more than just software skills. And it's also not a linear process like you saw. You'll find yourself jumping between each of these actions. You know, some require a deep understanding of the domain of the end user, so you'll probably want to connect with subject matter experts for that. And other actions like fixing and testing might require software skills, annotating might require machine learning skills. So it's a collaborative process between product, design, and development teams that to reveal what users are looking for and to be able to use that to build robust and resilient assistants. And over time, your assistant will adapt to what the user wants, rather than expecting the user to adapt to your chatbot's behavior, right? And how we'll get there. So we talked about all of the ways to build conversational AI and how you can practice conversation-driven development to build those level 3, 4, 5 assistants using Raza X, which is a tool that allows you to visualize conversations, that allows you to tag and filter conversations, allows you to share it with test users, with real users, and it also allows you to test your chatbot and train it right away and ship it, push it back to production. But how we get there is through open source technology. Communities building and learning together and shipping applied research and putting that directly into the product that we build. Because open source really makes the field progress like 10 times faster, as it has in many different examples. Like it happened with the web, where it was open sourced, and that really gave us Web 2.0, which is something that our CEO Alex liked to talk a whole lot about. But open source is definitely one of the ways to really progress the field and make it so that everyone can contribute meaningfully and everyone can actually use it. So conversational AI, for that reason, it needs you. And some of the ways that you can help make this field better is that you could go ahead and build something great and share it with others, so you can inspire others to build great conversational AI too. You could go to our forum, or other forums and share where you got stuck or share where you made some progress so that others can help you out or learn from you. And really talk to others about how to build NLP solutions and how to build chatbots so that we can all learn together, and eventually we can build something that really works. And that's been our approach to this really inspiring and difficult problem. So I hope that you go to our forum and check out those solutions and engage with the conversational AI community about what's next. So thanks for listening. And if there are any questions, I'm happy to take them now. Or you can just reach out to me if you want to send me a DM on Twitter, or if you want to send me an email, and I'd be happy to answer some of those questions. All right, thank you.
Thank you so much, ma'am. That was really wonderful. And moving on, we've got a next speaker lined up. That is Dr. C.S. Jyotirmay Rao, ma'am. She's a senior scientist, technology innovation specialist at Novozymes. And today she's going to be talking about understanding genomic feature of pathogen through AI lens. Over to you, ma'am.
Yeah, thank you, Shashank. Let me just share my screen.
Yes, ma'am, sure.
Yeah, just give me a second so that I can share my screen. I'm not able to. Just give me. Why can't I see it? Yeah. Yes, I hope you can see my slide.
Yes, ma'am, we can.
Yeah. Okay. Thank you, Shashank. Uh, Good morning, friends, data enthusiasts, students. So the whole idea of this workshop, I'm going to talk about how we can extract some genomic features from any pathogen if we have a genetic material. So the title of my workshop is Understanding Genomic Feature of Pathogen Through AI Lens. So before we take a deep dive into this uh, subject, I wanted to introduce myself. I have done PhD in life sciences in 2001 from Mumbai University, and my area of research has always been microbial genetics. And I have looked at cancer genomics. I have looked at cataract. I've also have some interest in precision medicine, where we can actually integrate the genetic information in such a way that it can give you a kind of tailor-made medicine for all kind of diseases. So the whole idea, my research interest is not just to microbial genetics. I also look into innovation, biotech innovation. I'm also into patent analytics. So I've worked in some of the big research institutes, government research institutes in India, like CDFD, CCMB in Hyderabad, NCCS in Pune, and I'm working in corporate field also. That is, I'm working with the leading biotech company, Novozymes, and I'm also a registered patent agent. So from past 2.5 years, I'm trying to. I have learned about data sciences. I have invested time in learning data sciences and deep learning models, and I'm trying to integrate them in genomic studies and patent analytics. So the whole idea here is, for this workshop, uh, I want to talk about how do we, when a sequence is given, a DNA sequence is given, how do we, if you are not from you're not from a biotech, or you're not a molecular biologist, but you are from some other field, you still can work on it if you know few things. So basically, before I go to my Python notebook and start executing different lines of code, I want to give you a primer on what exactly is the genomic structure, what are the things you have to take care before you go into this kind of analysis. So I will start talking about genomic features. How do you extract genomic feature from a pathogen using AI tools? So I want to give you a kind of a broad overview of what is genetic material and where it resides and what is its function, So all of you know that our genetic material, the basic building block is DNA. And where does it reside? DNA resides in nucleus in higher organisms. So it resides in all cells of our body, and every cell has a nucleus, and the nucleus has our DNA. For higher organisms like any animals, birds, or humans, the DNA is organized in a structure called chromosomes. And as you know, we have 23 pairs of chromosomes, and our so every chromosome um, every encodes DNA for all your physical attributes, all your physiological attributes, how every cell in your body is going to react to the environment. So this information, which is encapsulated in chromosomes, has to tell the cell environment or the cytoplasm of a cell that what kind of proteins it has to produce under what conditions. So if you see, our human body is made up of so many different types of cells, and every cell will function very differently. Liver cell will do liver functions. Heart cell will beat. It keeps the rhythmatic beating of the heart. So every cell has certain traits. So, but if you see the genetic makeup of every cell, it's the same genetic material. But how a cell behaves is is an information how the cell, based on the location, based on its feature, based on the function, those kind of genes get switched on, and the cell behaves in that way because of the proteins produced by the certain kind of proteins produced by the cell. So how does a cell know what proteins to produce? So this information is captured in your nucleus, and the nucleus has the DNA. The information trapped in DNA has to come to the environment of the cell and tell the cell what kind of proteins it has to produce. So there is a big process, a complicated process. So I will try to give it in a very simplified format so that you can understand. So the DNA travels from the nucleus. DNA is transcribed into a different molecule called RNA. RNA travels from the nucleus and goes to the cell, gets into the cell environment or cytoplasm of the cell. And uh, this in the cell we have some so we have, every cell has different organelles, and the RNA which is traveling from nucleus to the cytoplasm gets attached to ribosomes. It's a small organelles present in the cell. There it starts translating the RNA into protein, and those proteins which are functional proteins are getting expressed, and cells start secreting those proteins. So the whole idea here is the three molecules are important for us to know, that is DNA, RNA, and proteins. DNA is made up of nucleotides. DNA is a double helix structure, and if you see the backbone of the double helix, it is made up of nucleotides, a chain of nucleotides. And there are four different kind of nucleotides, that is guanine, cytosine, adenine, thymine. And these are the four nucleotides what you find in DNA. So how does the DNA differ from RNA? So if you see here, DNA, so the information, genetic information travels from DNA to RNA, RNA to protein. The process between the information travel between DNA, uh, the information transferred from DNA to RNA, the process is called transcription. And the process of RNA getting translated into proteins is called translation. So the whole idea here is DNA has made up of four nucleotides, AC, GT. And when it gets transcribed into RNA molecule, the RNA molecule, if you see here, the second strand, so one of the strands of DNA will get transcribed into RNA. So if you see the sequence of ATGC, what you see for DNA is very similar to RNA. But if you see, there's a single difference. RNA doesn't have thymine It doesn't have T's. Instead of T's, it has U, that is uracil. So when a sequence comes in front of you, you can easily make out whether it is DNA or RNA, because DNA, you will see the nucleotide is made up of the out of 4 nucleotides, one of the nucleotide is T, but when it comes to R, the nucleotide is not T, but it is U or uracil. So when the information from RNA has to travel to protein, what kind of protein has to be produced? So you see here the triplets of RNA nucleotides will translate into one protein. So what happens is the whole string of RNA is getting translated to protein in such a way that there is a code here. There is a kind of a codon usage. There we call it codon triplets. What we are talking about, triplet is nothing but a set of 3 nucleotides will dictate what kind of protein it has to produce. Okay, so there's a codon table. Every organism has a dictionary that which set of nucleotides will form encode what kind of protein. So if you see here, almost in most of the places we have in the multicellular organisms, we see that a protein always starts what is the starting codon, that is the methionine, and there are 3 stop codons. I'll be talking about that. And if you see on the top, I've shown you how do you sequence any organisms or any. So you get DNA, RNA either from single cells like microbes or from multicellular organism. You just collect, you take blood, you take mouth swab. You just have to need some few number of cells for you to extract DNA or RNA. Once it is extracted, you can actually sequence it using DNA sequences. So we have big sequences. When you load your samples, that will show you the sequence in this format. So if you see these, their 4 nucleotides are colored differently. So this is how we see the sequence when we do DNA sequencing. Okay. So I want to go to my I want to show the Python notebook which I'll be using for this. Uh, just give me a sec. Yeah. If you see here, this is the I'm going to use this Python notebook to explain further. So the whole idea, what I'm doing here is I'm going to take COVID-19 virus sequence, and we'll see how we can using a special library called BioPython. How when we take a pathogenic DNA sequence or RNA sequence, how can we process that? Okay. So why I have taken COVID-19 virus? It's very interesting because if you see we are going through pandemic where we are all confined to our houses and we cannot travel. We have to take a lot of precautions because the whole world is going through a pandemic. A small virus which is invisible has made us being so careful that normal life has come to standstill. The whole idea here, I'm trying to say that you can start if you have not explored genomics sequences, if you have not done any of this kind of any kind of experiment, you can start working now, because uh, our world is full of so many microorganisms. Microorganisms are, they can be beneficial and they can also be pathogenic. When they become pathogenic, it can actually really make fatal, in the sense it can result into such huge death toll. And so there's so many possibilities. So it is not new. This kind of pandemic is not new to our humankind. We have come across in coronavirus itself. Coronavirus, the COVID-19, COVID-19 is something which has affected us drastically. But we had this kind of pandemic situation in different years. Like in 2003, we had SARS epidemic, which started in China, and it actually uh, actually affected such a big population, but not it was not as virulent or as what do you say, it was not very it was a contained epidemic. You cannot say pandemic, you can say contained epidemic. So it was not that well spread, but it did cause a lot of loss. In 2012 we also saw MERS, Middle East Respiratory Syndrome. um, in Saudi Arabia, again, it got life got affected, and now we see COVID-19, where because of which from March, at least in India, we started lockdown in March, and but this virus had started in China long time back. So I want to show you the first report when this happened. I Yeah, there's a Nature paper. The uh, China did the first sequencing of COVID in 7th Jan to 2020, and it got published. The whole world knew by 3rd February 2020 that what is the sequence of novel COVID uh, virus. And this virus, another problem with virus is there is a huge possibility of it getting mutated. I'll show you why this why if I'll show you when I'm going through this notebook. I'll show you that what may give you an indication whether a virus or a sequence what you are working on has this ability that it can mutate. Okay, so the whole idea of this workshop, I'm going to divide this workshop into two parts. In the first part, I'm going to take COVID-19 sequence, DNA sequence, and I will do the analysis on that. And then second part, what I'm going to do is I'm going to take sequence for MERS and SARS, and we are going to see how does our COVID sequence matches with how much similarity is there with SARS and MERS. Because even if we have some kind of similarity, even that will give a good indication that how do we proceed. Yeah, so that's the agenda for today's workshop. And I've also written an article in Medium titled Learning Basics of DNA and DNA and RNA Analysis with COVID-19 Sequence. So there I have given a very elaborate explanation for anybody who is new, who's starting new in this field and who wants to invest some time in understanding this area of research. So if you see the structure of COVID-19, it is called coronavirus because it is the envelope of the virus has crown-like structures. These structures are called spike proteins. So the outer envelope of the coronavirus, COVID-19, has three different proteins: M protein, S protein, E protein. So it protects the single stranded RNA, which is encapsulated or trapped in this envelope. So it looks this is a artistic rendition, but if you see microscopic in the electron microscope, it's so tiny, and this is a tiny microorganism. It is not visible to human eye. You have to have special instruments to see this microbe, the structure of the microbe. So it has a characteristic of a crown like structure, and that crown like structure is nothing but your spike proteins. And what is the function of spike protein? The spike proteins get attached to the human cell, and it injects the RNA, the pathogenic RNA, into the cell in a human cell. And in human cell, the RNA goes and attaches with the main genomic DNA, and instead of the cell genomic material instructing the cell to produce what kind of proteins, your pathogenic RNA will start instructing the nucleus of the start instructing the cell to produce those proteins, those pathogenic proteins, which it needs to replicate, which it needs to increase in number of organisms, And once the cell has enough amount of there's enough rounds of replication, what has happened is the cell is almost it is no more a normal cell, it is infected cell, and it is going to start dying. So the whole idea is and all of you know that coronavirus affects the lung cells, right? And it tries to destroy the lungs in such a way that the person start getting acute respiratory distress. So the whole idea is we're going to look at using biopython. So the whole we cannot use any other library because it has to recognize the sequence of DNA, RNA, or any genetic material or protein. So we need to have this library to start with. So you can do pip install biopython. So that in that way you can install biopython. Once you have biopython, I have loaded few libraries, numpy and pandas. This is for general purpose for, and then I have also matplot. I have also loaded matplotlib and seaborn. These are the two libraries for visualization. And so biopython has a sequence input output function which helps us to read the sequence, DNA sequence in the format of FASTA. What is FASTA format? So if you see most of the wherever you look for sequences, any kind of DNA, RNA, or protein sequence, they are represented in FASTA format. It's a format in which you will see that there is a I'll show when I'm loading the FASTA format. So the FASTA format, your DNA, RNA, protein structures are represented in FASTA format. So the whole idea is, again, I'm going to reiterate that it's very important that when you have a DNA sequence, you can transcribe the information present in DNA into RNA, and genomic information present in RNA gets translated into amino acids or a chain of amino acids, and that chain of amino acids results in the functional protein. So the basic block of DNA is nucleotides. Basic block of for RNA is also nucleotide. But in DNA you have thymine, but in RNA you don't have thymine, you have uracil. And the RNA gets translated into amino acids. Each triplet is coding for one amino acids, and chain of amino acids is will with specific folding is going to result into a functional protein. So let's start our investigation into the DNA sequence of COVID-19. So if you see, my file is in a FASTA format. So FASTA format file will have a suffix of FNA. So I am using sequence input output function dot parse. So I'm parsing my the data, which is DNA sequence of COVID-19, which is seen in FASTA format. So I load it using parse command, and once I load it, if you see this sequence, the sequence start with nucleotide. So in many of the cases also, the first line is where is the sequence, which is it, which organism, and those information is there. And sequence IO can easily make out where the sequence starts. So if you see here in this COVID-19 file, you have a sequence, so you can easily make out the sequence. What you see here is a DNA sequence. It's not RNA sequence because it is made up of T's, not U's. And at the end of it, you will see the length. So I have the data file is talking about 29,903 nucleotides. So that is the structure of coronavirus. The genomic makeup of coronavirus has a COVID-19 virus has these many nucleotides. Okay. Yes. So what have I done? So if you see here, I have loaded this to, once I do the read, you can do parse. So if you see the difference here, when I did the parse, it picked up only the DNA sequence. But when I say the read, it's going to pick up all the information present about for that sequence. So it talks about the sequence. The record has sequence, that is 29,903 nucleotide long sequence. Then you have the ID. This is the ID which is present in the repository, DNA repository, which is maintained by NCBI. Okay, and it has a description. If you see the description, it talks about severe acute respiratory syndrome coronavirus 2 isolate Wuhan HU1 complete genome. This is the complete genome. Genome is the term used for the complete total sequence or total DNA RNA present in a cell. That's called, that terminology is used. Genome is used. Gene is a single genome will have multiple of genes residing in that. The collection of genes for a cell is genome. So if you see here, so I have read my sequence, and I know that I have loaded my file. Now I can start working. So I'm here, it is DNA and RNA. I'm just telling you that the main difference between DNA and RNA is that DNA is double helix, RNA is single stranded, it's not double stranded. And the difference here is DNA will have thymine and and RNA has uracil. So that's how you can recognize whether the sequence given to you is DNA or RNA. Next, what I'm doing is I'm taking the DNA sequence, and I want to calculate, I want to basically total, I want to see how many adenines are present in that 29,903 nucleotides, how many adenines, how many thymines, how many guanines, how many cytosine. So I'm running a for loop for that, and I want to look at the frequency of this different nucleotides in the sample. So so transcription, as I have already told you, transcription is a process when you want to convert your DNA into RNA, right? Before that, I just wanted to show you that I calculated the frequency of ATCG, all the nucleotides. And when I plot, if you see here, um, A always goes with T. There is a universal law, that universal concept, that A's adenines always bind with thymines. Adenine and thymine are gets bonded to make the double helix by double bonds. Okay, and G always goes aligns with cytosine, and G and C gets bonded by triple triple bonds. So if you see the strength of GC bond is stronger, the strength is high compared to AT bonding. So this is how, when you have any gene or any sequence which has more GC than AT, that means that gene is highly conserved. So how the term conserve means that there's very low mutation happening in those genes. But if you see here, looking at our COVID-19 frequency of ATCGs, you see A and T are higher than GC. So if you have a sequence like this, it looks like it has a high capacity of mutating. So there's a possibility of that's what is happening in COVID-19. If what we know in the world after it started spreading, COVID-19 has almost 30 different variants already in the human population. So that mutation, because there's a less conservation, there are more ATs than GCs. So there's a high possibility of this genome undergoing mutations. So yes, so let's take our DNA and do the transcription so that we have RNA structure. So you just have to take our DNA sequence and call for the function transcribe function, and the transcribe will do the translation of your DNA into RNA sequence. So if you see here, the sequence remains the same from DNA, but if you see, the T are replaced by U's. There's no difference between messenger RNA, DNA, except for two things, that DNA is double helix, RNA is single stranded, and DNA has thymines and RNA has uracil. It is this. This is also, if you see, I have not written RNA, just simply RNA. I have written as mRNA. There are three different kinds of RNAs in a cell, and we are more interested in messenger RNA because messenger RNA is a RNA which travels from nucleus to cytoplasm, conveying the genetic information from DNA to uh, DNA to our cell, right? So this is messenger RNA, and if you see the sequence, if you look at the length of the sequence, the number of nucleotides remains the same, 29,903. So we have done this transcription. We have got the sequence of RNA, single stranded RNA, and we can also, what is the next step? We can translate that RNA sequence into um, strings of amino acids, or the instruction is, you can see that how your RNA is encoding for proteins. So if you see here, I have just used, I've taken the messenger RNA sequence and I have translated that. When I do a translate function, and I can also print the, I'm printing the length of the protein, length of the amino acids. So if you see, as soon as I did the translation, you will see that there are certain kind of stars in between. Do you see stars? There is a chain of amino acids, and there are different chains of amino acid. They are separated by star or asterisk kind of. So this shows that our 29,903 nucleotides are giving instruction to many different proteins, and all these proteins have, if you see, there is a different sequence. So we can actually, the length of the protein is a very important aspect for us to understand what kind of. So there are so many proteins, each protein has different length, different amino acid. The sequence of amino acids decides what kind of protein it is going to produce. And if you see, our messenger RNA, when it got translated into 9,967 amino proteins. In this 9,967, not all proteins are functional. You need few things to say that what has to be, there are few parameters to tell what kind of amino acid sequences are functional. So let's go and explore. If you see, I have separated, all the protein structure by taking a delimiting, um, using a delimiter of asterisks. So I can do that. I have split all the, I have actually made a list of all the amino acids which COVID-19 DNA sequence is encoded. So when I split it, I can also look at each chain of protein, and I have made a, so I have taken all of them and I'm calculating. So amino acids, just a little teaser that we have 20 different amino acids. So proteins are made up of amino acids, and they are different. There are 20 different amino acids what a cell can synthesize. So what I've done is I have taken all this, I've taken all the protein structures, separated them, and um, I'm also looking for the functional proteins. What are the functional proteins? So here, if you see here, any protein which is, um, the length is greater than 20 or equal to or greater than 20, I'm considering them to be a functional protein, because very small chains of amino acids is not going to give a functional protein. Functional proteins are proteins which have subunits. Proteins are complicated, they have different kind of folds. Those are very important for their function. So any protein, what I'm taking here is, out of 9,900 and some odd protein chains. I'm I'm going to I'm going to filter out those amino acid chains which are less than 20 in its length. And I have done a describe on that. So if you see the spectrum of my protein, the spectrum of the protein in COVID-19 is uh, minimum is 20 because we have that is our cutoff. So maximum, if you see, it is 2701 amino acid long. So you have different lengths of proteins we see. So 50% is 25 in length. But if you see as we go to maximum, so there's a wide range of uh, different proteins here, ranging from 20 amino acid in length to 2701 amino acid in length. So if I can also put it in a data frame. So the if you see the length, so the length is differing, and I'm considering only those proteins which are 20 or more in length in amino acids. I'm considering them to be functional to do further processing. So if I see, yeah, so this is a different sequences. Again, to reiterate, the difference between DNA and RNA is not much. It's the same sequence. The only difference is T is replaced by U in RNA. So if you see, what have I done by doing transcription and translation using BioPython? I have taken 29,903 nucleotide long COVID-19 DNA. I've reduced that to 9,967 proteins. And in this proteins, again, when I filtered it, I've again reduced it to 80 functional proteins. 80 functional proteins which has a length more than 20. So I was talking about how the proteins work. So if you see the chain of RNA, the triplets, that is the set of 3 nucleotides, their sequence will tell what kind of amino acid it has to produce. So I can also show you the codon table. This is the codon table I was telling, how our cell recognizes that which set of nucleotides should encode what kind of protein. So our if you this is a it has the position one first letter, so and position second letter and third letter. So the combination of three, the sequence of 3 nucleotides give rise to a certain proteins. So start codon for any of the gene, the start codon is AUG. So if you want to recognize in a DNA sequence where could be a start codon, that is when you have a set of nucleotides which has AUG, that is your start codon. And we also have stop codons. We have 3 stop codons called UAA, UAG, UGA. That means it tells when to stop, thus when the protein, when should the amino acid synthesis should stop. So this is the stop codon is what you have seeing in the when we did the translation, you saw asterisk. That asterisk is nothing but the stop codon. So the protein synthesis stops wherever wherever the ribosome come across a stop codon. So yeah, so what I have done here is BioPython has all there are many aspects in the sense you can utilize many of these features to do further analysis. So what I have done is I have taken the list of 80 amino acids and I'm trying to figure out all the different traits of those proteins by importing prot_parm. That means it is going to look at the protein structures and then it is going to give the parameters. So there are some it follows certain rules which tells what kind of a chain of amino acid, what kind of protein it is going to encode. So I'm putting my all the protein data, 80 functional protein data, and I'm asking it to give me the amino acid percentage. Amino acid percentage is nothing but, as I told you, that a cell can synthesize 20 different kind of amino acids. So this out of 20 different amino acid, what is the frequency of each amino acid for each protein? I'm also asking for molecular weight. What is molecular weight? when you know what kind of amino acid it is encoding, every amino acid has certain weight, a molecular weight. So when you combine the all the different amino acid happening in that protein, you can actually calculate molecular weight of that protein. And molecular weight is a very important character for a protein. It helps us to understand, it is a very important aspect of a protein for a molecular biologist. Then aromacity. Aromacity is because every protein has specific foldings. So this will help us understand. This is another a very important um, feature for a protein. Flexibility, how flexible it is, right? Isoelectric flexibility, in the sense, if the protein is made up of 3 subunits, the flexibility will be low. If it is not subunit protein but it is very simple protein, then it will be highly flexible. So there's some parameters to it how we can calculate, and biopathin has this biopathin can do all that. It can also calculate isoelectric point. So molecular weight, aromacity, flexibility, isoelectric point, they're very important characters of a protein. Then we also can derive secondary structure fractions if there is any secondary structure. Just to give you a little bit more into proteins, proteins is not a simple chain of amino acids. The amino acid has primary structures, secondary structures, and tertiary structures for it to become functional. So all that is encoded in your string of amino acids. So if you see here, so it has actually looked at all the 80 functional amino acids, and it has derived this information what I was looking for. So if you see, it gives me this frequency of amino acids. So I have different, so for every protein, it is giving the frequency of amino acids, to what percentage is their occurrence. So if you see, adenine has not let me see, leucine. Yeah. So let's take a protein, amino acid A. So alanine has this much of uh, occurrence. The amino acid percentage seen for this protein is this. So when you compare, let me see if there is a high occurrence of any protein here, a greater occurrence. Yeah, I'll show you in a plot when we take all the 80 functional thing, that what are the predominant amino acids, and why they are important, why that information is important. So if you see the molecular weight of this protein, it gives you molecular weight, it gives me the aromacity, it gives me the flexibility, it also gives me isoelectric point, how polar, how what is the polarity. These are the things which are very important for a protein. Knowing your protein, in the sense this pathogenic protein, there's a possibility that you can actually, if you can take spike protein and look at the structure of it, and once you know the structure and the different traits, you can easily see what kind of vaccination efforts are going on. So if you know what are the important proteins, you can actually tag them in such a way that you can produce a successful vaccine. And when you tap these proteins, when you stop them being expressed or stop them in uh, doing destructive activity on the cell, then you can contain the pathogen. That's the whole issue here. So I have all the, after doing this running, I have details for all the 80 functional proteins. So what have I done? I have taken the molecular weights of all the different molecular weights I have taken, and then I have taken different frequency of all the amino acids. So when I plot here, if you see here, uh, my y axis is molecular weight, and x axis is all the different amino acids. So if you see, leucine and valine, yeah, these are the L and V are high in occurrence. Okay, so this is something very important, right? Certain amino acids are predominant, and this knowing this is very helpful, right? Yeah. I have taken the molecular weights, and I can also do a data frame on that, and we can also do a describe on it just to see what is the extent of range of molecular weights we'll come across. So what have I done? I have taken the this is I have taken the only 10 proteins. I've taken the top 10 proteins, and out of the top 10, I have just again done the frequency plot to just to see if I take the top 10 proteins, what is the which amino acids are predominant. So this is a random, yeah. This we have explained, yes. So what I have taken is I have taken all the functional proteins, that is 80 different functional protein. I have done a histogram on that. It just gives me a range. If you see here in a preview, you can easily make out that most of the proteins are somewhere less than 250 in its length, and you have very few protein which is a little higher than 500 in its length, and there is one protein which is higher than 2500. We have seen the maximum was 2701 amino acids. So there is one. So if you see here, you can clearly make out that the protein which is of higher length may be very important, right? So the whole idea is, can we do kind of I've done some plots taking, I've done one plot where I've taken all the proteins less than 60 just to see what is the profile. We know that less than 2, they are predominantly all the proteins are less than 250 in its length. So I've just taken a subset of uh, proteins which are less than 60 just to see what exactly is, what kind of length we see in uh, the proteins produced or being encoded in the COVID-19 genome. So if you see, there are a lot of proteins which are less than, which are 20 to 25, right? So this gives you a kind of, a range, what kind of proteins you are coming across. When I plot anything above 1000, I get this protein. So I can also I can look at the um, sequence of this protein which is 2701 or something, so 2. So if you see, this is the sequence of the amino acids. So this protein may be very important because of its length, and because it is occurring in less, but it is going to replicate. So when it in the human cell, when the cell gets infected by COVID-19, so the COVID-19 will instruct the cell to produce a lot of proteins, and in this may be a very important protein, right? uh, that's the first part we have completed. Now we can look at the comparative genomes. Very simple. What I've done is I have COVID-19 sequence. I've also collected MERS, FASTA, sequence, SARS sequence, and I'm using BioPython pairwise pairwise comparison tool function, so that what I can do is I can do a pairwise alignment and see how similar they are, right? So if you see, when I call for the length of SARS, COVID, and MER, the MER has a bigger genome. It has a bigger genome with 30,049 nucleotide long genome, and second comes COVID, 29,833, and then comes the SARS. So next thing is, what I'm doing is, here I'm doing a pairwise alignment of so I need to use this function pairwise to dot align dot global xx. This is the function, and in this I put which two sequences I want to compare. So I'm comparing, in the first case, I'm comparing SARS with uh, COVID-19, and the second I'm comparing MERS with COVID-19, and the third one I'm comparing MERS versus SARS. So if you see here, Our COVID-19 sequence has very clear cut similarity, in the sense it is COVID-19 sequence is highly similar to SARS to an extent of 83%. And if you see the comparison between MERS COVID and MERS SARS, it is only 69, or if you even round it up to 70%. So, if we know that COVID is very similar to SARS, so there are a lot of patents. If you go and look for it, there are a lot of patents which talks about how to target SARS, how to combat SARS, what are the vaccination um, possibilities, what are the strategies. So we know that means we can go and look for them and see whether what we suggest the strategies for SARS, combating SARS, can we use it for COVID-19. So this give an indication, because we are suggesting this because our COVID sequence is very similar to SARS and the similarity is 83%. Just a small information that in humans we differ very in to by 1%. In humans we all differ by 1%. So if you take your the genome sequence, when you compare, we all differ by only 1% when it comes to genomic makeup. So what I've done is I've plotted them. So if you see what we were discussing, the SARS and COVID has high similarity compared to MERS, right? um, so after doing all this, what we have understood is we started our analysis on whole COVID-19 genome. And COVID-19 genome is made up of 29,903 nucleotides. And we have seen, when we looked at the frequency of different nucleotides, we saw high frequency of A and T, right, than C and G. And when we translated our RNA sequence, DNA, when we transcribed the DNA to RNA, translated from RNA to uh, amino acids, we ended up with 9,967 amino acids, right? And when we look for the functional proteins, we ended up into 80 functional proteins. So we are capturing so much of information here. And when we looked at the frequency of amino acids, out of 20 amino acids, we saw there is a high occurrence of lysine and valine, right? High occurrence of lysine and valine than other amino acids. So we also know lysine and valine are a good indicator that when they are present in a protein, they actually encode for alpha helices. Okay, I'll just show you the alpha helices, how it looks. It looks something like this. Okay, your protein structure, as I was telling you, proteins have secondary structures, tertiary structures for it to be functional. So when we know the kind of amino acids the COVID-19 genome has, you can also have an indication what kind of proteins you will come across. And this is a good information for pharmaceuticals companies, because that will help them in coming up with strategies. There are two features. We are talking about aromaticity, isoelectric point. This is a very important thing when you are talking about the function or the features, the structural functional aspect of a protein. These are very important. So this will also help in getting a potential pharma target. Comparative, when we compared COVID-19 with SARS and MERS, we know that SARS or the COVID-19 resembles SARS more than MERS. So that information is also an important aspect. And I've given some in references. This you can, there's no need for you, if you want to really get into a project where you want to look at uh, uh, when you want to do some kind of investigation, when you want to start something on your own, you can collect sequences there are many ways to collect sequences. You can go to 100,000 genome project. So what they have done is they have captured genomes of 100 organisms, and there from there you can get, or you can google national ncbi gene information there also. So whatever genes we have sequenced, they are all put in a repository. It's an open source repository. So that helps that for the researchers to know what kind of research is happening, what are the sequences done, and that helps in furthering the research. So the whole idea is I wanted to show you that you can start with DNA sequence, and you can derive so many things, so many aspects of it, which you can glean lot of insights just looking at the sequence, DNA sequence, using BioPython. You can actually you can So that's it for today. This is what I wanted to cover in my workshop. I hope it has helped you. And that's it. I just wanted to share.
Ma'am, are you done or is there anything else left?
Yeah. I just wanted to show this research paper which appeared where from where I have taken the coronavirus sequence. Right. That's it. I've covered everything. Thank you. I hope this has helped you all. And if you
Thank you.
yeah. Thank you.
Thank you, ma'am. Thank you so much. That was really insightful.
Yeah.
And there are a
You're
couple of
welcome.
comments, ma'am. We'll be posting them in the comment section below, and you can answer them at your convenience.
Okay, sure. Okay. Thank you.
Okay. Okay. Thank you. Thank you. Thank you so much.
Yeah.
Okay. Moving forward, we've got our last two keynote speakers of today. That is Dr. Kian Lin and Jerry Culp. And today they're going to be talking about machine learning at edge.
Hello and welcome. Thank you for joining us today. My name is Jerry Culp, and I'm the head of Data Science and Edge in the Advanced Compute and Solutions Group at HP. I'm joined today by my colleague, Chin Lin, who is an HP Fellow in HP Labs as well. So we're excited to be here today to bring you a session to talk about the innovation that's happening with data and computing in the industry that's leading to machine learning at the edge. So today what we're going to cover is the rise of edge computing, why that's happening, and then use cases around print quality. So what is the edge and what does it look like? If you look at all of these images, these are the edge for somebody, whether it's an autonomous car, a factory, a cell tower. These are all instances of edge for someone. So how do we define it? We are looking at edge as having computing close to the source so that it overcomes some of the pain points around latency and bandwidth. Now I'd like to take you through some of the trends that are happening that is driving machine learning to the edge. So the first is around hardware and Moore's law. So CPUs has been generating a lot of compute capability over the years. We saw lots of increases with core counts and frequencies, but now we're seeing a leveling off of that due to Moore's law, and in conjunction with that, we're seeing less ability to handle bigger workloads due to serial processing. This has led to the rise of the GPU and its parallel processing and its many thousands of core counts. This has enabled additional workloads and additional amounts of data to be processed for new capabilities. When we look at software, there's been a similar disruption that's been happening. Traditionally, we've seen applications being developed as monolithic apps, but now we're seeing a transition into supporting cloud-native software capabilities as well. These are things like microservices and serverless functions that really support being able to do distributed computing at the edge. The last disruption that we've been seeing is around data science itself. with all of the data, we've seen an explosion with AI and analytics that's been happening to be able to support many new use cases and many new industries in the market. But they have created some considerations that we have to take into account. So if we look at the considerations, there's 4 major considerations that we have to take into account. That is bandwidth, latency, criticality, and security. So I'll walk through each of these and give you an idea of what these are so that you better understand how they impact the edge computing. The first one is bandwidth. We have seen a huge explosion of data. And part of the reason of this is the number of IoT devices that has been increasing over time. So if you look at the graph on the page, each of the bars shows the amount of data that we are creating in the world. And if you can look at the very bottom, there's a dark blue line in all of those. That is the available bandwidth that we can get the data to the cloud. So as you can see, over time, we're creating huge amounts of data that are getting trapped at the edge and that we cannot get to the cloud if that's where we're doing our processing. So we need to figure out how we're going to manage this data problem that's getting trapped at the edge. The other consideration around bandwidth is the fact that when you look at the amount of energy it takes to be able to get the data to the cloud, we actually need more energy than we physically produce in the world to be able to do that. So it's yet another indication of how data is growing at such a rate that we need to find new compute methods to be able to deal with it. The next consideration is around latency. And we're seeing a huge increase in the interaction between people, things, and data. And a lot of these need real-time interaction. So if you look at an autonomous car, there's a lot of capabilities in that car that cannot afford latency in order to be able to do its job. If I want to brake, I need the braking to happen now. I can't afford latency in being able to process when that needs to happen. The other thing that's driving latency is the number of IoT devices. So one camera can probably stream pretty easily and still use the cloud for its processing. But as we increase the number of IoT devices and the number of cameras, you cannot take that amount of streams and take it to the cloud and be able to account for the latency depending on what you're trying to do. So these are indications that from a latency standpoint, we need to be thinking about new compute as well. The third area is around criticality, and this is our ability to not have issues when networks go down. For example, if I have a store that is run autonomously, that I can have frictionless checkout, and the network goes down and I'm utilizing the cloud, I can either no longer process orders or people are in the store and I'm no longer tracking what they're purchasing. So that can be a huge financial hit to stores if that is how they're managing it. Another one could be a factory. Factories rely on keeping the lines running. And if the lines go down because I'm trying to process and understand what the quality is on my line, then I'm actually losing money because my line is down. Or I'm suffering larger yield issues because I'm putting out products that have issues. Another instance could be MRIs. So in healthcare situations where there's criticality to being able to manage the patient data and the criticality of it, if we have the network go down and that's a reliance, then we run into issues with, it could cost life for customers. The fourth area is around security, and there's a number of those as well. So one could be customer information. When I am working with customers and they are entrusting me with their data, if I don't keep it safe and private, then I'm violating that trust. And so there's a huge need to be able to protect that. You could also look at patient data for healthcare. That is an area where we need to keep that private as well. So we have to be very secure with it. We also have instances where it could be IP. So let's say a broadcast company is creating a new movie and they don't want it to leak. They're very proprietary about that IP, and so they want that protected as well. So we have to look at security as well and where the best security is when you're looking at edge versus cloud computing. So let's talk a little bit about some of the use cases around edge computing. The first is factory. This is probably the largest growing segment when you're looking at edge computing, and there are a number of instances where we can use this. We can look at it from a quality perspective with inspection. Industrial printing is another instance, predictive analytics, and workforce automation. So those are some of the areas, and there's lots more in there as well, and that's why manufacturing is growing so rapidly. The next one is around retail. The whole stores are getting digitized at this point. So it could be that I am tracking customers walking the store, and I am going to use that information to determine what's the best layout for my store, what's the best place to put a sale item in the store. There's also the loss prevention, so I can track what's happening in the store and whether I'm seeing a loss through theft, as well as frictionless checkout, which I mentioned earlier. Another one is smart cities. We are seeing an explosive growth of use cases within smart cities. This can be in traffic flow, it can be in public transit. There are many, many use cases where being able to compute at the edge and access and analyze the data right there is becoming very, very important. And the fourth area is around healthcare. There's a number of use cases in healthcare, whether it is patient monitoring, patient fall detection, leveraging home healthcare. This is an area that will be more and more important, and we're seeing a lot now with the current economic issues that we're going through. So these are 4 examples of use cases that are key to the edge, and there are many, many more that are being created. And so now I'll transition to my colleague, Chin Lin, and she will talk through some print quality use cases.
Hello. So I'm going to talk about some of the print quality use cases. So here's an example use case. What we want to be able to do is to automate print quality assessment. So imagine you have a print factory and lots of things gets printed, and you have to check whether the printout has good quality or not. And if it's not good quality, you have to address it and then correct it before you send the print output to your customers. And a lot of this used to be done manually. People use a loop to look at print quality closely and make sure they satisfy the quality standard. And so during the printer design process, the printers are tested very, very heavily. And so here you see a row of printers, and we are going through the testing process. And all the printers print out a lot of test charts, and we use this to do a lot of, for example, life cycle testing or testing of how printers operate at different environments, temperature, humidity, and so on. And you can see here a imaging system with classical computer vision in operation that goes around and scans the page and analyzes the page to measure the print quality. Now, this works very well with simple test patterns, such as the one you see that's printed on this page. However, if we go into a print factory, the printer will be printing customer content, and it will be much, much more complicated. And if there's a print quality issue, the print quality issue will happen on the customer pages. So how do we find the print quality problems in actual print factories when when the customers are printing and we don't know the printing content, and it's not a very simple test pattern. So that's what I'm going to talk about next, is about the research we're doing in HP Labs to address this kind of situation. So, so I'll start with talking about artificial intelligence. And so artificial intelligence is really the development of computer systems that's able to perform tasks that normally require human intelligence. Examples are visual perception, speech recognition, decision-making, translation between different languages. These are characteristics that's associated with human intelligence. And there's a big growth opportunity in terms of technology advancement, and computers powered by new machine learning algorithms are trying to address some of this. And we have seen a lot of demonstration of this. And Jerry mentioned a number of the use cases, such as autonomous cars, that heavily rely on artificial intelligence to interpret the images and being able to take action in real time. And so what's really changed in the development of artificial intelligence, which started in the early 1980s, is really the breakthrough in deep learning, which happened less than 10 years ago. And so deep learning is really causing the new explosion of AI technologies and applications. So, so the success of deep learning is really driven by advances in 3 key areas. The first one is a large-scale data set from the web and the social network. And the test data, the training, the data to train a neural network used to be in the order of thousands. And it went from thousands to millions. And this kind of dramatic growth of training data from the web and social network is really driving a lot of the advances in convolutional neural network development. The second one is better network models. Here we see a very, very complex network structure with convolutional layers, with pooling layers, and with nonlinear ReLU functions. And these all function together to be able to interpret the images better, and then being able to figure out the semantic meaning of the images. And the last one is really much more powerful GPUs. And all this enabled the integrated feature learning and the classifier design. So if we look at traditional computer vision, the way it works is that it has 2 stages. It has a feature computation stage, and it has a classification stage. The features are engineered by human designers, and the classification is done with traditional machine learning techniques. So some of the examples of features commonly used in computer vision are, for example, LBP, the ball, SIFT, and the SURF. And after the features are computed, then we use machine learning to make decisions based on these features. And some of the common algorithms used for machine learning is, for example, SVM, cascade classifiers, random forest. And this works when the amount of training data is small and the situation is simple. However, the accuracy does not improve significantly when large amount of training data is available. So, so this is an example of we are using the traditional approach to do face detector. And so on the right, you can see a number of human engineered features. And these features are computed at various scales at each patch locations. And then there's a cascade classifier that's used to reject non-phase regions. And that's how the phase is detected in an image. Now, if we look at the deep learning approach, the deep learning approach really use integrated feature learning and classifiers. So you see on the left of the block diagram, you see the feature representation. So these are learned features. And then the feature classification is also integrated into the network. And both blocks together, they are commonly referred to as convolutional neural network. And so when we do the training, we give it the image, we propagate it through the network, and then we come up with a label. And then we compare the label with a ground truth label to find an error. And then this error is back propagated through algorithms such as gradient descent. And so those will be used to adjust the weights so that the overall error can be reduced. And this process is repeated many, many times until the entire system converges. And that's when we say a convolutional neural network is trained. So so if we look at some of the feature representations, for example, you will see usually the first layer and the second layers from natural images, and it will start to pick up, for example, edgelets. And then if we train the network with face images, then the second and the third layer will start to show features from the face. And then on the other hand, if we use car as a training image, then the second layer and the third layer, you will start to see features of the car. And so that really shows the network is learning to differentiate this type of objects. Now, how do we apply this kind of theory to print quality assessment and characterize print defect? So our objective is to be able to generate a print defect map with pixel level accuracy. And so what are the challenges? The challenge is that we are really lacking of precisely annotated image data for training. And so here you can, for example, see some of the common artifacts we encounter in the printing applications. We see the streaks, we see the bending, we see the spot, and then there's also die-to-die inconsistencies, and we see that as kind of vertical variations. And so let's take streaks, for example. You see that in order to annotate this data, we have to essentially mark all the black spots. And this is extremely difficult to do. It's not like a natural object, like a cow, and we can clearly see the boundaries of the cow. The streaks, on the other hand, doesn't really have very clear boundaries. And if we want to mark all the pixels that are considered streaks, it's extremely time consuming. So how do we solve this problem? We solve this problem with simulated artifacts for training data. And then we evaluate our network that's trained with real artifacts imprinted and scanned images as a test data to essentially see how the network is doing to address the real world applications. Here are some of the examples of synthetic data and how we use it to train, to simulate defects. And on the left, we show an example of using a mathematical function to represent the dark streaks, and then we apply it to the color image. And on the right, we show an example of the banding, how we can model the banding defect with a mathematical function, and how it will show up in the training image example that we simulated. And so then we also need to simulate the print scan effect. On the left is a digital image that we're sending it to the printer. And on the right is a printed out. And usually, because of the printing process and the characteristics of the printing inks, the image that come out would look a little bit different from the digital image. And we need to model this process so that we can simulate realistic images that looks like it's printed. And so then the training pipeline looks like this then. We have the background image, and we have a database of images for doing this training. And then we add synthetic defects into these training images. And then we do resize and crop. And then we add the print scan effect. And then we do data augmentation. So for example, we can do rotation augmentation. And then we apply it to train a semantic segmentation network. So here is how we are doing it. So on the left, you see the printed RGB image, and that's essentially the simulated one. And then we sometimes also add a original RGB image as input as well. And then we use a ResNet 50 backbone. And then we use an ASPP network, and then we use a decoder. So this is essentially the DeepLab V3 Plus network. And then we train it with the printed data. And DeepLab V3 Plus is a very popular network that's originally published by Google. And so we use that to train the network for print defect mapping. And so once the network is trained, then we can run through with actual printed RGB images in the inferencing stage to essentially detect the presence of defects and generate a print defect map. We have tested two types of inferencing strategies. One is to resize the image, and the second one is patch-based. So in resized image, essentially we shrink the high-resolution scanned image, and we resize it to a much smaller image, and then we detect the defect map. And in the second case, we essentially do a lot of crops of the original high-resolution image, and then we analyze each crop, and then we piece together back the original defect map. And second one, the approach is patch-based, is much more time-consuming, as you can imagine. And but we are observing increased accuracy. So this is our result, and we see the streaks and the banding mapping with real data. And so we actually painfully annotated some of the real data, and then we compared 4 scenarios. The first one is no reference. The second one is full reference, both with resized images. And then we do the same thing for the patch-based full reference and the no reference. And then we analyze the intersection over union, and then we analyze the time that's spent for each of the scenarios. And as you can see, when we have the resized image, the time is actually very fast, 1.7 seconds to do the inferencing. When we have the patch-based, the time is takes much longer, about 18 to 20 seconds. And if we look at the accuracy, the patch-based is slightly more accurate. One of the surprising findings for us is when we compare the no reference versus full reference, the no reference actually performs better. So, so this is a little bit counterintuitive, and we believe that it's possibly caused by the mismatch in the actual printed characteristics between the digital image and the printed image. And so if that kind of mapping is not very precise, then the adding the original digital image to the network doesn't really help the performance. Here are some of the examples of real samples. Visually, we can see how we are doing in terms of doing the banding detection. So on the left is the reference image. This is a digital image, and the next one is the printed image, and you can see clear banding visibility, and then the third one is the ground truth. So this is a person looking at the printed image and essentially mark down all the samples that are pixels that consider banding, and the last image shows our result where we can detect most of the banding very accurately. Here is another example with spots. So here you can see some of the spots on the left, and notice that they are actually very faint, and it's the edge of this spot is not very clearly defined. It's very fuzzy. And so if we use a classical computer vision algorithm, it will be very, very difficult to detect this kind of spots, because the a lot of the classical computer vision relies on, for example, detecting the edges or doing the color threshold. So when the spot is very faint and there's no clear edges, it's very difficult to detect this kind of spots with classical computer vision. And with deep learning, because we are really trained the network with a lot of sample images like this, we can now really pick them up and then detect them successfully. This is an example of we are trying to map the die-to-die transition. And we are using segmentation and post-processing. The die-to-die transition happens when you have print pens that stitch together to form a very, very wide print swath for very, very high-speed industrial printing. So, for example, the web press. And because on each of the print cartridge, there are multiple semiconductor chips with print nozzles, And then there are many print pens that are laid down in parallel to do to increase the print walls. We sometimes see this if the printer is not calibrated well, we will see this kind of variations from the die-to-die process. And so we want to be able to detect this kind of variations. And so based on the left original image, we can mark down this and essentially detect and mark down the lines that human observers see, and that's the ground truth. And then the third image is the segmentation result. And the interesting thing you see is that the human eyes are actually not very accurate at picking up the boundaries. So you can see the segmentation result, actually we are able to detect at much more regular intervals, which is really the cartridge to cartridge kind of or die to die transitions, and being able to pick that up. And then if we do post processing, then we can define the boundary areas very accurately. And based on this information, then we can essentially dynamically compensate for the for this kind of variation, so that the printer can print out perfect images. So in summary, Jerry and I covered in this presentation why the real-time analysis of images is a very important use case for edge computing. We did a deep dive of training convolutional neural networks for print quality analysis with simulated data. And what we show is that for optimal results, we really believe that a combination of simulated data and annotated real data can be used. That concludes our presentation.
Thank you.
Thank you so much, ma'am. That was an amazing session. And thank you so much to one and all. With that, finally, the month-long event of WIDS has concluded. So many positives and insightful takeaways from the events. On a personal note, I've learned so much from all of the wonderful speakers over the past 1 month. These were such empowered women who have reached great heights, breaking off all social norms and barriers, and today have become huge inspirations to many other people. More power to all of you wonderful speakers, and may you all reach greater heights in the coming future. On that note, I would also like to extend my heartfelt thanks to the audience who have backed us throughout this month-long mega event, without who this wouldn't have been such a huge success. Next, I would also like to thank Usha ma'am, without whom merely any of this would have been possible. You have, time in and time out, you have always made me look up to you, ma'am, in so many aspects. The number of things you manage to pull off on a daily basis is something astounding, and you have truly made the younger generation and people like us redefine our boundaries and constantly push us forward. Lastly, I would also like to thank our sponsors and all of my fellow core team members who have worked so hard over the past 1 month, ensuring the smooth conduct of these events. Kudos, guys. Thank you. Thank you so much. And now we've also got a couple of our core team members who want to share their experience over the past few months, how it's been working for WiMLDS.
Hello, I'm Harshita. I'm an engineering student from Bangalore. Volunteering for Women in Data Science Mysore has been a great experience for me. I got to meet a lot of new people, interact with them, know their stories, learn from them. The core team was the best. I had a lot of fun, and yeah, there was a lot of learning too. All our decision making, leadership, communication skills were put to use. And these speakers, they are amazing people. All the speakers, um, their sessions were very knowledgeable. And being volunteers, we also got to interact with them personally and know their stories and get inspired. So overall, it has been a fantastic experience, and I'm looking forward for more. Thank you.
Everyone, I am Shrishti and I'm currently pursuing my BE from SJCID. And talking about WITS, I've been a part of WITS for 3-4 months now, and it has been a wonderful journey. It's been really inspiring and motivating to listen to all these amazing women and see them work so hard to reduce the gender gap in technology. And this really pushes us to give our best. So, thank you to all of you. Talking about our core team members, it was an amazing team, and from marketing to designing posters to doing the dummy testing to the last minute changes, we have done it all. And thank you to all of you for being amazing at what you do. It's an experience worth remembering. Not to forget Usha ma'am, who is an inspiration herself, and she's the backbone, and she worked really hard to make all these events a success. She's been really supportive throughout the process, which made our work easier. And so, thank you, ma'am, and thank you to all of you for coming here each week and trying to learn something new. So, thank you, everyone.
Okay. So, hey guys, this is Shashank here again. And even I'm here to share my experience over the past couple of months. And I joined WiMLDS and GDG at around July. And since then, it's been right from day one till this date, it's always been very insightful. So many positives and so many takeaways that I get to learn on a day-to-day basis what happens in this group. And talking about the core team, all of my fellow peers from different colleges and various places all over Mysore are constantly a source of motivation. They keep pushing me forward and keep helping me redefine my boundaries. And also talking about Usha ma'am, she has always been a constant source of motivation and inspiration as well. Constantly, she makes us look up to her. And two of the major things that I've learned over the past couple of months and that have really helped me grow as a person is, number one is how to work under pressure. So this has been such a major event that we've conducted in the past 1 month, and it involves so many people and so many top level speakers who have been a part of this event, and dealing with them, pulling off last minute stuff, and just working on a day-to-day basis on this event has given me such a good foresight about how to work under pressure. And number two is networking. It has made me develop such good contacts, and I've made a lot of other new friends from whom also I can learn a lot, and even I try to give them the best that I can. So this has been my experience, and I'm also looking forward to working much more and growing a lot as a person and helping WiMLDS and GDG also grow a lot. Thank you. Over to you, Nitya.
Hello everyone, I am Nitya, and right now I'm doing my second year from NIE in Information Science and Engineering, and I joined WiMLDS core team about in July. It's just been 2 or 3 months, but I have to say that it's been a great journey so far. It's amazing working with this core team because everyone is so nice and they're compassionate and they're very passionate about what they do. And not only as seniors, not only they are helpful, they genuinely guide you and tell you what to do next, not only in terms of work in the core team, but also in life. So that's been a great influence on me. And secondly, we do so many dry runs. We connect with over this in this event, we connected to over 100 gorgeous, inspirational women, and it's been inspiring not only for me, but I think for everyone else, because when we do their dry run and we connect to them on a more individual and personal basis, we feel nice because and we get inspired because they're doing such amazing work in a sort of a male-dominated part of the society. Technology till right now has been pretty much male-dominated, and it gives me, and I think a lot of women, hope that technology is for everyone, and we can move forward. And we, there will be a time where women will be dominating the technology industry probably. So that is one of the most. It's the biggest takeaway for me. For this event. And not to mention, I can't forget to mention Usha ma'am. And I have to say this because Usha ma'am juggles a lot of things together. She's conducting workshops, she's conducting these this month-long event, and other than that, she has her own work to do. And somehow she manages to conduct everything and do everything so meticulously and so nicely, and that definitely is something that we all look up to. She's meticulous in the work she does, and she's pretty much an inspiration, and she's kind, she's sweet, she's one of the best mentors, one of the best leaders that we could have today. So thank you so much, ma'am, for guiding us, and thank you for letting me be a part of this. And so now I'll be starting with the closing note for today. So it's been a month-long celebration of women doing great work in data science, and WiDS Mysuru being the biggest ever regional event in the world, hosting around 100+ speakers across multiple geographies and multiple domains over 9 days. It's a proud moment for all of us. We would like to thank all the faculties and the management of NIE Mysuru, GSS, GSSS, and VVCE for extending full support and helping us organize this event seamlessly. We also thank our distinguished speakers who have taken time off their busy schedule and agreed to be part of this event. Finally, we would like to thank the entire WiDS Mysuru team who has worked hard to pull off this never seen ever before landmark event. We will be back again next year, giving another such memorable event. Finally, we would like to thank all our audience who have supported us and made this event a huge success. Thank you on behalf of the entire WiDS Mysuru team. Shashank, over to you. Would you like to say something?
Yeah, that's pretty much it. Once again, I would just like to thank all of the audience, my core team members, and all of the wonderful speakers who've been part of this event. And wishing you all all the very best, and looking forward to connecting with all of you as soon as possible. Thank you. Thank you so much.